depot in North America, and then you start to imagine for a sec, I got to figure chargers, I got to retrain my workforce, I got different driver dynamics, got maintenance issues, where am I getting all this power? In reality, the bus is kind of the easy part, and we can debate about range and charging strategies, but it's really coming today head on, but we got to figure out how to get the politicians to understand it isn't that simple, and I feel for the operators who today have the pressure on them. So the political drive's active, it's strong, but at the end of the day, we've got to figure out how to play inside that world, which means that our product development initiatives need to be, we think, variable and agnostic. We need to be able to go to an operator over the next 15 or 20 years and say, your situation is different, and you need to help us help you in terms of migrating to truly all electric, which maybe means a platform that has different propulsion systems in the medium term as we walk through and ultimately get to that, at the whole while figuring out what those skills need to be inside the transit agencies. And so that's what we focused our new product development on, which is proven platforms, because the bus has to friggin' work. It's got to start every day, it's got to finish its routes, it's got to be on time and so forth. And somebody told me years ago that bus rapid transit, BRT, should actually stand for bus reliable transit, because the bus has got to be at that stop when we said it would be at that stop. And that's as much us as a manufacturer and a supporter as it is on the transit agency and the relationship with the cities. So we've chosen to take that multi-propulsion agnostic approach, whether it's hydrogen fuel cells or battery electric or trolleys or whatever, to try and figure out how to work with our operators to migrate from conventional fleets. Yeah, but one thing's for sure, and many of you know this way better than we do, one size does not fit all. And that's the other beef I have a little bit with the political environment, that it's easy to say, I'm going to put electric bus on my route. Just one example, we've got a project in one place that have chargers on two ends of the routes, and there's 5 buses going all day long, and the buses go 2.9 to 3.9 miles an hour. 65% of the energy off those batteries is to heat and cool the bus. It's got nothing to do with moving the bus. Whereas, the first thing I'm going to talk to somebody, they say, well, what's your range? Well, my range, what's the battery dynamic? How do you want to charge it? What's your operating environment? How hot or cold it is? Is there hills? Is there, blah, blah, blah. And so one size clearly does not fit all. Which then leads us to this dynamic that things we never thought about before had to be involved with as a bus manufacturer. And that's this continued innovation outside the bus, but also the advocacy, because we find ourselves trying to educate and communicate as much as more than we ever did. And we now have to hire consultants and lobbyists and whatever, not only for us to work with our agencies, but also to help the political dynamic knit it together. And then there's this dynamic of alignment of goals. It's no longer responding to an RFP, how many buses and what do you want the seat layout. It's this continued alignment and operation and discussion with our transit agencies. And so our issue, 10 years ago, quite honestly, I used to say at our leadership camps, is I don't want to become a typewriter. Typewriters were a phenomenal innovation, but they're all gone. And so we got to figure out how to evolve, because fax machines and handwritten was replaced by typewriters, by fax machines, by computers, by now mobile devices, and so on and so forth. We got to figure out how not to make buses into typewriters. And so our priority at the end of the day then was to try and be active in the paradigm shift, not be a victim of it. And so we were pretty comfortable and confident as the first OEM to sign on to the shared mobility principles, something that was created by Robin Chase, a founder of Zipcar. And his whole vision was these principles around advocating for shared fleets, connected zero-emission vehicles, and autonomous driving features. Not rocket scientist stuff, but we think he kind of put it out there to say, get on board with the shared dynamic and this mobility principles. And so a couple of things that we've tried to do. First of all, we've tried to lead, and we've had a good degree of success, and we'll take a lot of the credit, but I think our competitors as well, that we got to find how to get interoperability of EV chargers. Nobody wants the Betamax versus VHS dynamic that, oh shoot, I bought the wrong one. And so as much as we'd love to have a mousetrap that customer can only deal with us, it's got to be interoperable. And so we worked very aggressively with transit operators, industry associations, third parties, and quite candidly with our competitors to find a way to get the standards in place that they're interoperable. And you know what, selfishly I'm a businessman, but quite honestly, like you, I'm a taxpayer. And this is at the end of the day, has to be the best way. Just like we put diesel in every different type of vehicle, we got to be able to put electricity in any vehicle and let the best man or best person win in the long term. So we've added a lot of resources in our business, and it hurts the cost base, no question, around infrastructure and so forth to try and launch and participate in that place. And as a publicly traded company, that's difficult, but it's the right thing to do long term. So we built a technology roadmap. It's a cool picture, but it's not really all that eloquent. And really what it says, no surprise, we got to find to be a leader in the zero emissions, but the zero emission vehicle has to be tied to that infrastructure strategy. On the bottom left, we got to find a way to make that bus really smart. Now, I came from an aerospace environment where the airplane was moving. There was an issue with the engine. Before the airplane landed, there was a strategy how to fix it. And when I joined our industry 10 years ago, I kind of, holy smokes, we got this vehicle that doesn't talk to anything. Hell, my mother, she passed away a couple months ago, her fridge from GE had more telematics than our bus did 10 years ago. We got to find a way that data isn't your data or our data, it's the data, and we're operating together to use that data to manage, operate, upgrade, efficiently utilize the fleet. And so we're pretty excited about the work that we've done there. Top right, I don't think we're going to find driverless buses on the road any day soon. Someday we'll see that. There's a public safety issue. There's a profile issue. You guys know this. Anybody that's in a transit agency, there's an issue with a bus that's on the front page of the Sun the next day, which is unfortunate, but the reality. And so we've got a risk-averse environment. Having said that, if we could find a way to get all that stuff that's happening in other worlds in our world, and some of you are involved in projects. Imagine the bus shows up at a depot and the driver gets out and the bus goes to the wash and it goes to the whatever and it parks itself without driverless. Imagine the efficiency and the safety and the density of the lot and all those things, the savings as a taxpayer. And so we're really aggressively working on it. And then the other issue, quite honestly, is again, we fundamentally believe it's an evolution, not a revolution. Nobody's going to convert their fleet tomorrow from diesel or natural gas to electric and say, ta-da, I'm done. It's going to happen in 15 and 20 years. And so we got to figure out how to evolve with our customers as they evolve. So the changing paradigm, we've learned a couple things. The first thing is the scalability of EVs is well beyond just the vehicle. I mean, we can change the quantity of batteries and we can try and add more this and try and do it, but it's that whole charging infrastructure that I think the funding of it and the pace of implementation and the reality relative to how you get power and what you pay for it and all those things is a big deal. So it's got to be a solution. Two, there's going to be a lot more. We already see it today. You see it. I think there's a couple examples in Canada, maybe in the US, where you go into one app and you pick your Uber and then you pick your transit and then you pick your Uber on the other end or your Lyft and whatever. And so this issue of intermodal planning and all the tools that somebody would think of independently have to be an integrated system. When it comes to autonomous driving, I don't think it's going to be the technology that's going to hold us back. Quite honestly, we believe it's regulation, certification, and insurance that's going to pace a lot of that stuff, which is why what we've chose to do is to partner with a company that's involved in military environments. And the military can put whatever they want on their own roads and their own depots and their own bases. And so by teaming with a military guy that's experienced with autonomous vehicles with tanks and trucks and equipment and so forth, we can test our vehicles in an environment that's protected from the public. So we think we got a bit of a learning curve opportunity there. And finally, the funding models are going to have to change. The days of, in the US, 20% comes from the local and 80 comes from the FTA, or in Canada, driven by municipalities with some federal funding. Figuring out how to get a more expensive bus that has better life cycle dynamics are different colors of money. And as we all know, the colors of money, a capital budget and a maintenance budget and a fuel budget doesn't move easily. So there's a political and a bureaucratic dynamic. The other issue is you got different levels of government. What comes from the local to the province or the state or the feds doesn't move. And so it's a completely different dynamic. So we think we're going to find ourselves into public-private partnerships that we've seen in rail or subway or LRT, where this crazy little bus guy wanting to sell you my bus and how many do you want, what color, now has to have a very different balance sheet and a very different relationship with the customer, where we got skin in the game now. We don't just hand you the bus and then wait for the phone to ring. Either you got a bus broke, you need service, you need spare parts to help you. At the end of the day, everything we think is going to have to change around that dynamic. So looking for a quote, I came across Bill and Ted's Excellent Adventure, probably the worst movie in the late 80s. It's kind of interesting when you look at sarcasm, but I can't remember if it was Bill or Ted, but everything's different but the same. We got to move people. It's a bus. Things are modern than before, no doubt. Everything about that bus is different. How we count people, how we move it, how we charge it, how we communicate with it. And things are bigger and yet smaller. And so, just for fun, thinking about this crazy quote, and you think about the skills we have to have. I just think about our own business. We can't hire enough electrical engineers. We can't train or hire enough people on the shop floor that know how to deal with, high voltage on a production line, and the next bus is a diesel and a hybrid, and the complexities and so forth are massive. Now think about that transit depot that's got 5 or 7 or 10, and you got a whole different set of skill sets, and now you need computers, less wrenches, and you need to change the money dynamic and the funding dynamic. And so I think there's a huge opportunity as we move, if we get aggressive as an industry, that we're going to write the script on job creation as opposed to be victims of it. The problem, again, is we got to figure out how the math works, which then means public-private partnerships not only is around physical buildings or buses, it's around that skills transfer and coordination and funding, which means it's all levels of government, all types of business, and it's our customers working together with us, as opposed to, again, hand off a bus and the transit agency manages that bus. And so I think there's all kinds of stuff in here that's going to do a great job for that skill development and, of course, the creation. Now, in our world, it's no secret, because U.S. is 10 times the size of us, on a transit basis at least, most of our customers, 90% of our transit business in the United States. And so what we're trying to do here in Canada is we're trying to keep the brainy jobs here. The people that do the designing, the engineering, the integration, the new product development, the contract management, the sourcing, and so on and so forth. As best we can become that economic engine around intellectual property and real know-how. And unfortunately, I get it, U.S. taxpayer dollars, we're going to be in an environment where there's lots of the wrench turning that may have to happen south of the border. The cool part is most of the North American leaders in transit buses and motor coach are Canadian companies. And so we got a really neat opportunity. So, in closing, the transformative initiatives to build livable cities combined with climate change strategies really does mean that zero-emission buses and technology and infrastructure are part of that shared infrastructure dynamic and shared mobility going forward. And as I said before, I think our job is our business is going to fundamentally change. We got to figure out how to integrate partnerships, not just sell stuff. And we have to take on a certain level of risk with our customers and, quite honestly, with our communities. And the goal needs to figure out how do we align objective, not how to make more profit on a bus up front or more profit on the parts downstream, but over the life cycle, how do we exist with our stakeholders, and how does our transportation partners and our communities exist? I'd say it's a really exciting time. At the last APTA show, the big transit agency in the United States, the chairman of APTA, the president, said, of the 100 years of public transit, the next 10 are going to be unbelievably quick and unbelievably challenging, more than they've ever been at the pace of change that we're going to have to deal with. So thanks for the opportunity to share a few thoughts. Sorry about my inability to get the presentation in advance so they could test it. Welcome to Winnipeg. Welcome to this wonderful first ever low carbon smart mobility initiative. Welcome to the mobility paradigm shift. I would suggest we all fasten our seatbelts, keep our hands in vehicles at all time, because it's going to be a pretty wild ride over the next couple of years. The good news is we're here to make it happen. So thanks very much.
All right, so as part of taking responsibility for my generation, I take responsibility for this semi-autonomous clicker that seemed to have worked against you. My apologies. Hopefully we can sort that out. And Paul, we are a little bit behind, but we're going to catch up per classic Cutric style. Since I've got you on the stage, and I'm going to look at Lindy to see if I can get the nod, can I ask you an impromptu question on behalf of the audience? I think, so I teach a course in globalization economics. It's my area of specialization, and every year there's just a lot of interesting dynamic things in the last 5 years in terms of the new NAFTA, new tariffs, what the pricing points are going to be. So we're living in a world now in North America where post-new NAFTA dialogues, we've got this extraordinary round of tariffs that have started to have an effect on manufacturing. And unless all parts in new flyer buses are made in North America, there's going to be a price impact. does it just mean that we're about to face really, really a lot more expensive transit systems? And buying buses and buying services is just going to get a lot more expensive now for the cities in the next 2 to 3 years?
Well, you got to dig a little bit deeper. The reality is 90% of our business, our industry is in the United States. Buy America requires that we make now, or 70% of the material content comes from the United States. So the vast majority of ours and our competitor supply chain is US oriented. Some of the tariffs may be in raw input costs that come into the United States, and so there may be some issues there. The reality of it is we got to find a way with our suppliers to make those buses cheaper. And so how we source, and in our case, we've chosen to build some of our own components to bring the cost down, rather than sourcing it, shipping it, packaging it, unpacking it, it's broken, get another one, handling it. We're making a part and putting it on a bus, and so we're trying to find a way to bring that whole thing down. I do believe, though, that there's a fundamental shift in that instead of buy a bus and then a life cycle cost, you're going to have less life cycle costs, but the bus up front is going to be different, which goes back to it's not a cost issue, it's a financing or a timing issue, and then the colors of money, which means the economic model needs to change. So tariffs are real, even just the Canadian-U.S. steel tariffs and the countervailing duties and all those dynamics. There is some pressure, no question. But pressure's on us because at the end of the day, it's not a commercial business that will, handle and negotiate that. It's taxpayer money, so the visibility is very, very high. It's real and it's an issue. The other issue, quite honestly, is the battery component is getting, a material portion of the bus. The cost of the batteries, the energy density, the range per kilowatt hour, and so forth is coming down. We got to figure out how to not only ride but drive that wave so that we bring the cost down.
That's fantastic. So we impromptu fireside chat here with Paul Soubry. I think it's helped us to understand that financial innovation has to come hand in hand with political innovation on the receiving side. But it also bears well, I think, or rather bodes well for the future, insofar as so many of the parts are manufactured domestically and insofar as cars are really not. Yes. We do face a future where cars are going to get more expensive right now, and it looks like the busing industry, at least according to one of the best experts in the industry, is going to stay solid and solidly cheap. So thank you so much, Paul, for that fantastic introduction and opening. And as a thank you, we have a little gift for you here. And again, once again, apologies for our technology. We'll sort it out, but thank you so much for being a fantastic welcoming introduction. So with that, we're going to move right into our first panel of the day. And for those of you who are on the panel, I'm going to invite you up here onto the stage. First, I'm going to invite Kirk Burkhardt, Vice President of Engineering Services from New Flyer Industries, John Walsh, Senior Vice President of Sales from Proterra, Ray Little, Vice President of Sales from Nova Bus, Alexandre Lalonde, Product Manager, Heavy Vehicle Charging Infrastructure North America at ABB, and Brian Pollock, Business Development Manager for E-Mobility and Business at Siemens. Welcome to our panel. All right, so we're going to do a little testing on the AV here. And folks, I think if you're using the PowerPoint, I believe you need to click the right-left button. So for panelists on the stage, if you're coming up, just the right-left button, not the up-down, that would be the laser. And hopefully with that guidance, we can sort out some of the issues. All right, so what we're going to do is start right into some of the presentations that each of our panelists have, and then we've got a series of queries, and we're going to move to the audience. So you'll notice that there are 2 microphones in the audience. So there is one right there, and nope, there is one right there in front of me. They're a little bit camouflaged. And what we'll do is encourage you to start thinking about your questions. We've got some time for critical queries with the panelists. And first, I'm going to introduce Kirk Burkhardt as VP of Engineering Services, New Flyer Industry, as a seasoned product engineer with a lot of experience in the automotive and heavy-duty manufacturing sector. Kirk's got 3 decades of experience in this industry, and I added up all of your decades of experience. Alex, you're the only one with an exponentially smaller number. It's 3. The rest of them got 20 to 30, so we've got over 100 years of experience on this panel. If you guys can't figure it out, we're screwed. So basically, with that, I'm going to turn to Kirk Burkhardt for our introductory presentation.
Thank you very much. Okay, let's give this a shot. Okay, good morning, ladies and gentlemen. And it's a pleasure to be here, and thank you very much for welcoming me to Canada's first low-carbon smart mobility conference presented by Cutric. As USIPA introduced me, Kirk Burkhardt, I have the privilege of serving as the Vice President of All Engineering Services for New Flyer. I've been with New Flyer now almost 10 years, And previous to that, I was with General Motors for 19 years. And believe it or not, I think I'm almost embarrassed to say, I actually started with leaded fuel calibrations. But I'm not that old, export markets. So I started with leaded fuel, but as my career grew, I became more and more involved with alternative fuels and alternative energies, and finished working with the Chevy Volt and several different hybrid platforms. So that was a great experience. However, my time with New Flyer has been fantastic, and what always led me to New Flyer was their innovation over time. So as Paul prefaced just a few minutes ago, it's clear we're amid a mobility paradigm shift where the speed of change is second only to the demand for change. As you know, New Flyer has manufactured heavy-duty transit buses for more than 90 years and is North America's largest transit bus manufacturer. What you may not know is our first electric trolley was delivered in 1968. The industry's first diesel-electric bus was delivered by ourselves in 1988, and some of our early fuel cell electric buses go back as far as 1993. So we do have an electric bus history to be proud of, with over 7,300 buses on the road with electric motors, batteries, and high-voltage systems, and 1,600 of those are zero emission. Our first battery electric bus was in 2012, trialed right here in Winnipeg, and by 2017 we had introduced our next-gen electric bus, the OpCharge. So it's very clear. Well, I'll have to keep a close eye on that. Okay, it's very clear we're in a mobility paradigm shift, but we've always led our industry with innovation and technology, and if you rewind to 2010, would we have ever thought we'd become a leading provider of mobility solutions? Would we have anticipated developing and delivering buses, technology, as well as infrastructure? I'd like to think we were technical visionaries at the time, but the honest answer is likely not. We didn't even use the term mobility in 2010. Uber wasn't quite 1 year old, and most of us hadn't even heard of it. That was only 9 years ago, and I know where I was at that time, on the shop floor launching the Excelsior. For us, a new bus, better by design, and intended to be suitable for a wide range of propulsion systems, including battery electric, there we go, there's a delay. Take note, there's a delay. Okay, full battery electric, fuel cell electric, and trolley electric, also known as in-motion charging. Excelsior, now almost 10 years old, a proven reliable platform with the most Altoona tests of any OEM platform and over 1 billion miles in service. Excelsior, familiar to many of you in this room today, is the focal point of a very broad portfolio of zero-emission and low-carbon propulsion offerings. This wasn't a simple evolution of a bus, a platform, or a propulsion technology at all, but as you're aware, both locally and internationally, the driving forces that continue to impact our business aren't really related to the vehicle or vehicle technology. Rather, it was the demand for sustainable mobility in growing cities, as Paul spoke to. Rapid urbanization here and globally is real, and it is a problem. More and more communities will reach megacity status with greater than 10 million inhabitants, and as a result, traffic congestion and pollution are significant. City leaders and communities alike are calling for better solutions to move safely and sustainably through the places they call home. With the drastic impact of climate change becoming increasingly visible and destructive, cities are demanding action, and rightly so, for industry leaders and transit stakeholders to champion urban solutions to mitigate climate change. As a whole, we're experiencing a profound movement to more livable cities, again, as Paul touched upon, and as we look forward to 2020 and beyond, there's still a lot of work to do to make this happen, despite all we've achieved since 2010, alongside industry leaders like Cutric. One example we're very proud of, in addition to some of what Paul touched on, was the opening of our Vehicle Innovation Center in 2017 for the purpose of education and collaboration, with a strong focus on the facts and the future of the transit industry and the mobility paradigm. There we go. Again, as I said, there's still a lot of work to do to navigate through the mobility paradigm to ensure the livable city can happen in our lifetime. Well, I could spend hours reviewing the technical capabilities and advancements of our zero-emission buses. I think the most important element to focus on is not the buses, but rather the technology and the infrastructure, the enablers. Why? We can design and deliver industry-leading buses like our Excelsior Charge or the Charge H2 as seen here, But that's no longer enough. In 2010, I'm not sure we could have appreciated the magnitude of consideration infrastructure needed or would need. So it's hard to imagine today that we have almost 100 depot chargers and en route chargers in process or fully deployed, or will have by the end of year, and that we, as an industry, have standards that allow for full interoperability of all OEMs. Again, both significant and unimaginable back in 2010. However, what we did have enough insight to initiate back in 2011 was our Connect telematics system. Why? Because data helps you make better decisions. As a result, we've developed software algorithms and deployed over-the-air electric bus analytics that help us improve our designs more rapidly, and transit agencies improve their energy use and driver performance using information from systems such as our Connect 360 analytics. Finally, we must also provide full turnkey infrastructure solutions to support the electrification of your fleet, from planning for route and energy optimization to charger installation, and finally commissioning. Essentially, a one-stop shop for all project management and logistics. So where's New Flyer going with cutting-edge electric bus and charging systems in 2020 and beyond? We will continue to tackle a complete and diverse range of smart mobility projects to solve the challenges of the smart city. We believe in a broad, low-carbon propulsion offering and diverse solutions for the complex needs of a very wide range of transit agencies. Many projects are further along, such as the Smart Rider system, using sophisticated chassis control and a fully electric wheelchair ramp. It allows for a much more efficient and easy entry for all passengers. Some projects are still trials at this point in time, such as our efforts with automated vehicles and robotic research. However, we have some very exciting milestones within reach in 2020. Unfortunately, there's more than I can speak to here and more than I can list. Nevertheless, we have a strong vision, a balanced approach, and a plan we're very excited about. At New Flyer, we've always been very proud to move people across North America, and we believe smart mobility is the way of the future. Thank you very much.
And thanks for figuring out the 2-second delay. And so I'll leave it to the rest of you to navigate that 2-second delay. With that, I'm going to introduce John Walsh from Proterra. And we were just having a chit-chat yesterday about the history of electric busing. You've got New Flyer, Nova Bus, Gillig, historically bus makers, or metal benders, as people used to say, that are trying to package electric powertrains underneath a bus that they've made for many years. And then you have BYD and Proterra that are battery electric energy storage makers that are trying to package a bus around an energy storage solution. Two very different pathways, and they're starting to converge. And so with that, John Walsh at Proterra.
So it's here? Okay, I did it on
If I
something.
may, I'm just going to ask, if we don't mind from the AV folks, where is the receptacle in the room? Oh, it's right there, so point at him. Yeah.
All right. Thank you. My name is John Walsh. I'm the Senior Vice President of Proterra, and I've been in the industry for 30 years, all on the supply side, mainly fossil fuel buses. And I want to take you back to Paul's slide that he had up earlier on climate change. I got into this business 30 years ago to sell buses. 8 months ago, I joined Proterra. So I'm very new. If you ask me a hard question, I probably don't have the answer, but I'll get it for you. But one of the pictures that Paul had up there was the state of Florida and a huge hurricane coming at it. And that particular hurricane, Irma, took my home out in St. Augustine, Florida. So climate change is real. And it's not just one hurricane, it's Michael, it's Matthew, it's Irma, and Dorian just came through. So I'm glad to be in this industry. It's an important part of what we do in transportation, and it's affected me personally in my story. So that's my story. So let me tell you Proterra's story. This is a 10-year conversation. Sorry, I'm going to have to take you back to 2004. We started with a grant from the US DOT to manufacture a hydrogen fuel cell bus. And so we were the very first company to ever build a hydrogen fuel cell bus, and we did. That bus today has been donated to the Transit Museum in Pennsylvania. And as we went along and looked at how we scale that technology, we thought, it's not going to scale. It's too expensive. We don't think it's going to scale. We're going to go down the battery electric path, and that's what we've done at Proterra. So we started in 2004. Today, we're in 3 manufacturing facilities, over 400 employees, and guess what? It's no longer a science project. We have 105 customers with 56 deployments in 56 cities. So it's no longer a pilot. It's becoming reality. We have 9.5 million service miles out there, and we have a lot of dedicated employees that have come from different parts of the industry. Transit, automotive, and battery. Yes, we're based in San Francisco, and we do have a lot of employees from Tesla. I'll tell you, it was tough working for Elon, I guess. I don't know. But we're proud of our facility in Burlingame. You should come visit us at any time. We manufacture our own batteries. We do not outsource those at all. We make them robotically in our facility in Burlingame. We have a bus assembly plant in Los Angeles and a bus assembly plant in Greenville, South Carolina, right next to BMW. So what happened? In 2004, we built that first bus, and it was $1.2 million. Today, our bus starts out in the low 700s. So we've reduced the price $500,000 in a matter of 15 years. We started manufacturing buses in 2011, and today, if I can get it to go, you'll see that many, many cities are adopting electric buses. So there are mandates out there. I agree with everything Paul said around these mandates. You can't get there quickly, and you should take your time as a property in doing so. California is probably the largest with their mandate, but New York City, Washington, D.C., Chicago, there's a lot of mandates out there, and some that are also coming to Canada. So as you see the curve, what we believe will happen is fossil fuels will go this way, battery electric will go up. Our customers, yes, there's some dots in Canada. So we have deployments right now in Toronto, Edmonton, and in Banff. We're very proud of that, but we're now over 100 customers, 800 buses in 41 states and provinces. We're very, very pleased with our progress, and there's a whole lot more to come. So our bus. Thanks for that intro. You did a great job. So what have we done? We built batteries. We positioned them underneath the bus, which we believe that's where they belong, and we built a bus around it with a high-voltage system and a process that works very, very well. Our bus is made of all composite. Why? It's strong and it's light, and that's what you need in a battery electric bus. We don't believe in the word agnostic. We don't think you can take a platform and convert it. We believe you have to be purpose-built, starting from the ground up, and that's what we've done at Proterra. We have a single-drive motor. We also have a dual-drive motor. So there's a motor on each wheel, which gives us 510 horsepower, but also gives us double the regeneration for the battery packs. In addition to that, we have adopted the universal charger of 1772 for plug-in charging and 3105 for overhead charging. And we're really pleased with that. It's got to go. Our batteries. This one's going to go a little slow. So we start out with a lithium-ion cell. This is one of those that kind of goes. Then we build into what we call a brick, a block, and a module. And in our battery packs, there's 1,500 modules. And this whole assembly process takes place in Burlingame. So we're proud of these batteries. One thing I will tell you about battery technology, it is improving. And next year, we're coming out with a new cell that will give us even more range than we have today. So we're very pleased with the technology and where it's headed and where we're going. One thing we do at Proterra that we would like to emphasize is testing and safety with our batteries. We think it's very, very important. And this is just some bullet points on thermal runaway, the type of testing that we do, intrusion. We're really proud of what we've accomplished with these packs. This picture I love because I get the question all the time, what are you going to do with these batteries after the bus is expired in 12 years? Well, our battery packs are 98% recyclable. That's important to note, but they're also stackable. So we can stack 9 batteries on top of each other and create a megawatt that we could put at a depot for storage. So our engineers have thought of everything moving forward. Range. I'm going to answer the question just like Paul did on range. I have no idea what the range is at your transit property. We have to come there, and we have a service to do route simulations for you to tell you what the range is in Edmonton, or what the range is in Quebec, or what it is in Vancouver, because it's different in every city. If you've seen one transit authority, you've seen one transit authority. They all act differently. So we have models that we come out and do range. Our packages for batteries are 220 kilowatt, 440, and 660, which is a lot of energy on the bus. Our charging, again, we do overhead and we do plug-in. And I like this bullet at the bottom because even though we have our competitors on our slides, we want you to universally accept battery electric buses and charging. So with our chargers, you can charge Gillig, New Flyer, and Proterra, and you can charge any car except a Tesla, but they do have an adapter. So with the infrastructure that we have, we've now come up with Proterra Energy, which is a brand new company. We make our own charging systems at Proterra, but we also partner with companies in the industry as well. So we have a 60 kilowatt, a 125, and a 500. We also have multi-dispenser as well. And we're just showing you a couple of our deployments that we've had. 105 customers, 56 deployments so far. We have Apex, which is our telematics system. So again, not just having the bus, the battery, and the chargers, we need communication amongst all of those items, and we have that with Apex. This is what a deployment would look like on a large fleet, and we have models to do that currently today. And this is our process that we go through when we engage with a customer. So we've talked about route modeling. Here's an example at RTD, and I'm sure you'll send these out. I'm trying to go quick. We do battery leasing. I've got a session on that at 4:30 today about financing buses and batteries. And I'll leave you with one last slide. Our technology is so good, we don't manufacture every bus, so we don't make school buses or over-the-road coaches, but we're now selling our technology to Daimler for their Thomas school buses and to Van Hool for their over-the-road coach. So we do outsourcing on our technology. Thank you. Look forward to your questions.
Thank you so much, John, and for managing this clicker as you did. And you took the words out of my mouth because for 4 years we've been hearing, but can't we use 1 kilowatt hour per kilometer, 1.2 kilowatt hours per kilometer, 1.5? No, you can't. You just can't. And in some jurisdictions, it's 4 kilowatt hours per kilometer. In some, going downhill with an empty bus, it's 0.5 kilowatt hours per kilometer. So there is no such thing as range on a bus. So thank you so much, John. And with that, we're going to turn to Ray Little, VP of Sales at Nova Bus. And Ray's just got oodles of experience and is well known to the CUDA community for his years of industry experience in transit. Ray.
Thanks, Josipa. Good morning, everyone. It's great to be here with you. Do you have control of the slide deck at the back? Okay. I'm going to ask you to advance the slides, okay? All right, thanks. Guys, I'm excited to be here to talk about electric buses. I'm also excited to be able to get my first 5 minutes of YouTube fame. I think my kids will actually be impressed with me now, so. Guys, we are going to dive into electric buses. Next slide, please. But first, we have a small message from my sponsor. Nova Bus is actually owned by the Volvo Group. Next slide, please. And some of the brands that you might recognize from Volvo are not just Volvo trucks and buses, but also Mack trucks here in Canada and the United States, as well as Volvo Penta engines. And of course, bringing it closer to home, next slide, please. Nova Bus is part of the Volvo brand, and we're here, of course, today to talk about Nova Bus electric buses. Thanks to Cutric, we have several electric buses out on the streets under that program, and many of you will know that we have electric buses operating about 18 hours a day in the city of Montreal. But this slide here, it's important, I think, for us to pause for a moment and talk a little bit about the European experience with respect to electric buses. In Europe, generally speaking, they talk about PHEVs and 100% electric vehicles synonymously. They don't draw a difference. And it's led to a large proliferation of PHEVs deployed in Europe. And in the case of Volvo, we have about 400 of them, along with about 100 things called OpCharge. It's the J3105 solution, and I'm going to talk a little bit about OpCharge later. Next slide, please. At Novabus, our approach was to electrify our current platform to make a 100% electric bus. There's a bunch of benefits to what we call the LFS bus, but really that vehicle has become known as the industry workhorse. And like I said, we've electrified it. Next slide, please. One more slide. Thanks. Like many of the people on the stage, we have had a long path to electrification. It began with us electrifying components on a diesel bus. And of course, then we became leaders in the diesel-electric hybrid bus business. And that's led us to where we are as a 100% electric bus on the street. Next slide. It's important to go back to our hybrid experience for just a moment. We began introducing, many of us began introducing high voltage components on buses many years ago. And for Novabus, our approach to the market was to develop high voltage training programs, maintenance programs. We're using many of the same hybrid components on our electric bus today. And this is to deliver reliability over your 12-year or maybe 15-year service history. Next slide. This is just a quick snapshot of some of the Novabus hybrid projects. We have very deep experience in our leaders in the hybrid bus business. It ranges from stop-start technology all the way through to a thing called geofencing. And for those of you that don't know about geofencing, I'd invite you to ask me questions after the session. But in a nutshell, you can get approximately 25% engine off time by geofencing your cities. Next slide, please. So I would like to spend a little bit of time talking about OpCharge. This is also known in the industry as J3105. The reason that OpCharge is critical, I think, really stems around two primary points. It's around, first, the operation of lithium-ion batteries, and second will be the slide that I cover next. And so with respect to the operation of lithium-ion batteries, I think we all know that they come with a warranty, and there's some fine print in that warranty. So we are not allowed as an industry to charge lithium-ion batteries above a certain percentage or discharge them below a certain percentage. And generally speaking, as a rule of thumb, we have about 75% of that lithium-ion battery's capacity as usable. So this is why the conversation around range can be so difficult. In addition, most lithium-ion batteries decline at a fairly steady state over the course of 6 years. So given the average transit duty cycle, at the 6-year point, we're left with 80% of the battery's usable capacity. So illustrating this as an example, and I hope I don't lose you here, I hope I don't bore you with these numbers, I'm an accountant by trade, but if we take an example of 450 kilowatt hours of battery on the nameplate of a bus, and we go through that math of 75% of it usable, 80% available at year 6, and I had to write this down, it comes out to about 270 kilowatt hours of usable energy on the bus. And then if we take the Altoona test reports where they're talking about 2.2 kilowatt hours per mile to propel the bus and its components, we come out to a range at year 6 of about 120 miles or 190 kilometers. So this is why we think the OpCharge is a critical part of the long-range bus conversation. And like Paul and John, we're still not heating the bus or cooling the bus using those numbers. So it leads me to the second reason OpCharge is important. Next slide, please. What we're showing, sorry, one more slide. Thanks. What we're trying to show here is what we're calling a smart charging garage. And you can see inside that illustration there that we have a pantograph illustrated above the bus. And the concept here is that the pantograph, the J3105 connection, would move in a gantry style from bus to bus. This system would be integrated to your CAD AVL system, as well as your wayside energy management system, where we're controlling how much energy is delivered to each bus based on tomorrow's duty cycle. We're also trying to peak shave, and there's many other advantages to taking this approach. It wouldn't necessarily be a high speed or a slow charge. It's how the energy would get delivered to the bus. And with this concept, where this leads us is to the buses being attached to the grid when they enter the depot. And this also leads us to the opportunity to provide automation or autonomous operation at the depot where the bus goes through that maintenance cycle while it's connected to the grid, while it's pre-climating for the next day's work. So with that, I'd like to leave you with that. My 5 minutes of YouTube fame is up, and I really appreciate your attention today. Thank you.
That's great. And moving on now to the charging side of the equation, I'd like to invite Alex Lalonde from ABB, with whom we've worked in recent years on the Pan-Canadian Electric Bus project as well, on the very challenging side of the charging infrastructure integration. Alex.
Thank you very much. Okay. So, well, good morning, everyone. Alexandre Lalonde here from ABB, product manager for the e-bus and e-truck charging solutions in North America. Why North America and not just a global role? So there's a global person responsible for the same product line as me on the global level, but we understood fairly recently, I mean about a year ago, that North America had its own requirements and own beliefs, own opinions that would require a very specific approach, I would say, in terms of product offering. So that's why my role came in. I'm originally an electrical engineer as well, specialized in power system, so I know a little bit about power. I'm kind of a young kid here on the panel, but I think from the past 2 years I've been involved on many discussions, many challenges as well on projects. I'm trying to shift slides. Okay. But I mean, the experience that I've gathered over the past 2 years, standing on the J3105 Standards Committee as well as talking to pretty much all the OEMs across North America, I can give you quite a good overview of what was in the past, what's currently the norm, and what's coming next. Just to give you a quick overview of what's ABB and strictly on the EV charging field, because I think globally ABB, if for the folks in the room that don't know ABB, it's a very global company, about 140,000 people worldwide. So really a big player in the power system and energy markets. On the EV charging side, ABB has been in the EV charging side since 2010, acquired a startup company called Epion that did basically the first DC fast charger that was installed in the field in Europe. That's going to be on my next slide. So up to today, we have installed 11,000 DC fast chargers across the world, and on 800 of them are high-power charging stations between 150 to 450 kilowatt chargers. So a lot of experience, a lot of projects that we did globally that basically gather all the experience under the same roof, and that we can basically offer to our customer. So chargers in 70 countries. I inspired myself to build this presentation. It's going to be quick. Oh, I see 3 minutes. We basically, where we come from the start of Epion. We started, putting in the field one DC fast charger that had no standard. So we had our own proprietary connector that was used to charge a vehicle. So that's where we come from. So we know the struggle of having no standard and no interoperability in the market. But we've been part of the first groups to basically start a standardization with the CHAdeMO in 2010, and then in 2012 the CCS effort came in Europe. So we've been since the beginning part of those groups, and nowadays, my role is also to stand and to be part of the North American standard organizations, but we're a strong proponents. We like and we push for standardization across the organization, like all my colleagues here on the stage mentioned in their presentation. Where we are now in terms of product offering, so if you've seen ABB's presentation like this 2 years ago, you would have realized that we had much fewer, I would say maybe about 2 products. Now we very much diversified the offering because we understood that pretty much all the transit properties or even the customers buying electric vehicles have different needs. So we came up with a very good range, I think, of different power levels and different architectures of products to fill and to fulfill, hopefully, all the needs of our customers. You can see on the screen here, we range from 24 kilowatt wall-mounted units to the pantograph systems that can do up to 600 kilowatt and passing through the depot charging solution with multi-dispenser concept. Where we are going, so we all know, I think, that right now and the past few years, we went into pilots, right? 2, 5, 10 buses at a time. So our product offering was also aligned on this to offer a very flexible and very straightforward charging solution to be easily installed in a transit property and not require a lot of big changes in the electrical grid. Now, where we're going is full-scale adoption. So full-scale adoption means a lot of chargers in a single location, on-route charger in a technology mix. So why on my slide I'm saying technology mix is that 2 years ago we were talking about depot charging versus opportunity charging. Now what people are talking about is using opportunity chargers to charge in depot, so using pantograph in depots, using depot chargers for the base load, so charging overnight, but then using opportunity charging to top off the batteries as you go for long-range buses. So, I mean, just the general concept of opportunity charging versus depot charging, I think is in the past. What the discussions right now are really, how do you integrate everything together in a very intelligent and smart manner to make the most out of your assets, basically. So that's what I call the technology mix. And obviously, smart charging and fleet management, it's all just on top of what interface you're using and you're selecting. That's the golden question. But just integrate, I think we all agree that integrating everything together is the solution moving forward. My last slide, let me see if I can. So the last slide is just to give you an overview of what are the stakeholders and what we need to integrate together to make this fleet and all this electric bus fleet happen is really the grid side, the charger management, and the fleet operation. So everything has to be integrated together, and we should stop thinking that you can integrate electric buses in your fleet the same way that you can, and operate them the same way you do for diesel buses. That's too often what I hear from customers, and I think we need to stop that and evolve, in the future. I know we're running out of time. Hopefully we can answer more questions on the panel. Thank you.
And so actually, Alex, that was a great segue because we heard that talk about range is an old discussion. You know, if you're at the cutting edge, you don't really talk about range anymore in kilowatt hours per kilometer per bus. You talk about systems. And as Alex mentioned, dialogues about is it in depot or en route? That's an old discussion. It kind of dates you. That's in the past, and we're beyond that. And as we'll discuss on this panel, is it electric bus or hydrogen? It's an old discussion. We're over that. So there's these older discussions, but if you haven't had those discussions at your system, it means that you're facing a lot of the dialogues that over the last 5 years, in many cases, these organizations have responses to and solutions for. So with that, we're going to turn to our final speaker, Brian Pollock from Siemens, another great partner on the charging side for our Pan-Canadian Electric Bus project. Welcome, Brian.
Well, first, thank you to Cutric for asking Siemens to participate on this panel discussion. I am responsible for business development activities on the e-bus topic specific to DC charging and transit. So a little bit about Siemens first. We're a over 170-year-old company, over 90 billion euro sales annually. We're present over 190 countries globally, but only one country is important today, right? That's where we're at today. Which button was at the top?
Yeah, there it is. And I'm
There
just
it
going
is.
to check here if your delay is over. Yeah. So if you point there, it's only about 2-second delay.
Okay, great, thank you. So This spider web does a pretty good job, I think, of illustrating many of the challenges that transit agencies face as they consider electrification of a fleet. You've got a lot of considerations on the power side. Can the utility even provide the power you need? I can tell you that there's some transit agencies today in the US who are experiencing the fact that no, the utility can't provide this power for a period of maybe 3 to 5 years. So one of the very first things a transit agency should think about in the planning process is, where am I going to get this 5 to potentially 15 megawatts of service interconnect to supply this depot of 100 to 200 buses we may be building out? You move now from a continuous dependency on a fuel supply to a continuous dependency on power. And you also, as you deploy all these different chargers, these are switched mode power supplies. You also have to take into consideration what harmonic content you might be reflecting to your utility provider. Then for charging operations, you have to have space to mount all this equipment. So does the facility have the space for all this charging hardware? How are you going to manage the charging operations? How are you going to optimize the use so that you can minimize the amount of power you consume at any one time, minimize demand charges? On the commercial operations side, you have shifting costs from fuel now to electricity. What does that look like? Hopefully it represents a savings for the transit agency. And then on the maintenance and service side, now you've got the need to manage high voltage systems, whereas previously maybe you were managing, you're servicing lighting and HVAC loads inside of office spaces. This slide does a good job of illustrating just some of the different technologies that are available. So at Siemens, I don't have a slide today that illustrates the portfolio of chargers that we offer, but we have a complete solution from plug to grid. Whether it's a level 2 AC charger for a passenger vehicle, a DC fast charge product for charging a light duty or passenger vehicle in a corridor, or our high power DC charging solutions for depot applications. We also supply all the various infrastructure, or what's called make-ready product in this space, all the transformers, switchboards, switchgear that's necessary to deploy power from the grid to the plug of the vehicle. This slide also illustrates some of the different options you have to consider when looking at a full-scale deployment. We can do the plug-in charging, we can do en route charging with a pantograph, or we can do in-depot charging with a pantograph. The advantage of pantograph charging is it removes a person from the charging process because it's an automated procedure. Other things to consider when you're talking about a full-scale deployment is where is that energy going to come from on a continuous basis? Are you relying on the utility to never have interrupted power? Or if you lose power for a day, then what? Are you going to deploy a microgrid? Are you going to deploy co-located stationary battery energy storage so that you can minimize the demand and time shift when the energy consumption is required to charge the vehicles? So there's been a little discussion today about the J3105 standard. So there's a couple iterations of that. Primarily in North America, we're seeing the J3105 deployment, which is the structure down to the bus with the rail system on the bus. The nice thing about that approach is it's fully automated. The bus driver pulls up if he's positioned correctly and sets the parking brake, then the charging process begins. We are looking at projects where we're going to allow not only for that pantograph to be mounted on a ceiling in a depot, but for multiple pantographs to be mounted to a common charger and then sequentially charge vehicles in depot as they're parked in an overnight scenario. The other picture up there shows the J3105-2 implementation, which is the bus-up pantograph deployment. Not as common, not really seeing that in the U.S. Most of the bus manufacturers up here today are doing the 3105-1. And then I'm not showing the 3105-3 because I've only seen that in a cartoon. So from a commercial standpoint, this is what Siemens is offering in terms of overhead chargers today. We have a 300, a 450, and a 600 kW version available. And we comply with the OpCharge standard. When 3105 is available, we're going to comply with that standard. For back-end communications, we'll comply with OCPP so that if you want to use our back-end for monitoring this asset, you can, but if you don't want to, whoever's OCPP back-end software will function. We've got a couple different style masts. I think this picture is showing pretty much the architectural design style mast in both cases. I think the next slide shows the industrial style. And then I've got a picture there too of a deployment in a depot with it mounted to the ceiling structure. This slide just shows you some of the different components that make up an overhead charger. Deploying an overhead charger is not something for the faint of heart. It's a major project. You've got a significant civil works that needs to occur because you've got underground duct banks that need to go between your power section and your mast. And you're digging down into the ground probably 5 to 8 feet to bury those conduits and put that mast foundation in place. And there's some transit agencies that go through this deployment and figure out, oh, there's a gas line right where I wanted to set my mast. Surprise you shouldn't have to encounter during a deployment, but just planning. Planning is important when deploying these overhead structures. I'm not going to spend any time on this slide. It'll be available for you to look at, but just a lot of different considerations to take into account when doing an overhead deployment. This slide just shows a couple examples of where we've deployed overhead masts with pantograph, and then just the different OEMs and where we're at in stages of interoperability. Thanks to Cutric, we had the opportunity to have ABB chargers and Siemens chargers tested with Nova Bus and with New Flyer products. BYD, we're doing a deployment in LA, and they will have a bus that'll charge at one of our overhead chargers. Proterra, we're talking to about interoperability testing, but talking about the components they use and what we've had success with in the past, there's no reason why it shouldn't work, after a day or two of just testing it out. Siemens also makes a depot charger. It's a 150 kilowatt unit that has power section and then up to 4 remote dispensers. And just like the overhead charger, it's OCPP compliant for the back end and J1772 compliant for the plug in the front end. And then in interest of time, I'm going to keep moving here. This slide illustrates where the different bus manufacturers line up with their voltage ranges and where their batteries charge. For the most part, everybody's in the same range, that 400 to 800 volt charging range. BYD has a product that charges at a little higher voltage, and one of the reasons why we also have a new voltage range for our second generation of product that we're going to make available. Proterra in the past was using a lower voltage range, but as I understand, next year you're going to be delivering vehicles with the higher voltage range, more compatible with the other vehicles. So something to keep in mind. I mean, your passenger vehicles charge down in this 200 to 400 volt range. If you're buying a charger and you're intending to use it to charge a passenger vehicle and it only delivers 500 to 800 volts, it's not going to put an ounce of energy in that car. And then the last slide, real quick. Siemens is offering a software as a service for depot management. It's going to have a couple aspects to it, monitoring and reporting, energy optimization so that we analyze when vehicles come in, when they need to be charged, how you might time shift that usage so that you can minimize the demand requirements from the utility. And we're also going to have a piece that will manage co-located energy storage, so a bit of a microgrid control. And then this will also allow us to monitor the overhead chargers, and then if you have a cluster of overhead chargers, do some demand management on those as well. And you can see there's a lot of hooks into other systems. We're going to have APIs available for pulling data from the OEM cloud so that not only do we have the history when we're trying to optimize the system, but we'll know when that bus is coming back in what it might need for that overnight charge to be ready to go the next day. So I can see I'm getting the hook here, so that's it from my side. Thank you.
Okay, so slowly we're figuring this out. And the deep irony is if you were at our hydrogen fuel cell conference in June in Mississauga, we went to this hotel and it was a great event hotel, but we showed up and we realized it was a wedding event hotel. And so the AV didn't really work out. So we thought we're going to go to a pro hotel and doing a pro job, but it looks like the problem is on our end, everybody figuring out this clicker. So for panelists coming up, if we can help this pro hotel help us at Cutric be a little bit more pro, we'd really appreciate that. So with that, we've got just a great overview of the technologies, where we've come from and where we're going. Some of the older debates in terms of range, depot versus en route, hydrogen versus electric, another one that's going to come up later on in panels. These are sort of the older debates, and now there's a lot newer debates that are accruing and that transit agencies are facing. And Brian, I'd note that you had a photo of the Vancouver bus there that was part of the Pan-Canadian Electric Bus Project, but you had the old wrap, and we've got colleagues here from TransLink, and if you've seen the new wrap, these are the most beautiful buses I've ever seen in my life. They've got this wrap that's got glow-in-the-dark imagery on it, and the chargers glow in the dark. It's amazing. You got to go out and ride on these beautiful buses. So with that, we're going to segue into some of the upcoming things. And we're going to ask our panelists, each of you have a microphone, and I think yours is there, Kirk. We're just going to do a quick, if you want to check that it is turned on. We're going to use our parliamentary rules of behavior since we are in the context of a federal election. So we're going to ask for 60-second answers from panelists. And the first question that we want to ask panelists is, it's going to put you in a difficult position. You never want to ask OEMs, who is your favorite client? But that's what we're about to ask you. So of all the transit agencies that you've worked with or seen in North America, which transit agency would you say is an exemplar for moving forward with electrification, and why? What is really so great about this transit agency that others should maybe pay attention to and even try to model or mimic? And with that, we'll start with you, Kirk.
Okay, I'll start off. Thank you very much. It's really hard to say. Actually, I've been very impressed with several transit agencies, and what we're always looking for is partnerships. So I think what we're looking for ideally, and I think the right mindset is you're willing to accept the challenges that are going to come with new technology. And I think unfortunately what I've learned over my last 10 years, there's a lot of transit agencies that are all about risk mitigation, and it's very much just about risk mitigation. But when you're talking infrastructure and new technologies, you have to be willing to take that challenge on and know that you're going to work through the risk and work through the challenges. So examples that I've seen would be STL or STM. It would be TTC, and it would be TransLink as some of the bigger agencies that we've worked very closely with. But I think it's that willingness to accept the challenge and leave some of the risk mitigation behind, because we're going to work through that together. And if you want to avoid all risk, then you should just wait, probably. Thank you.
We've heard that in terms of procurements. If we're constantly going for the lowest possible cost in a public tender, you're not going to get to electric, largely because the costs accrue through operations, not in upfront capital. So that risk profile being a leadership quality. All right, we're going to turn to our next panelist, and we'll go down the line from left to right from Kirk. So John?
Really, can you hear me okay? Really hard question. We have a lot of customers, and I could take you back to the beginning of time with Foothill, who was our very first customer in California, doing fast charging, to Tallahassee, to Via in San Antonio, and then Worcester in Massachusetts. And really the beginning of time was fast charging, and now we've gone to extended range batteries. So the model has really changed. And the conversation is, how do we get a 1-to-1 ratio diesel to electric? And that's really the goal. So not because we're sitting here in Canada, like I said, we have several customers, but Edmonton, who is just getting ready to deploy, has done an outstanding job of planning. They have a huge staff. They're doing multiple things in depots. They planned this out with telematics. It is truly impressive. The other point I'll make is when we get a pilot of 1 to 2 buses, I agree. I don't think that customer is very concerned about going with a full deployment. I think they're just testing it and really not wanting to take it much further. I applaud Toronto at TTC for doing a large pilot with multiple manufacturers. Many of us are there with pilots, and that's the right way to do it. They're testing different chargers and different buses, and that's the way you should do it to figure out what the path is forward.
Fantastic. Thanks so much, John. So if we're going to do a pilot, it ought to be big and large and meaningful. And if we're going to do a deployment, it ought to be for full-scale integration objectives. All right, great. And Rail?
Hey, thanks, Josipa. I am going to give a list of the top 5 at some point, but really what I wanted to talk about is what these top 5 have in common. And it begins with funding. It begins with money. The top 5 I have on my list have money. They've also taken, for me, quite a scientific change management approach to introducing electric buses. And what I mean by that is they have a series of champions, and those champions are supported by a project management structure. So I think that's critical in rolling out electric buses. They also have a close working relationship with their power authority, so I think that's advice that I think these top 5 would share. In my mind, Seattle is ahead of the other 4, Toronto, Chicago, New York, Montreal. But I need to give a special shout out to the small transit authorities that are literally implementing electric buses through passion. And of course to Cutric for some of the work that you have done. I don't think these people can be leaders in their functions without Cutric here in Canada, so well done.
Thank you. Well, we'll take it. Thanks so much. And Alex at ABB?
Yeah, I would piggyback from Kirk's and John list, basically. So TTC, I think, is one of the great one, just going with multiple manufacturers to test the technology and compare them one to one is, I think, a great idea. I would say TriMet in Portland, Oregon, just by using depot charger and on-route charger on the same bus route, basically with the same buses. So really looking at how to implement and optimizing the technology mix. As well as Edmonton, obviously, for the creativity of using on-route chargers in depots, well, just pantograph chargers in depots, and large-scale deployment and going full speed with 30 buses and even more moving forward. So that's very good, I think.
That's fantastic. So the in-depot overhead charging movement in order to support the large-scale electrification, quite innovative, and a couple of you mentioned Edmonton Transit, a really great project management team moving the project forward.
Yeah, it's
Great.
a technology shift. It's
Absolutely, and culture shift.
pushing
at
the
that transit
technology.
agency.
Yep.
Brad?
Yes, so I've been on this topic for about a year now, and my answer is going to come from a perspective of my base in the United States, although I support my Canadian colleagues. Most of my experience has been with the U.S. deployments. You know, because of the decision of the Air Resource Board in California, you know, LA Metro and the political environment in LA, they want to deploy full fleet electrification by 2030. I have no idea how they're going to get there, but you know, they're embracing it, and they're going to figure out a way to at least get most of the way there by that time frame. So from that perspective, they're kind of leading the way. But then on the other side of the coin, New York City Transit, the largest bus fleet in North America, and they are crawling, but it's because they're looking at this from every aspect so that when they're done analyzing everything, they can go full scale quickly.
So systems planning and integration, and then political leadership on the West Coast, motivating the industry. So we're going to turn to the audience for questions, and in a moment, and just to remind you, there are 2 mics, so we'll ask you to line up if you've got your questions ready. But with that, what we've got from our panelists here is there's a lot of innovative systems. Seems that if we boiled through them and distilled to the top, what is probably common is either there's political mandate, forcing them to go that way, or there's money on the table. And you can't do what TTC did without cash on the table, and you can't even do what Brampton, New York Region, and TransLink did with our project unless there was cash on the table. Edmonton had cash on the table from an NDP government that was very supportive, and a federal government. So cash has got to be on the table, and without the cash, you can't be as innovative. And that leaves the open question of what about all the rest of the transit agencies, the mid-sized ones, the ones that don't have that amount of cash municipally or even federally or provincially. And we're going to come back to that in a moment, but we have a question here from Doug at IBI.
Hi. So in support of the idea of large-scale systems integration that's vendor agnostic, on the charger side, there was talk about OCPP that would support that. So I guess I'd be interested to hear from the bus manufacturers about something analogous in terms of flexible API that they might be offering for that purpose.
Okay, so moving into the dialogue about flexible APIs, which one, we'll start over there actually. Why don't we force tell this?
Yeah, so from our side, with our software as a service, we're going to have an API available for connectivity to whoever's OEM cloud the transit agency needs connectivity to. And we don't need all the bus data. We just need some of the bus data to make it relevant for charging operations.
And in fact, I'm remiss because we should make sure that everybody understands what API actually means in the audience. And so maybe just by show of hands, who understands what the concept of an API is? So we've got maybe about 50% of the audience, right? It is a concept, it is an acronym, it's a bit cliche these days, but it refers to a technical concept. And just to put it basically, there's a unit, there's a bus, there's a vehicle, there's a something, your watch on your hand, and there's a computing system somewhere controlling how that thing works. And that unit has to talk to that control system, and there's going to be some kind of communication between that unit and that control system. And the decision maker in between, whether it's a device or a software, is the API. And so if all of these devices, these buses, these shuttles, these autonomous cars have different API standards, or they don't have a common API, then they can't talk to the same control system on the back end. And so just like we talk about interoperable charging systems, if the software and the brain control do not talk to each other, the system breaks down. And so the question was really about the movement towards these API standards, commonality, and what does that mean for the future. We faced it in our own project where not all buses necessarily on day one were able to talk to all loggers and all software systems. So Alex.
What I would say, the question is much more towards the bus OEM, so I'll let them some time. But I think on the charger side with OCPP, we kind of solved this issue by a standard common protocol to integrate all charging infrastructure. But now what I see coming more and more is in the bus environment and the transit environment, it's much more industrial type of communication protocol that are being requested. So we may see in the future some sort of standardized exchange table on a more industrial type of communication protocol, like OPC UA, something like that, that would be shared between the vendors, that could fit more into this industrial environment versus OCPP, which is more targeting the car charger market. So that's also a trend in the near future.
Okay, so if we globalize the question more towards a commonality of APIs and software controls as well, Ray?
Thanks, Josip. But just a quick check. I was wondering if the consultants are paying us for this. Guys, you saw my slide where we envision a smart charging depot. So we've already assumed that we're going to be sharing APIs. I would say on one technical note that those APIs may be unique to each transit authority. And where I'm going with that is each of you have your own CAD AVL system, and I think we all know the challenges of APIs among that network. So doing it across the entire country or the United States and Canada, I do see as a challenge, but I don't see it as much of a challenge on a customer by customer specific basis. Does that answer the question?
So you think transit agencies can get away with maybe even having unique APIs per jurisdiction?
Yeah, I would see that as at least a starting point. Yeah.
Okay, and interestingly enough, and we'll hear about it a little bit from our smart vehicle panels, I mean, Los Angeles launched its own city-led API for autonomous shuttles. And of course, if you're an automaker, an autonomous vehicle maker, you now have to design your vehicle system to plug into that software communications protocol.
And I would just clarify then to my original question, I wasn't necessarily talking about something that would be the same protocol as is the case with OCPP. Like for integration work that we do, it actually can be fine if each of the different things that you're integrating has a different API as long as it would be maintained over time. Yeah.
And so there's some support for that view, but on the flip side, folks have said, look, not all of us can be LA. LA can move the audience, LA can move the market, and if everybody has these unique circumstances, it's going to be really hard for the software providers and the manufacturers to bring the price point down as far as possible. So that is one of the counter-arguments that cities need to get together and have very common APIs and also very common software and communications protocols across the vehicle charging and overall systems network. The jury's out.
Yeah, so I think you guys can see the strategy at Proterra is to be fully integrated bus, battery charging, and telematics. And so we have TA, what we call technical assist, and we have turnkey. So we can do from the utility all the way back to the bus in one package, or we can do it a la carte, and we're doing that right now. So it can work either way. It just depends on the property and what their goals are for the fleet. But we can do it either way, and you'll hear that term TA and TK with us pretty often, and that's kind of what that acronym stands for with us.
Okay, great. And Kirk?
Yeah, I would agree with what John's saying. I mean, we can do it either way. I mean, we've been very agnostic and diverse in our approaches to customize. Transit agencies are also different. And we took a lead role with interoperability standards at a charging level. So if we have to take that up a notch to a communication protocol or to another level to allow full integration, yeah, we'd be very open to that. And we've taken a lead role, and we would look forward to having conversations on that. So.
Fantastic. So a real divergence in what's possible, but a lot of opportunity here in terms of unique solutions or common ones. Michael?
Thanks, Josip. A fantastic start. One of you, I think it was Kirk, mentioned in-motion charging. I'm just curious as to what you see the potential for that, especially in systems like Vancouver, Boston, San Francisco, and others that already have wires in their infrastructure, and what's going on overseas in Europe with regards to that as a potential piece of this big puzzle.
And Michael, can we just clarify, maybe there's two different types of possibilities here? You're referring to in-motion charging, where potentially the vehicle has a pantograph that comes up and connects to catenaries, and the pantograph then comes back down and maybe moves on battery, or there's also inductive charging. So were you referring to the former in terms of connecting to the catenaries,
that's right?
Yeah, and we had this dialogue because in rail, that's obviously one of the dialogues around electrifying rails, that the pantograph comes up for rail to move in and out of the garage, the pantograph comes down, and it's high-rail for the interregional travel. Could you do that for buses too? And perhaps we'll throw in there, Michael, what about the inductive charging? Is that
Sure.
part of the future? Mobile charging that's not heavy-duty equipment or using equipment that's already there. And Kirk?
We'd love to see more, to be honest with you. And I think there's a lot of transit agencies, including maybe even Winnipeg Transit, that are remorse that they took all the wires down years ago, not knowing exactly what the future was to hold. So we think there's a place for it. I mean, I highlighted in my presentation, if it wasn't obvious, about the diversity and the needs being so diverse. I think there's definitely a place for it. We'd like to do more, and we're having conversations with some of those big trolley markets now. In terms of Europe, I can't really comment on Europe very much, other than the ADL acquisition has been fantastic, and we've been talking to them on a regular basis, and between their engineers and my engineers, there's a lot of technology sharing. So if we with our in-motion charging and trolley experience can help them in Europe take more of a foothold, that's what we're doing. And between us and MCI, I tell you, the amount of energy with this technological revolution now has been just fantastic. And if that means reflecting back a few years to 1968 when the first trolleys hit the road, then you know what? I think there's a diverse place, because I don't think it's a silver bullet that's going to suit everybody. That would be my comments.
That's great. And John?
So we hear electric trolley or electric bus, but we talk in terms of battery electric bus, and there's a huge difference. So we believe that we don't do lines, but our technology could fit with anything. So we're looking at that. We are looking at inductive. We don't currently do it today, but obviously that's something that's in R&D that we are looking at, because some cities think that may be the best solution. But today we don't do wire, we don't do inductive, we do just the battery charging.
Okay, very good. So it may be part of the next 5 years to come, depending on what clients want. Okay, right?
Thanks, Josipa. Like John, we respond to demand, but you did see my slide where we do envision, at least at the depot, that the vehicle would be connected to the grid the whole time. En route, I'm more of a fan of the European approach on the plug-in hybrids and bringing it closer to home here in North America, really where we have long-range buses connecting to the OpCharge or J3105. The infrastructure around having the bus connected 100% of the time out there on your streets, I think challenges the business case on battery electric buses.
Mm-hmm. Alex?
I would say pretty much the same. I cannot really comment so much about the capabilities of buses to connect to catenary rails, but I can tell you that we've had some requests in Europe to basically build chargers that would connect to the catenary rails, because you already have the infrastructure in place on street, but you would put a OpCharge or on-route charger next to them. That has its own challenges, and I think the discussion is ongoing, but that's what's the closest to the catenary rails. And in terms of inductive charging, ABB has always been blonde on the fact that we selected conductive charging as the way forward for the next years. We always stay open, right? We remain open to any development in the standardization. I think we're waiting very much on standardization of this technology before making a real choice if ABB goes this way or not. But I mean, that's something that the future reserves.
Okay, so there's not that many catenary lines left, but if the future brought them back, there might be the opportunity of systems integration with the charging infrastructure required for battery electric as well.
Yep.
Great. Brian?
Yeah, so first for the inductive charging question, Siemens has looked at it, but we're not pursuing it currently. Next for the question on operating a vehicle on a catenary line, Siemens Mobility does rail systems, does rail electrification, and is very much in that business today for rail electrification. The difference with a catenary line is it's a constant DC voltage, and your battery system on the bus needs a varying voltage and a controlled current. But Siemens also makes a DC to DC converter that can sit on that vehicle for charging that battery electric bus with the catenary overhead lines. But haven't seen anyone doing it here yet in North America.
So it's possible to integrate the systems, and maybe can we ask you just why have you decided not to pursue inductive charging? Is it just about the efficiencies? Because we hear this a lot. It's easy, it would be simple, but at the end of the day, it's just fundamentally not an efficient transfer of power.
Yeah, I don't really have any insight into why it wasn't pursued. Just know that it hasn't been.
All right, so another dialogue for another day, but Kurt?
Well, I can speak to that. I mean, we're looking at it as well. I mean, we're always trying to keep as much technology within our roadmap as possible. But I think there's two key things. You've touched on one with efficiencies, and if we're going to talk range and the life of a battery, then I mean, obviously, we can't take much inefficiencies. So the efficiencies have to catch up, and like we've touched on several times, all of us today, standards. Mm-hmm. I think before it can really move forward, there needs to be a lot of work on the standards so that it's easier for integrators to integrate, and it's, in the end, much better for the transit agencies to have one standard of induction to work to.
Mm-hmm. Fantastic. And for those of you who haven't seen an inductive charging system, because we do get these questions a lot, basically from the laws of physics and electromagnetism, you're sending an electron across a space of air, right? And that is where the inefficiency comes from. So you're trying to power it up from a huge power source and then basically send electrons through electromagnetic radiation across air. And the further the air is from the receptacle, the less power actually receives. In a basic science understanding, that's what you're trying to do, which is why it's a really complicated and difficult technology.
I think it's, it looks very cool when you look at it from, far away. But I think for the engineers in the room, looking at the actual system integration. So what does it take to make inductive charging happen from a system point of view? There's a lot of boxes and power conversions, losses. We talk about high frequency power conversions with high power, right? So there's a lot of things involved, and currently I think what's stopping the market on that is that if you want to work, if you want an inductive charging charger to work, you need both pieces on the bus and on the street to be from the same OEM.
Right.
So there's no interoperability so far because the standards are not there yet.
That's right. And inducing electrical movement and basically electromagnetism is from a physics standpoint, it's a really interesting kind of solution. Yeah. From an empirical and practical standpoint, it is very challenging. But then again, a lot of what we heard is quite challenging. And so with that, we'll turn to Scott Gellner.
Do we have time? I know we're running tight.
Yeah, we do.
Okay, excellent. So great panel presentations, everybody. My question's more to Ray, John, and Kirk. I guess I really enjoyed Paul's keynote speech, and his pictures of the Winnipeg winters really kind of solidified a few concerns for us in Brampton. Our winters in Canada are much different than those in the States, and our council's notion for zero emission, zero carbon future is zero emission bus technology. It's not zero tailpipe emissions. So I was wondering if maybe each of you could just speak to what your current offering is around fully zero emission buses versus zero tailpipe, i.e. with diesel fired auxiliary heaters on board. Our future is no diesel. So getting there obviously has a price to pay, and Paul mentioned I think a number of 65% of the draw on the energy system is attributed to heating and cooling. So where are you at now, and where are you going tomorrow with your solutions?
Yeah, okay. And maybe if you can also comment, does it make sense to just keep using diesel heaters in Canada given the trade-off?
I'm not a fan. I've never been a fan of having to keep a diesel auxiliary heater on the bus. But when it comes down to range, I mean, you're just trying to strike the best balance. I think actually for having lived several years in the Toronto area, I mean, I actually don't think the Toronto area would need a diesel aux heater. It's more for the driver than I think for the passengers who are already fully clothed anyway for the winter. They've been waiting at the bus stop. We're doing work with we're always looking at alternatives. I mean, I would prefer to not have it at all. We're looking at heat pump technology, and we have a heat pump project going now with some funding that we've received, and we're going to be working closely with New York City to look at those technologies. But again, not very good for the Edmontons and the Winnipegs of the world. Probably good for the Bramptons of the world, I would think. So that's a project that I could keep you abreast of. We're just into the infancy of it. And I would agree, we've got to look at greater efficiencies where we can run a larger kilowatt floor heater and not be so worried about the impact to range or even to the low voltage side for that matter. So I agree with you. We should eliminate it completely. And one thing that does help, I think, quite a bit, I mean, you touched on fuel cells very briefly, but if you're looking for extended range and you want to have less concerns about the energy for heating the bus, and when we look at our telematics report, we do spend a lot of energy heating and cooling buses. I think a lot of that energy has been kind of seen for free for years, and we have to get rid of that mindset. But fuel cell, as a battery charger, a zero-emission battery charger on the bus, I mean, I haven't seen enough fuel cell discussion in Canada, but it is a viable alternative. Mm-hmm. We're seeing lots of interest in the Southwest. I'd like to see more interest north of the border. We've got a 350 miles range with it, and there is energy available for heating and cooling, because what we're seeing with most properties, they're using a fraction of the energy they need. So again, there is energy for heating and cooling, and we don't have to be overly conservative with a diesel aux heater in many cases, I would say.
And that speaks back to one of the outdated debates that we've often heard, is it electric bus or hydrogen fuel cell? And that just is a dead debate. It's both. It's both for the future. It's going to be both for a lot of systems, not all systems. It's electrification by another carrier of an electron, and it does overcome some of these issues of high speed, high range, high heat, high climate control, crush capacity, really difficult environmental conditions for electrification across all modes. John?
Yes, so at Proterra, we signed up for a test this past year with Duluth, the FTA, and NREL. And you can actually get this report on NREL's website monthly to see the performance of these buses. But those 7 buses were delivered in December of last year. And in January, if you check the weather, it was minus 60 in Duluth. We think it's the coldest place on earth. We learned a lot. Diesel, hybrid, CNGs did not run that day, but our buses did. Mind you, they didn't go very far, but they did run. I hate seeing a tailpipe on our bus. I absolutely hate it. So what are we doing at Proterra? We are now advancing from 440 kilowatts of storage to 660. That bus is at the Altoona test track right now. It'll be finished in December. In addition to that, we have a dual power with 2 motors on each wheel, which gives us double the regen, and that's going to give us even more range. What are we trying to do? We're trying to get away from that diesel fuel-fired heater if we can, and we're working with the HVAC system companies to come up with solutions. So we personally want to get rid of it, but I totally agree. You got to keep the bus warm, and you've got to keep it efficient, and that's a solution that we have today. I think we'll get there.
Thank you, John. And Ray?
And check out that test. It's an interesting read.
We'll send it out with a link to your presentation. How about that? Right?
It's kind of nice going number 3, guys. So like Kirk, we're doing some work on heat pump. Like John, we're increasing battery size on buses. Like we showed in the presentation, we're seeing the bus being pre-climated when it's attached to the grid at the depot. So before it leaves the depot, it's headed out at temp. But I would bring us back to the math that I talked about, and I'm bringing it up again because I'm sure you went to sleep when I was talking about the math. But if we're saying 65% of the energy on a bus is devoted to heating or cooling, and I would span that to every state that touches our border and all of Canada except BC, Vancouver and Victoria, where we need to have this conversation. So the math was, I would remind you, it's 190 kilometers at year 6 with 450 kilowatts on board. And if we're using 65% of that energy, there's a new equation. So I don't see at this time getting rid of the tailpipe for heat and still having range, but the OpCharge is also part of that solution too. So we could deploy enough OpCharges to push the bus with electric heat.
Fantastic. Thank you so much, Ray. And Kirk, you have a jumping comment
well,
there?
I mean, very good points by John and Ray. So I'm just going to jump on something Ray said here, which was an excellent point. Many of the HVAC systems and even heater systems that we design are over-designed because there is, again, in the spirit of risk mitigation, we put too much reliance within the APTA White Book specs on pull-ups and pull-downs. So the systems are designed for a very aggressive pull-down or pull-up, and you've got extra capacity there that you don't need. And we've had properties now in the Northeast asking for Houston pull-downs, and to me, that's not energy conscious. So anyway, thank you, Ray, for bringing that up.
So essentially altering the requirement on the client side to be energy conscious to be able to efficiently move into these technologies.
I think you should look at the majority of the duty cycle and look at the steady state. And yes, I know doors are opening and closing, which is a challenge, but some of those aggressive startups, pull-ups and pull-downs, which is a fraction of the time, it's not a good use of energy.
Okay, so on the parabola curve of performance, we're taking the extremities and using that as a procurement strategy. So in the last couple minutes, what we're going to do is turn to our panelists and give them the 30-second concluding comment. Unless you guys had something you really burningly needed to say on the auxiliary diesel heater, we're going to turn to our panel for final comments in 30 seconds. We're going to ask them to say, what is an old question that they used to hear transit agencies ask, and what is a new question that agencies are asking? And so we're going to start over on Brian's end. When you're coming out to these agencies, they're talking about electrification, what did you used to hear and what are you hearing now in terms of key questions?
Sure. I can only speak to what I hear now because I've only been doing it for a year.
True.
So, but what I hear is the concern is how are we going to scale up? Where's the power coming from? Where are we going to put all these chargers? What's the best methodology to keep charging reels up out of the way of the buses so they don't get damaged? Desire to do a lot of in-depot pantograph charging. So how they do all that, where the money comes from to get it done.
How do we scale and how do we pay for it?
I would piggyback on that, just adding that a former question is, what's the technology status? Does it work? What? Is it standardized? Is it interoperable with other OEMs? I think this is in the past, but the questions now are really, how do we scale up? How do we go full speed and fully electrified?
So nobody's asking, does it work anymore and does it interoperate? Just how do we scale up?
Exactly,
The
with
time is
pilots and pictures and announcements. I think we made this question part of history, and now it's like, are we going full speed?
Fantastic. And Ray?
Thanks, Josipa. I think 5 years ago, transit authorities, our customers, were asking us as bus builders, where is your electric bus? Is it going to get on the road? I think we've answered that question. Today, I would say that the transit authority, our customers, are having range anxiety. They're wondering where their power authority is in the electric bus conversation. And I think one of the most important things our customers are dealing with now that they didn't 5 years ago is stakeholder management. We have a lot of special interest groups influencing the operation at our transit authorities, and the lobby of your stakeholders is taking place where you're receiving a lot of pressure to move. So I think that's something that our customers are having a hard time with.
It's almost a political issue in the commercial landscape in terms of stakeholder management.
Yeah, Paul mentioned that during his talk too.
Very good.
We haven't mentioned much about the utilities, but the question that we've seen is, how do we afford this? And the way to do it is to get the utilities, I know there's some of you in here, to buy in. And in some cases with our deployments, the utility companies are actually purchasing the infrastructure and the chargers for the customer. So that's a good point to get to, because without them, we really can't scale this at all. So it's good to see them come on board. At APTA in Louisville this year, the rooms were busting out of the seams in the sessions that the utilities were involved in. So it's good to see them get on board, because that's what we need.
Great. And 5 years ago, I mean, the question was not where are the utilities, they just weren't anywhere.
They didn't exist.
And the question now is, where are the utilities and what's your role? And chop chop. And it's a great segue to our next panel when we're going to be putting the utilities on the chop chop panel here to give them a few questions. And Kirk?
Yeah, I mean, 5-10 years ago, I think a lot of the questions weren't great questions. They were very diesel, it was coming from a diesel mindset. So the questions were very basic, very rudimentary, and that's why we felt a need to take very much an educational role. The questions now are very educated and very sharp, but I agree with a lot of what Brian and Alexandra said with infrastructure and how am I going to scale and can you help me scale? That's the big question right now, is how can we scale beyond the 5? We know the 5 work. From all the manufacturers, the 5 work. Now, how do we get to 205?
Fantastic. So where we've come from is perhaps diesel-oriented queries about will it work? What's the boogeyman in the closet? Prove it to us. We don't believe it. To fast forward where we are, how do we scale up faster than we ever thought we needed to? What's the role of the utility? And how do we manage our stakeholders from political through to the community to see that this is the way of the future? I look forward to welcoming you all back this time next year to see just how much further we've been able to accelerate this industry. With that, I'd like to thank our panel for a great introduction to technology. Thank you so much. With that, folks will note there are refreshments at the back, but we're going to steam right into our next session, and then we have a health break, but feel free to grab your caffeination as you require. It was a fantastic segue we had here into the issue over energy systems. And a lot of the dialogue that we've had over the last 5 years has been about energy system, battery management system, but energy system in terms of stored and mobile energy. And with that, we're going to move to our second panel on energy systems and utility integration, specifically looking at smart charging, demand management, and energy efficiency for electric buses. And I'm going to invite here to the front our speakers for today's panel, Sasha Pejcic, the Managing Principal at Transportation for Stantec, Kim Girglis, the Senior Account Manager at BC Hydro, and John Roulette, the Director of Energy Solutions at ENMAX. Oh, there we go. So we're going to invite you guys up. Fantastic. And it looks like we have a solution to the clicker scenario. So thank you very much, guys. It's going to be a little bit easier for you. Please, John. And we're missing Kim in action. No, we're going to give Kim a minute. All right. Well, with that, we're going to find Kim wherever she may be in a few moments. So in this particular panel, what we're going to be looking at and diving into is really the energy sector's situation in the Canadian electrification landscape. It is pretty much our experience that over the last several years in Canada, from west to east, the vast majority of the utility sector has not had a strategic plan. They haven't had a strategic plan for electrification. It's been a struggle to effectively move into electrification. And for those utilities that have had some kind of strategy, it's largely been motivated by the fact that the city has dictated that it ought to be so, and the transit agency has dictated that it ought to be so. And so it hasn't come from within organically at the transit agency level, or rather at the utility level. And so therefore, what we started at Cutric several years ago was moving into a power providers working group. So for those of you who are part of our consortium, if you are a utility in our consortium, we got together a number of utilities across the country to say, just like transit agencies were struggling to share information around electrification, utilities actually were not sharing information. And in this country, we have vertically integrated utilities like BC Hydro, Manitoba Hydro, Hydro-Quebec, that can move and shake across the entire distribution scheme. And then we also have local distribution companies that are municipally backed or fully municipally backed utilities that are really obligated by the needs of the municipality. And so that creates a really difficult, complex mosaic, and it's just not possible to have a standard utility approach. There are loads of different business plans that are going to have to emerge. But first and foremost, it was important to get the utilities out to the dialogue to start with. And so with that, I'd like to welcome our speakers, and each one is going to give you a little bit of insight into what their utility or their utility strategy and the energy strategy is more globally with regards to energy systems and utility integration. So first, I'd like to welcome Sasha Pejcic from Stantec. Sasha is the managing principal and lead at Stantec's Global Transit Advisory Practice, and he's very specifically focused on zero emissions bus portfolio, and I've had the great pleasure of working with Sasha on a number of projects recently. So Sasha. This one should, the big green button. Yeah, that one should work.
Very good. And good morning to everyone. So, what I'd like to talk about today is really from the transit perspective, is understanding, where's the fit? Where do we bring, electricity and transit together? So our journey to electrification starts with, recognizing that we were partners in the past. We were friends. And there's emerging approaches coming again, and that's great to see that collaboration. But then at the same time, there's challenges for both industries. Transit and power have their own divergent issues, and they need to come together. So where's the fit? And that's what we're going to talk about. So we were partners in the past, recognizing that in history, electric utilities used to run and own transit. And they were all over North America, even right here in the great city of Winnipeg with the Winnipeg Electric Company. So they were prevalent. Ontario Hydro and Ontario, the precursor to OPG and Hydro One, very active in transit. As you can note, there was a lot of local street and radial network railways run across the province, from Toronto to Guelph to Winnipeg to Hamilton. Ontario Hydro played a lead role. So, we're starting to see some interesting partnerships emerging once again. And, as the previous panel spoke, there's a lot going on in California, especially with their innovative clean technology mandate from CARB. We're seeing a lot of positive movement in the state. First we look at the California Public Utilities Commission. They've stepped in with really a leadership role on creating a transportation electrification framework. So that framework, we're obviously insular, we're looking at transit, but they're looking at electrification across all industries. So that in itself presents a whole other challenge. So looking at rate design and principles for zero-emission vehicle fueling and getting the price right so people can afford it and agencies can afford it. We're seeing, some of the electricity providers in the state emerging with some really interesting approaches. For instance, Southern California Edison, SCE, they've stepped in and developed a charge-ready program. And what the charge-ready program is, if you allow them access to your land, 100% funding for electric vehicle charging infrastructure, including transit. If you don't give them easement to your land, 80%. So not a bad deal either way. You get 20 cents, it's costing you 20 cents on the dollar, in worst case, to design a charger and an infrastructure to your liking. So an interesting partnership. They're also waiving demand charges. So for those that aren't familiar with electricity jargon, demand charges are the highest price for your highest demand to account for facilities, building power generation, utility lines, etc. So what they're doing in the case of SE, they're waiving those demand charges until 2024, and then ramping them up slowly and incrementally. And an interesting development in the state is that they're guaranteeing price matching equivalent to the cost of diesel. So that sounds nice for agencies that are running diesel, but in California there's a lot of agencies running natural gas, which is a lot less price. So that presents a problem in California, which I sit on the Zero Emission Bus Task Force for the California Transit Association. We're dealing with that right now, saying, well, the cost of diesel is just not good enough because we're paying the cost of natural gas. When we look at the Pacific Gas and Energy and Electric, their strategy is an interesting one. They're developing a commercial rate as well, one that's targeting to be lower than the cost of diesel. So we're kind of in that in between, diesel and natural gas. They're also looking at subscription charges. So as opposed to having those high demand peak charges, having more of a subscription-based access to power is what's emerging in their situation. Also looking at the volume of time of use charging and how that relates. Obviously, if you're charging off peak, it's going to be less expensive than charging on peak. So there's some encouraging developments certainly in California. But electric vehicles bring challenges to both transit and power. Transit's core business is moving people at the end of the day and providing high quality service. Not to disrespect any of the transit agencies, but the staffing and the sophistication that's going to be required to manage power the way it really needs to be managed is probably beyond the capabilities of most. There's some large agencies that probably can take that in-house and do it very well, but I'm going to say that a lot of the smaller agencies, mid-size, may not have the capacity and the experience to really manage power the way it needs to be. We've gotten away from having relationships with electric utilities. I mean, transit agencies have had no reason to engage their electric utilities. But that's changing. So now we need a new partnership and a new strategy for that. I'm going to argue that electric utilities are in a better position to manage overall load. Again, we're looking at it from our perspective at the transit agency level saying, we need power and we need it now. But the regulator and the electric utility is looking at it from a broader perspective of managing entire load. So I'm going to suggest that they're better suited to manage that entire load for the whole system. And coming down to the charging infrastructure itself, again, not a core function of transit. And I think it's better left to other partners who are really experts in that field, just making sure that for transit's ability, the infrastructure is ready, it's available when needed. We talked about demand charges. I heard a presentation at the American Public Transit Association a couple months ago from Denver, and they were saying 85% of their bill is only the demand charge itself. So the power cost itself, very small. And they were quite terrified that they were going to lose their jobs, frankly, when they got their first utility bill, because they weren't prepared for that shock. So demand charges make up the bill. Energy storage can help, but who's in the best position to own that energy storage? Should it be at the agency side, or should it be at the electricity utility side? Again, managing that overall load. That's a discussion we need to have, and we should have it today. When we look at it from the electric utility side, they have their own challenges. This mass uptake now of electric vehicles is something that needs to be managed. They need to be able to supply power to everyone, and of course everyone's going to need the power all at the same time. So this is an issue, and it's coordinating those charging loads and power availability across all different streams, moving power to where it needs to be at that time. And of course there's that funding question that keeps coming up. There's a lot of investment required. Who will pay for all this, and how will we pay for it? So we need a true partner, and that's what I'm advocating for on the transit side, that electricity is available and priced to sell when we need it. There's an interesting business case that presents with the electrification of transportation, in that the business case to invest in renewables becomes a lot more attractive. Because we have this predictable, stable load that's going to be required all the time, it's an asset for electric utilities and local distribution companies to invest in renewables. And this new term has been coined in California with this the curve up there, love your duck curve. And what the duck curve is essentially what is your demand for power versus, on the top end, versus on the lower end, how much is being supplied by renewables. So that gap kind of forms a silhouette of a duck. So that's the whole point of the duck curve. It's really trying to shrink that gap and really looking at whether the investment is there. And I think the business case presents itself for utilities to invest in renewables, because we can close that gap and make the duck curve less ducky. Also looking at, overnight charging and that strategy, we're going to have predictable demand. So the additional running time for more baseload generation makes sense. I think we can invest in more baseload to be able to charge vehicles, so that's all good. I'll also advocate for a price comparable to diesel in Canada. I think that's the right strategy to put agencies at the same, at the same playing field until that's figured out, of course with no demand charges. Turnkey infrastructure, I would say, is very attractive for the transit industry. We did talk a little bit about the P3 models. I think there's going to be some more discussion during the conference on the P3 models, but they're a viable solution. I mean, simply put, the mandates, and what I'm seeing even in California, we have a mandate, but it's unfunded, so there's really no way to pay for it. So how do we shoulder this cost burden? It can't be at the municipal level. We can't afford it. So that's something that we need to close the gap on. Also looking at, one pain point we hear from agencies, in California is the coordination of construction and really putting on street chargers. They don't like going through the whole permitting process. They don't like that. So turnkey solutions, I think, are the way to go. I'll also say that I believe electric utilities are in a much better position to maintain the equipment. Again, they're electrical experts, and we're all going to be competing then for the same pool of resources too. Service level agreements will need to be developed, meaning that when the transit agency needs that infrastructure, it's got to be available, and has to be down to the second, frankly. And last, looking at resiliency for power downs. I mean, this is a major problem, and we had a situation in California a few months ago where San Joaquin RTD lost power. They lost 25 of their electric buses. They had a 2-day power down. So fortunate for them, they still had their diesel buses kicking around. So they put them back into service, but not everyone's going to have that space. They're not going to be able to store dual fleets. So we really do need some resiliency solutions. Unfortunately, I'm thinking that those are going to be fossil fuel driven in the short term until something else comes up, and we look to the industry to come up with some of those solutions. So with that, I'll stop talking.
Thank you, Sasha. That was great. All right. Always a whirlwind tour. I appreciate the methodology. I sympathize. And so with that, I'm going to turn to Kim from BC Hydro. We've had a great opportunity to start working with BC Hydro a lot more in Vancouver around the TransLink project. And Kim has an illustrious history, not only as a manager at BC Hydro, but also in British Columbia within her role in energy conservation and electrification. So with that, moving over to Kim.
Good morning, everyone. Thanks very much for having me here today. I'm going to take you through a quick overview of BC Hydro and a little bit from a utilities perspective on how we support the electrification of transportation. So a few quick facts about BC Hydro, probably the most important being that we are a Crown corporation owned by the province of British Columbia. We do serve 95% of the population. We're very fortunate to have a hydroelectric system, so our system is 97.8% clean. So we have lots of substations, transmission line, distribution lines. And one of the roles that I do at BC Hydro is really supporting the transportation sector. So we're very interested in partnering with our customers for electrification. In my role, while I'm very fortunate to work in the transit space, I also support marine, we also support airports, we also support trucking. So there's a lot of different applications that we look to for the electrification of transportation amongst mass transit. From a utility perspective, the electrification of transportation is actually quite complex. I'm sure that's no surprise to everybody. But we have poles and wires to maintain. We have to worry about capacity to support that. There's infrastructure beyond the traditional customer drops. So as you were mentioning, Sasha, about who's in a better position to maintain charging equipment, who's responsible for the interconnection cost, charging infrastructure and management. So again, we look at it from an entire grid perspective, and if everybody electrifies at once, we suddenly have a lot more to manage than we did before. And there's, of course, different end uses that are of concern, one of them being rates and helping contribute to a positive business case there. I think this is probably fairly obvious, but there's certainly customer benefits to the electrification of transportation, so obviously displacing diesel with clean electricity in the case of BC Hydro. Cost certainty is a huge help, so having rates that are predictable over time so you can make a plan for a transition. Maintenance, we're going to see reduced maintenance costs with electric versus combustion engines, so that's great. And obviously there's employee and public health benefits with air quality, noise, and those aren't necessarily quantifiable, so to speak. From a utility perspective and overall perspective, there's still challenges. One of them would be technology, and the other one would be cost, so that's a factor of time, really. Charging infrastructure is a big one we spend a lot of time talking about. How is the infrastructure going to work? Where is it going to be? Who's going to pay for the cost to install it? Who's going to maintain it? For a transit agency, it's going to be a change to their core business. For a utility, maybe not so much, but that's something to consider. And of course, there's interest in rate options. So some time of use rates. Sasha had also spoken about demand, which has been a big discussion. From BC Hydro's perspective, we are a regulated utility, so there's a regulatory process involved. We do have the British Columbia Utilities Commission that we have to report into. So a few things that I've been working on along with everyone at BC Hydro to help reduce some of those barriers in the electrification of transportation is we've developed a transportation sector team, so a team that's specifically dedicated to transportation only. We have a working group that's comprised of various members across BC Hydro, different business groups, and we also have an executive steering committee that will help us provide expertise, support, identify, and reduce barriers. So as we're entering into this space, and so rates would be one of those things, or infrastructure, we can bring that up with our executive steering committee to talk about how we can address that and how quickly we can address that. That's been a huge help. And one of the outcomes of having this working group and steering committee is that BC Hydro in August filed a rate application with the BC Utilities Commission to minimize rate impacts of electrification. I've got a bit of a model I'll take you through very quickly, but we have proposed a fleet electrification rate that will be of benefit to those electrifying. One of the other things that we often do is we try to identify process improvements to help expedite and make it easy for customers to do business with us. We know that sometimes the utility is not the easiest thing to navigate, not the easiest place to navigate, so that's why you have people like me and other of my peers in the room that are here to help make it easy to do business with us, help you understand what our process is, and also help us identify where we can improve our processes. Another part would be to educate and collaborate with organizations, customers, and industry, helping to identify opportunities and address barriers. So I have the fortunate fortunate opportunity of working with both of our transit agencies in the province, and you will see that we've partnered and talked about what the barriers are, what the challenges are, and we're able to navigate things together as opposed separately. And that just sums up the bottom there, that we partner with our customers in their strategy to transition to low carbon electrification. The sooner that we can be having these conversations with our customers, with transit agencies, the better. Then we can inform them of our processes, what we can, what we can't do, what we can potentially change, what we can't change, and vice versa. The more we understand about what's a concern to transit agencies, the better we can serve you. Oh, some of this information is sort of blocked out, so I apologize for that. But I just wanted to walk you through really quickly 2 of the electrification rates that we have proposed. And it really follows the sort of depot charging and en route charging model, if you would, for transit. So we have a time of use rate, which is really an overnight rate. So it would allow your buses or vehicles to charge overnight during our off-peak period, therefore bringing the cost of the demand right down. And then there's an energy-only rate or a demand transition rate. And that would be more for your en route scenario. So we're trying to minimize the demand impacts for when transit first starts off. So if you have an en route charger and right now you only have 1 or 2 buses on your system, you're only maybe passing through that charger once an hour, so you're setting that peak for 5 minutes once an hour. Once you start having 20 or 30 buses on that route, then that demand charge starts to level out because you've got buses passing through that charger maybe every couple of minutes. So that demand transition rate is really meant to help ramp up the electrification of transit, and then at some point it'll level off and we'll just end up on a regular rate. So I apologize that the slides don't look very well, but this is just a little bit more of a summary about that overnight charging and the energy only rate, which, like we said, is filed with the British Columbia Utilities Commission. We have to go through a regulatory process, which we're probably just about to start in a couple of weeks. So it's not been finalized at this point. All it has been is proposed. And so we sort of have to go through a bit of a hearing process to justify those rates. But hopefully the next time we gather, we'll have some good news to share with regards to where we are at with the rates. Thank you.
That's great. And I think it's a general trend right now. Everywhere we go, we hear there's new hearing rate applications going in and new hearings around it. Toronto Hydro just had one, and everybody's waiting for the outcome of that. There's a whole number of them in the U.S. and obviously with BC Hydro. So with that, we're going to turn to John Roulette, Director of Energy Solutions at ENMAX, the voice from Alberta, as we were hoping to obtain a little bit more of a voice from the western side, given that we're here in Manitoba. And everything, I think, east of Manitoba, if you live in the east, you think everything is western. But in reality, if you're in Alberta, you know, Manitoba's pretty central, so we did want a Western voice, and thank you so much to John for coming out from ENMAX. We're really quite keen to hear about the new strategies that ENMAX is proposing.
Good morning, everyone. Happy to be here. It's like a classic joke from a movie right there. Left and right? Just big button at the top. Okay, here we go. And now for something completely different. So I'm, as mentioned here, from Alberta. I work for ENMAX. So we are effectively a vertically integrated utility in Alberta. But then things change. For those of you who don't know, I'm going to spend a little bit of time here just describing how the Alberta utility market works, because we are unique in Canada. And I'll do that by giving you a little introduction to ENMAX and who we are. Very busy slide. We won't go through the whole thing, but there will be a multiple choice test later. So see how many numbers you can remember. But very quickly, to give you an overview, as I say, vertically integrated, we participate in the generation market. We have 1,600 megawatts of generation, which ranges everything from 800 megawatt combined cycle gas plants all the way down to distributed solar on residential buildings that we are involved in. We are active in the wholesale market. We own and operate the wires distribution system for the city of Calgary, and we are the largest retailer of energy in the province. Now, within that, though, there's different pieces. In Alberta, the generation market, the wholesale market, and the retail market are what we refer to as deregulated, However, a better term is probably competitive because there are still a lot of regulations and rules to follow, but it is a competitive market. In your energy market, you run your generator, you can sell long-term contracts, or you can take the hourly pool price, which changes every hour. So you get some variability there. As a user of energy, you can pick who you would like to purchase from. So there are different competitive offers out there. Everything from hey, I will pay market price, so I will pay you that hourly price in the wholesale market, plus perhaps a small retail fee, or things like 5 and even 10-year contracts where you lock in pricing. You can have on-peak, off-peak. There's any number of different things that occur. That, of course, is different than the transmission and distribution side of the industry, which are regulated. So within our company, within ENMAX, we have sort of those two pieces, the Chinese wall between the two, where we can't talk about what's going on the other side to maintain, the appropriate sort of relationship around competitiveness, things like that. So all of this introduces a very interesting dynamic when we talk about serving customers and emerging markets and new types of services. The other thing that we do, which I think is somewhat unique, is that through our power services business, which is also a competitive business, we actually take part with our customers behind their meter. We have a fairly sizable distributed solar business where we actually provide turnkey solar projects to our customers. So those are behind their meters, connected to their facilities. We design, install, finance, and provide O&M services for those kinds of systems. We are doing that now. It's very fledgling, but starting to do that with stationary storage solutions. So we're looking at that. We also do a fair bit of high voltage work. So customers who need, high voltage switchgear or perhaps even substations, industrial scale substations and things. And all of that happens in our competitive side. Of course, on the regulated side, then we get into, I think more what you would typically see from your distribution company, wires and poles down the sides of streets, neighborhood transformers, the substations and all of that equipment. Which of course then comes with all sorts of rules with it in terms of what you're allowed to do on the regulated side. So I will flip to the next slide to talk a little bit about the strategy that we're looking at here around electric vehicles. I'm going to echo a few of the things that I think we heard this morning. We see this coming, but there's going to be some required changes to various business models to support the electrification of urban transportation and transit. That's changes from the utilities point of view, also from the transit operator point of view or the fleet point of view, and we're all trying to figure that out right now. Looking at it from our perspective, and this is, again, relatively new for us, sort of fledgling, we're trying to figure out what role we can best play, where we can best compete, and what kind of service we can offer to best move this market forward, because, don't get me wrong here, we see this as an opportunity. In fact, I will argue, even with those within my company, that this is one of the biggest opportunities we have across all parts of our business because it's shifting a fuel source, right? Generally, growth in the electricity industry at the moment or historically has been, well, if you build a new neighborhood, if you get more buildings, you get some more industry. And then there were guys over there running on liquid transportation fuels. And now we're starting to see that merge. So to me, that's actually pretty exciting. We see big opportunity. The question being, where do we play? You can see up here, what we've kind of identified is the pieces in the middle of this. We don't see ourselves becoming experts in electric vehicles. There are people in the room who are experts at that, and we will hope continue to be. So we see ourselves playing differently. We see ourselves playing in that battery space, or the actual asset space, again, because we have synergies with our generation fleet. If there is a second life to battery storage, we feel that we could be very well positioned to value that and take advantage to that, as opposed to a transit authority who typically are not in the generation of storing energy and or producing energy. Charging infrastructure, we see that as something that could be right in our wheelhouse. I appreciate the comments earlier about who might be best suited to do that. I have a phrase that I use with customers all the time is that, well, what's your day job? Our day job is to generate electricity, it's to transmit electricity, it's to handle the equipment that manages electricity. Most of my customers' day jobs is either to run a transit agency or perhaps a manufacturing facility. So it's not their job to become an expert in, say, rooftop solar. We can do that. They need to be experts in their day job. So there's sort of an alignment of tasks. And of course, the electricity piece, we are a generator, we're a retailer. We can tailor, products and services to that. Just below is a little summary of where we see, different services. So the engineering, there should be a comma there, my apologies. The engineering, procurement, and construction of electric vehicle infrastructure, capital investment programs. Right now, with our distributed solar product, over 90% of it is financed by us. Typically on long-term agreements with our customers, 15 to 20 years is very common. We're willing to do that because of who we are. We're going to be around for a long time. We're not going anywhere. We think that may have application into the EV space as well. And then operation and maintenance services for the infrastructure. Again, likely not the vehicles themselves, but for that electrical infrastructure, the chargers and all the pieces that come with it. Before I sort of move on and we can get into discussion, there is a big challenge here with sort of in the Alberta market, that competitive side and that regulated side. We heard about a couple of the rules, and we saw examples of an ask to the regulator to say, hey, can we do these things? And that's a challenge that we have in our company and in our jurisdiction, in that right now in Alberta, there is no mandate for a regulated distribution entity to get involved in this whatsoever. And in fact, there are no drivers for them to get involved. There's no sort of signal from government saying, please do this to reduce carbon from transportation, or to help municipalities, or to help transit. So there remains this question of, well, will that signal come? Because if it does, it changes the market, and it changes the landscape, and it changes where you may be able to make investment or who can make investment. And I would suggest that uncertainty at the moment may be working to slow things down. It's hard to say at the moment because it's all still very nascent. But we see that as a big challenge going forward, who will have the ability to do what, who is best suited to do it, who can do it in a most cost-effective way, all in the sort of drive to see more adoption and roll these things out. So all these things that we are struggling with. I will end very quickly because I see my time's up, just to show that we are actually trying to walk the talk within our own fleet. We have a very large fleet, which is captive to the City of Calgary effectively, because that's where we look after all the wires systems and the infrastructure. So we're actually in the middle of something, we call it our E-Fleet pilot. It's effectively partnering with Navistar to get two sort of, I'll call them mid-range, sort of Class 6 vehicles, new vehicle platforms to the market into our fleet to test it out. That helps us deploy some charging across the city, which hopefully will have some synergy with other potential users like City of Calgary Municipal Fleet. So just something that we're ticking away at. I know today is about transit, but we sort of see the opportunity for synergy and sharing across networks and across platforms, and hopefully what we can learn here can also help us support our transit customers as we go forward. So with that, I'll leave it there and we can get to the panel discussion. Thank you.
So that was a great segue. And in fact, I think although we're here talking about transit, there's a reason we were so focused on standardization, interoperability. It's because everybody here, I think a lot of people here, certainly we do at Cutric, think electrification of transit is just the segue. It's just the segue to coach and truck and delivery vehicle. And electric vehicles as personal automobiles, they're a bit tougher because you have to convince a household to buy that car. It's a household economic decision. But fleets and trucks and buses and coaches, if they can use the same infrastructure and have the same fuel provider, that's a much bigger win in the short term, at least for the public. And John, you've made a great introductory comment to our first question to the panel, and that is where you said, you don't have a signal in Alberta. You haven't gotten a signal from the regulator to say that you ought to be investing in these spaces. And in fact, about 4 years ago, we started a power providers working group in Ontario, and we called together Ontario Power Generation, a whole bunch of local distribution companies, Toronto Hydro, OPG, Hydro One, all of them. And the whole idea was from the Ministry of Energy in Ontario to figure out if the utilities could decide what they needed the regulator to do. And we had the regulator in the room, the Ontario Energy Board. And I remember one day when sort of the lawyer, she was very vehement about it, and she kind of slammed her fist on the table at a certain point, just frustrated and upset. And she goes, listen, tell us what you need to do and we will create the regulations, but we can't just create them from wind. We need a minister to tell us that that is actually what the regulator ought to be regulating. And right now, regulators in Canada typically need to keep electricity fair and cheap and available and essential. But very rarely, and in fact, I think nowhere in the country currently does the regulator say, and environmentally efficient and clean and oriented around zero emissions. But they've started to do that in California. And so that's the signal that you've referenced. And that leads us to our first question for the utilities. Should utilities in Canada have an electrification of transit and transportation strategy? Because almost none of them do. At the highest levels of decision making, there's no document that says this is the plan, this is what our role is going to be, and this is what investment we need and ministerial support we need in order to get to that target. Because right now, who's steering the ship? So that's the question, and we're going to start off, maybe John, on your end. Do utilities need, or ought they have a transit and transportation electrification strategy in Canada?
So I'll start by saying yes, I think they should. As I mentioned earlier, I think this is actually a big opportunity for growth in the electrical industry. I'll leave aside even the advantages to greenhouse gas, air pollution, all those sorts of things. Just if you're interested in your core business, here's a new market to go after. Here's something that can promote growth, that fits with what your traditional business was, if slightly different in nature. I think the big challenge with that is what we were talking about, though, on that regulated side. And depending on the market you're in, vertically integrated Crown Corp, very different than what we have in Alberta, and again, different than Ontario with, sort of the larger infrastructure and I think 62 LDC companies, municipally sort of driven LDCs, who each one has their own set of rules and constructs and everything else. From our perspective, we're looking at this and sort of saying, and in the Alberta context, we see it as an opportunity. Now, the signal to do that, needs to be economic in that point. It's like, is this a business opportunity for us to serve our customers because our customers are going there? Why are the customers going there then becomes the question. California did this because they want low emissions from transportation. The government basically turned to the regulator and said, we want this, help the utilities get there. Frankly, that's what a regulator loves, because then they go, great, this took it out of my hands. Government said, do it. We'll keep it as fair and efficient as we can. Hey, utilities, come back with a plan and let's move ahead. Maybe an oversimplification, but bear with me. In Alberta, we don't have that. And because it's in a way separated, carbon emissions in our electricity system are handled, through effectively the Minister of the Environment on generation. The wires companies in the middle, the regulated distribution entities and transmission entities, all they do is move electrons. They actually don't have emissions, and they're not responsible for the emissions either on the generating end or the end use. Therefore, our regulator looks at that group and says, well, we really don't have a mandate to tell you to help somebody else reduce emissions. Right, that has to happen. That happens on the generation side. Mm-hmm. It's a different place. So somewhere in that mix, in that sort of hot mess of stuff going on, is there the economic growth case that utilities should be interested in this market? I would argue yes. You're going to have to figure out, given the construct of your market and your regulatory regime and everything else, how you play in that. And then you get into, why is the customer going to do this? We're quite excited to work with Calgary Transit. We know they're looking at this. We want to help them along as we can. We are, wholly owned by the City of Calgary, so there's a great synergy there. But this has to make sense to them. And again, no one is coming to them and saying, hey, we'll give you, at the moment anyway, a lot of money to do this for, say, climate change purposes. Sure. It's more the business case. So
okay, so we need a kind of political economic driving factor combined, and possibly what you've referred to also, John, is a reorganization potentially of the energy system and the energy market may be required if it is in fact the case that some of the deliverers don't have the mandate and the action is occurring at another end of the spectrum. So we'll come back to that. And Kim, from your perspective as a Crown Corp utility, do we need transit electrification strategy?
I'm going to broaden that out a little bit to say, overall, I think we need to have an electrification strategy. So again, from a utility standpoint, we're going to stand back and look at where is our largest opportunity all over the province to reduce GHG emissions. Does that include transit? Does that include transportation? Absolutely. For us, it's a broader picture, and we're very fortunate in BC to have a lot of sentiment to reduce emissions. We've got different cities that have targets. We've got different organizations, you name it, that has targets. So we have the motivation. We have the energy. We're vertically integrated, so that'll allow us to do that. I think from a policy perspective, that's probably where we do need help, unlike California, where the government has dictated to the Utilities Commission what they want. Our current government is trying to make things a little bit more transparent, be a little bit less hands in telling the Utilities Commission what to do. So that's, I think, to some degree kind of slowed things up, but I think there's absolutely a sentiment to do the right thing. What we do need is a little bit more push from policy once that falls into place, and I hate to sort of take that Crown Corp stance, but you know, if we were mandated to do more, we would absolutely be able to move things faster than we are doing currently.
Okay, so decision making still comes from the top, and at the end of the day, there's no way to get around it, although there may be more democratic ways of approaching the actual policy.
Yeah, I don't want to say to a degree there's nothing we can do to get around it. I think we can help inform. We can help inform our customers. We can help inform government what's going on, what will be helpful, but we still unfortunately have to let process play out. And we try to do what we can in the meantime to help fill that gap until we have something a little bit more overarching to I don't want to say force us, but force us in that direction.
Yeah, and they're interesting insights because you can see we've got ENMAX and BC Hydro here. Well, we've got a lot of partners at Cutric from the utility sector, from BC Hydro to Manitoba Hydro, Nova Scotia Power, a bunch of LDCs, OPG. A lot of folks did not want to be on the panel. And the companies really discussed the idea of being on the panel, and it's important that we have this kind of panel, but did not actually want to be on the panel. And the reason is simply because there isn't an internal coherent position to articulate publicly, and that is pretty indicative of where we are in 2019, if that's the case. And I think as Canadians, we have a lot of work to do, and our politicians at Ministries of Energy have a lot of work to do to give these signals.
Yeah, and I think we wanted to participate just in large part because it's a learning. We want to share what we've learned. We want to learn from others. We want to find out what everyone is doing, and if you're not willing to sort of speak out about the reality of where things are at and share your experiences with customers and vice versa, we're never really going to move forward. You know, for a large part, California does set the precedent, so I think a lot of us sit back and watch and look to see what California does. They do a lot of great things. They don't necessarily do everything right out of the gate, so there's an opportunity for everybody to learn from that. So it's unfortunate that we're not necessarily the people out there leading, but we're coming in close behind, and we're happy to take that position and learn from it so that when we implement it, we can implement it well.
Fantastic. And a voice from British Columbia, which I think it's fair to say is probably the last standing provincial jurisdiction outside of Quebec that aligns with federal climate action goals. And so that is indicative of also where we are in terms of what the utility can and ought to be doing. And Sasha, you work in California a lot with transit agencies and utilities trying to electrify entire fleets that are running around with like chickens with their heads cut off, trying to figure out how to do this in a very short period of time. So what is it? Do utilities need a transit electrification strategy?
And
yeah,
there we go. Absolutely. I think there's a need. You know, California's taken some great leadership. Is everything perfect? No. And, you know, through the ZEB task force that I sit on, I mean, we're having the discussions that that need to happen. I mean, we have disjointed parties still. You know, we have CARB setting regulation. We have the utilities doing their thing. We have the transit industry that's now burdened with a mandate that's unfunded, and they don't know how to achieve it. So we're all trying to align the pieces. I mean, I'll give California credit that they did develop a roadmap. It's working. At least it gives us a strategy. You know, rewind back some almost 10 years ago, I worked at the province of Ontario, and we were developing an electric vehicle charging infrastructure roadmap. And how far should the province of Ontario go into electrifying fleets? And here we are almost 10 years later, and not much has really happened since that work that I worked on even back then. So we're catching up. I think California is doing a good job. There's going to be a lot of lessons learned that emerge out of that, and we're quickly seeing those lessons. So stay tuned, but I think they're doing the right thing at least, and they've stuck their necks out, and everyone's watching very closely, and everyone in California knows that.
So with that, we are going to turn to questions from the audience, and we do have 2 microphones here, so if you have your question, line it up. But in rapid action fire and parliamentary rules of 60-second queries, one of the things we've experienced over the last few years, and certainly that we've alluded to, is most ministries of energy themselves don't have a transportation plan. So most transportation ministries don't have an energy plan. That's the case. We have 10 provinces. You would be hard-pressed to find one ministry of transportation in the country that has an energy transformation plan. You would be equally, if not more, hard-pressed to find one Ministry of Energy in this country that has a transportation electrification plan. And we have faced this in all provinces that Cutric has operated in, where there is no coordinated transportation energy matrix plan. And that is about holding hands across mandated levels of government to transform this industry. So in 60 seconds, essentially, if it were the case that the ministries woke up tomorrow and ministers said, look, we shall have this plan, and here are the price signals, or rather here are the market signals or the environmental signals, thou shalt provide the fuel of the future. The question to you is, can utilities be the fuel providers of the future, and how quickly could that happen? If tomorrow the mandate were there and the signals were there, how quickly could our utilities displace petrochemical industries and being the fuel suppliers of the future for transportation? John?
I get to start, eh? Okay. Great answer I heard at a conference last week. It depends. To be honest, at a certain level, we see this as opportunity. We're not too concerned, particularly in terms of supplying the actual energy. Alberta's long on generation. More can be built. Like, we see that as fairly straightforward. Infrastructure is another issue, though. When and where the demand comes, we heard a number earlier that, hey, yeah, it might be 3 to 5 years to get you, the transit authority, what you need. That might be on the outside for our jurisdiction, but it, like I said, it depends. If you start turning transit barns into small industrial electrical consumers that require a new substation, et cetera, that's not an overnight process. Personally, I think it can be accommodated. I think it can be worked through. The big challenge, though, is that comes with very high upfront cost, which can be prohibitive depending on whose balance sheet it sits on and how those costs are distributed. And there's also the issue of, well, what are we asking for today versus what do we think we need in 5 or 10 years? Do you build it really big and hope it'll come? That's challenging. Do you start small, but then you're constantly trying to catch up? There's all of those issues that come into play, which are difficult to work through. So the overarching question is, we can do a lot of it. Like, it's going to take a bit of runway, but we'll get there. It's not an impossibility, but it's not a, hey, yeah, by the end of the year we can have, the whole bus fleet electric and there won't be any growing pains. We're not there either.
Okay, so it might not be a 5-year solution strategy, it might be more like a 10-year transition strategy, if in fact the political mandate were there, which is the big question mark. Go ahead, John, the last comment?
No, I was just going to say yes. I mean, that's where it comes back to that. Well, it depends, right? What's the demand from the market? How many, how fast, where are they going to charge, what they're going to charge, and all of those things, there's a myriad of options in almost each of those categories that trying to figure that out is challenging.
Right, quite complex. So Kim?
Yeah, I would echo the exact same statement. I think we're well in a position to be the fuel provider of the future. We connect people every day, all day. That's what we do. This really shouldn't be any different. However, again, let's refer to depot versus en route. If you're doing en route charging, it's a higher charge in a denser population. Maybe the wires are a little bit more difficult to get to, or they're underground. There's civil work required. That can get quite complex. Or likewise, if you're converting an old bus barn into something that's electric and it's a 30 or 40 megawatt plant, I mean, that's like a small industrial facility that you're building. That doesn't happen overnight. There's engineering that's required. There's coordination of land and properties and rights of way that needs to be negotiated. So from a fuel perspective, we're also long on energy, so that's not a problem. It's just the actual physical infrastructure and wires piece that I think would be a little bit more time consuming.
So another kind of 5 to 10 year civil works transition, if in fact the mandate were there to start yesterday.
Fair enough. Yeah.
Okay. And Sasha, from your experience?
I'll be the Kevin O'Leary in the room. Where's the money? It's one thing to have the political mandate. I think we can move pretty quick on the actual engineering and all that stuff. But there's got to be the money behind it to support that kind of a mandate. it could be done. I mean, it's going to be very challenging. And again, we're gonna have resource constraints. There just isn't enough people to do all this work simultaneously. It might take a little bit longer than. I know we're all very enthusiastic and everyone would like to move very quick, but the reality is there's so many electrical engineers. There's so many people that can work at once. So we're gonna have resource constraints again across the professional services industries for sure, and need to manage for that.
Okay, so it's going to cost something, and it's not a small amount of something. But we've heard this many times. I mean, the electrical infrastructure in Canada needs a massive upgrade anyhow. From left, right to center, there's a massive upgrade that's required. This is maybe just motivating that dialogue. John, last comment, then we'll turn to a question.
Yeah, and just to hit on that cost, like one of the big issues is the issue of stranded cost, right? We're already seeing that in some unique instances. And actually just last week, the Alberta regulator had a 3-day conference around DERs, distributed energy resources, but they included electric vehicles in that as well, sort of thinking, hey, this is a big trend coming. And that is something that's going to need to be figured out, because from the competitive private sector, if you're going to build a lot of infrastructure, you either need a customer to commit to it so that you know you're getting your return. The customer has to know they can commit to it. They can't change platforms in the middle of that, of paying off that infrastructure. Or if it's a regulated utility, if they build it and it doesn't come, or it changes, or we build 30-year infrastructure which changes, how do you account for that? Right?
Yeah, and people have
difficult.
talked about this already in Ontario, where money has gone out the door for DC fast chargers, in some cases backed by utility, and it is stranded. And so the question is, was that good taxpayer use dollars or not? And so we'll turn to Catalina Gallo from ABB. We've got questions, so I can ask you to answer in about 45 seconds each.
If a picture were 1,000 words, I think somebody asked me earlier, what does Cutric do? And the image before me, in a time of fractious constitutional Canadian debates on energy transfers, having Alberta and BC together on stage is awesome. So thank you, Josipa, thank you, Cutric. My question is, in view of the funding question that keeps coming up and up, don't you think it would be great that if we manifested a bold vision or strategy on electrification, that global financial markets would be interested in investing more?
Great. So a question on that financial innovation theme. Is there not a possibility that new sources of investment capital would arise if, in fact, there were these strategies driving the creation of a marketplace? And we'll start with you, Sasha.
Yeah, I think there's definitely a role for the P3 market and the new financial market stepping in. As I kind of alluded to, there's just the municipalities can't shoulder the burden of this cost. So I think there is a role for the financial markets to step in. It's financial markets like infrastructure. It's predictable. The payback is pretty good. But on the municipal side, the issue then is, we can borrow less. We can borrow at a cheaper rate. So there's always that risk transfer that has to come in any P3 model, and the way you structure it, making sure the risk is anchored with the party best able to manage it. But I do think you're going to see that interest. I think, there's a lot of business cases, at least, people are even coming to talk to me that, we should approach transit agencies and talk about renewables and how we can save them some money, and this will pay for itself. And it all sounds great in theory, but I think you're going to see a lot of innovative solutions emerging. I agree with you.
And certainly one of the worries that we've heard about is if there isn't financial innovation and investment, then the ratepayer is going to have to carry this. And that means my electricity bill for my 500 square foot Soviet-style condo is going to be $5,000, right? And the ratepayer cannot carry the cost. So potentially investment from foreign or global investment sources. Kim, is that a possibility?
I think it's a possibility. I think that's what's being weighed out right now. Who is best suited to serve that? And that's a question that hasn't quite been answered at this point in time. And I think from a utility perspective, our utility perspective, I think to a degree, we're sort of indifferent about who we connect to. If we, so we're happy to serve whoever we serve. We're still going to be a partner. We're still going to be a part of the game. But yeah, I think there's opportunity there.
Okay, new sources of income and revenue?
Yeah, I think it comes down to the market signal and the risk. It was already touched on. I don't think we'll have any trouble getting capital for this if there's the right sort of vision of a market and the use case. Look at renewables as a parallel, I think. If you put in policy that had a target for renewables, which created a market of a certain size, really nice when they came with 20-year government-backed contracts. Capital flooded in from all over the world floods into those jurisdictions, and I mean floods. But that's because the risk there is very, very low, and they hunt it. If you need the capital to come in, it's that question of risk. I think it'll show up once people either get comfortable with that market, or if there's the policy and the rules that basically dictate this market is going to exist.
Fantastic. And I'm going to, last comment, and then I'm sorry, Doug, we've run out of time, so I'm going to ask you to hold on to your question and ask the panel afterward at the reception.
And I stood here so long.
I'm so sorry. Well,
we talk too much.
I mean, I'll just add, from my perspective, when I was at the province, I was structuring P3 deals with municipalities. And one of the caveats here is that municipalities are going to have to open their minds to a different type of partnership. Municipalities are slow to make those kind of rash decisions because councils are thinking of 4-year terms. They're not thinking 30 years. So to get them to bind them to a 30-year contract, very difficult. And at my time during Infrastructure Ontario, we were very slow to get municipalities to move on P3 projects. So that appetite has to be there. There's some cities that are sophisticated, but others need a lot of convincing. And the issue then is once they understand what the total life cycle cost is of the asset, because many municipalities work in capital costs. They're not really thinking about the O&M that comes with it. And once you put that true, total cost of ownership number out there, they get scared. So we need a mindset in how a mindset shift in how municipalities operate too to be able to push this really forward.
Yeah, and we've heard that a lot, Sasha, as we've moved into, and we'll talk about it a lot more in the upcoming panels, innovative finance P3 models around transit electrification, not classic ones, but really innovative ones that our whole system plays. Maybe the utility is actually part of that P3. And one of the things we've heard is, look, there's some cities in Canada that legally will never take on debt. They will never take on debt, they'll never take on finance, and so you're stopped right at the door. There is not even a dialogue to be had. And if we've understood what our panelists have said here today, that ultimately in the utility sector and electricity sector, we need ministerial mandates and decisions, and maybe that is ideological, but if we do believe that climate change is nonpartisan, then perhaps actually acting and creating the regulatory environment, or at least the market signals for electrification at the utility level actually just becomes as standard a business as building wires and posts to carry those wires and distribution and transmission equipment. So with that, we're leading right into the future of transit electrification. I'd like to thank our panelists here at the utility side of the equation. And next year, back here, same time, same place, I suspect we'll have a fuller panel of utilities willing to dive deeper into the dark recesses of what the future of electrification in the energy sector will look like in Canada. Thank you to our panel. And I'll ask you just to hold there for a minute. So we're about 15 minutes behind schedule, but not to worry because we've caught up on 5 minutes. We'll catch up over the course of the next panel. We are going to break for a health break, and I'm going to ask folks to come back in about 15 minutes. We'll give you the signal that we're going to be starting the next panel. And enjoy your refreshments, and we'll see you soon.
We are going to go ahead and get started. So if everyone can please take their seats and bring their conversations to a close, please. If you don't have to get a seat, I'll just run there. Just as an FYI. Okay, can everyone please take their seats? And we will go ahead and get started on our next panel. Okay, so for those of you that might have missed the themes of the conference, we have two main streams that we are going to be focusing on in this conference. The first one is obviously what you've heard about all morning, which is battery electric buses. The second is really focused on first mile, last mile smart mobility, or the idea of smart mobility in a broader context. So Josipa is going to be leading a lot of the e-bus content, and I'll be leading a lot of the smart mobility content. And this marks the first panel on the smart mobility side. And tomorrow we'll be very heavily focused on smart mobility today. Tomorrow we'll be focused more on smart mobility. Today we are more focused on electric bus. So I'm incredibly excited for this panel, and I've been waiting for a panel like this for about a year and a half, although I didn't really know it. But when I first took over the Smart Vehicle project, I was probably in about my first month. We were about to have our first session, and for those who know the way Cutric functions, we have project sessions. We bring together stakeholders. We typically do presentations and put out knowledge that we have. And about a week before, I was still really new, and Josipa, my boss, messaged me and said, "I've been hearing a lot about C-V2X and 5G at conferences. Can you research it and present it next week at our session?" So being a good worker, I went to my best friend Google and said, "Google, DSRC versus 5G." And all I found was lots of numbers and frequencies and acronyms and nothing that was digestible to help me get down into the technicalities of what this debate is. So the way I function is if Google doesn't help me, then I go talk to people. So for the past year, I've gone to conferences. Everyone I see who I think might know something about this, I go up to them, I say, "Hi, I'm Christy, nice to meet you. What do you think about DSRC versus 5G?" And I've heard a lot of very passionate responses on either side of this argument, which I don't necessarily think has to be an either or, and I think likely will not be. But today, we're going to hear from two panelists who do have a lot of knowledge and experience in this area who can help us sort of figure out this puzzle of DSRC versus 5G and what are the proper applications for each of them. So our first panelist is Jason Conley. He's the Executive Director of the OmniAir Consortium, which is a leading industry association promoting interoperability and certification for ITS, tolling, and connected vehicles. Jason has over 15 years of experience in transportation and security technologies. He earned his law degree at the Columbus School of Law, at the Catholic University of America, and an undergraduate degree from Wake Forest University, and he is a member of the Virginia State Bar. Jason?
Okay, we're going to see if this works. All right, well, thank you. I would just like to begin by thanking Dr. Petunovich very much for inviting me here, and Ms. Malakar. We're very happy to share sort of our vision for interoperability and conformance and for connected vehicles. But I was very impressed this morning with the passionate and very articulate remarks in defense of electrification of buses and of smart mobility. And I think coming from Washington, I'm very, very keenly aware of how our leaders speak about these issues, and it's rare that I've heard such an impassioned and articulate defense of this industry. So I would like to commend Cutric on that and for moving this issue forward. Also listening today, I've been hearing from a number of panelists who have been talking about some of the issues of interoperability that that the industry is now grappling with charging stations and buses, and solving that problem. It goes a long way toward ensuring market adoption of the technologies. I can assure you that OmniAir's focus is squarely on certification, interoperability, and conformance of the connected vehicle technologies. And we do that not so much for focus on carbon reduction, but on saving lives. So across North America, over 40,000 people lost their lives last year in traffic crashes. And that number is an astounding 1.25 million when you look around the world. And when you think about these connected vehicle technologies that we'll be talking about today, have the potential of reducing 80% of those fatalities if you have widespread deployment. of even just a few of the applications. That's what motivates us. That's what motivates our members who come from across the spectrum of test labs, device manufacturers, deploying agencies, governments, engineering firms. And that's really our focus. And it's been our focus since 2004. Omniair, oddly enough, was an outgrowth of the tolling industry. And it was the tolling industry that really saw the possibility created by the dedication of 75 megahertz worth of spectrum for dedicated short-range communications in the 5.9 band, and what the possibilities could be for tolling, but also for safety, for public safety, for ITS. And so Omniair was birthed within the IBTTA, International Bridge Toll Tunnel Association, in 2004. For the first 10 years, tolling was much of our focus. We do have a certification program for tolling tags and readers that we continue to do, but over time, it's been increasingly focused on deployment of connected vehicle technologies. So we focus on conformance and interoperability testing. We are communications media independent. I'll be talking a little bit more about DSRC, just given the nature of the panel, but we do have plans for developing a similar certification program for cellular V2X at the appropriate moment in time. So Omniair's certification services, we do it both for tolling, we do it for connected vehicles, and we have a network of authorized test laboratories and qualified test equipment. And so when we stood up our certification program in the October of 2017 for DSRC, we recognized there was a need. There was an existing stack of standards known as the WAVE stack of standards, and there's a series of standards created by SAE, IEEE, and some created by the U.S. Department of Transportation. We developed a series of test cases against those. And so each of our labs has been audited for, they're all ISO 17025 compliant labs. They're names that you might recognize like UL, DECRA, Intertech. They're around the world. 2 are in Asia, and the remainder, 1 is in North America, 1 is in Europe, and the remainder in North America. We have qualified test equipment, 3M, Danlaw, Keysight, others that are able to run through our test cases. We have about 168 test cases for RSUs and 120 some test cases for OBUs. And so it's a very, very difficult thing for a device to become certified. But what that means is once that device is tested and certified, that can be trusted for deployment. It means that device meets a minimum interoperability requirements and it conforms with industry standards. And if you think about the purpose of certification and that independent testing that happens, it should increase market choice and decrease the prices, and that should spread deployment of the technology. And that was the theory behind certification, so I don't know if Cutric is thinking about that for electric charging, but I would certainly commend to you to highly consider a certification program once the standards are completed. So we have a test plan that is a sample here. It shows you some of the rigor that we go through for this program for OBUs. We do a similar, more extensive testing for RSUs. And so at the end of the day, you have a device that can be trusted. And we're here to prevent procurement mistakes. I've worked in government myself. How many people here in the audience are actually in government? Okay, so and how many have experienced what you might consider a procurement mistake that, maybe don't raise your hands. But so I had sold real-time passenger information systems, AVL systems, into smaller transit agencies before. And I think what I found is some of the agencies may not fully understand some of the complexities of the systems that they're looking to implement. And that implementation has taken longer, cost more money than they had thought. And some might consider some of those deployments to be procurement mistakes. And a certification program helps to address that. So we take care of the testing, and we have a third-party certification that will address that. So it should give confidence, if properly done, confidence to the deploying agencies, confidence to the OEMs to deploy these technologies. And so what technologies do we now certify? We have 2 certification programs, one for RFID toll tags and readers, and we have another for dedicated short-range communications. And that's what I wanted to talk a little bit about today. How many people are familiar with DSRC or connected vehicle technologies? So DSRC is a form of modified Wi-Fi. It's a short-range wireless communications. It operates in North America within the 5.9 band, a slightly different band in Europe, 5.9 band also in Korea, slightly different in Japan. And it's being used around the world for vehicle-to-vehicle communications and vehicle-to-infrastructure communications. And the idea is that there is a wireless broadcast going vehicle-to-vehicle, pulsed every 3 seconds to a 100-meter range. And that is a type of sensor that's non-line of sight. And so it sees through walls, and it helps communicate heading, direction, speed, all of this information about vehicles. And so that allows developers to develop safety applications on top of the that ride on top of these devices. And so there is a long history of DSRC. The spectrum was first allocated in 1999 by the Federal Communications Commission in the United States, and similar timelines in Europe, Japan, Korea, Australia, around the world. There have been standards programs that have been in place. Standards have been developed for years. Pilot projects. There are 3 connected vehicle pilot projects that are reaching their concluding stages in the United States right now. All of the devices there in those pilot projects are, in fact, Omni-Air certified. And there are active deployments around the country, and I think I have a slide that will talk about those active deployments. So if you'll see here, there are thousands of active deployments and planned deployments in the United States, numerous deployments across Europe right now. So there's an install base, and there's a long experience with DSRC. And for that reason, you'll find that the transportation officials in the United States tend to favor DSRC because it's trusted and true. However, we do have C-V2X coming, and I won't spend too much time on this, but I think one of the most interesting things about C-V2X is how fast the momentum behind C-V2X has been, how fast the devices have been progressing. There are 2 types of cellular connected vehicle communications. One is an LTE direct, and I'm sure you'll hear about that in a minute, communications that is a short term, and then there is a longer term network-based communications. It's coming along fast. You have lots of automotive OEMs, especially in Germany, Ford in the United States. You have a number of chipset providers who are rallying around this, Samsung, as well as Qualcomm, as well as others in China. And you have the Chinese government making a massive investment in this technology. And that's helping to drive some of the market. Unfortunately, what that creates is a challenge. That creates a challenge from a policy perspective of which one do you deploy. Do you wait to deploy this technology because there's something better coming, or do you begin saving lives now? Do you do that now? This is just a brief number of safety applications that have been developed through some of the pilot projects. Some of the more important ones are vehicle to pedestrian. I think that holds some of the great promise, especially in the transit world. Our chair of our board of directors is managing a pilot project in Tampa, Hillsborough, which has instrumented 10 buses with OBUs, and has also instrumented RSUs along a corridor. And they've also instrumented 10 streetcars, old-fashioned streetcars that run on the rails in Tampa. And they're doing several applications. One is transit signal prioritization, which allows a communication between the vehicle and the infrastructure to know whether that vehicle is running behind, and then that gets priority. There's also emergency vehicle preemptions, and then there are also applications that address safety issues with pedestrians and crosswalks. So there are innumerable applications that can be written to this and to help save lives, but you need to have a critical mass of that deployment to be effective. And I think that's one of the policy challenges when we talk about C-V2X versus DSRC. So I think the first challenge is this fundamental question: should the market decide? Should we have a technology neutral policy in which the market will make the decision as to what the best technology is and adopt that? And I think that's an important principle in many areas of transportation. However, with this, you have a public good to consider, which is which one is capable of saving the most lives more quickly. And so that's why you've seen some attempts to regulate this, both in Europe through a delegated act, which is now being revisited by the European Commission. You also have had an NPRM issued by NHTSA in the United States that would have required this in every production vehicle by 2023. Both of those have been put on ice because of this question of market choice and the recognition that cellular V2X is coming. The other question is wireless spectrum availability. There has been this enormous swath of spectrum that has been available at 75 megahertz. 75 megahertz worth of spectrum in the 5.9 band for 20 years. And there has been relatively minimal deployments. Lots of research, lots of standards, lots of pilot projects. But frankly, the automotive OEMs and the state DOTs have not utilized this to the extent that it was envisioned 20 years ago that they would. So other parties, because wireless spectrum is a finite resource, are coming to grab that spectrum. There's a push across spectrum for the need to push for 5G. So that's putting pressure on other areas. This is unlicensed spectrum, so the Wi-Fi industry is coming after this. The cable and television industry is coming after this because they want to see more spectrum available for unlicensed devices for entertainment purposes. So that's a challenge. Cybersecurity is a big challenge that we have to consider. There's over 100,000 lines of code in every new car, and the attack surface increases with every line of code that we've added. And so how do we address that? As well as the recognition that autonomous vehicles are kind of exciting and sexy, and so that's where the research money seems to be flowing now. I would just mention one thing that we talked about. We had Christina come and speak at our big event in Quebec last spring. Oh, goodness, you okay? And it's called a Plug Fest. And this is something that the electric bus industry, I don't know if you're doing this, but I would certainly commend this for your consideration. We partnered with a group called Propulsion Quebec, as well as with Transport Canada, and we had 250 people at the PMG track in Blainville, just north of Montreal, where we did field testing, bench conformance testing, group interoperability testing, security certificate testing over the course of a week. We're doing something very similar in Spain, coming up very shortly. And we learn in that process, device manufacturers may think those devices work. The systems integrators that are deploying those on behalf of agencies may think those work. But when they get there and they test this against different test tools and test labs from around the world, they learn otherwise. And we think this helps to improve the performance of the industry across the board. And so at the end of the day, through the series of these events, this event, the one that we're doing in Spain in a few weeks, is that you should have more market confidence to adopt these life-saving technologies. So Omniair, I would say, is communications media independent. We're actually developing a certification program for cellular V2X. We expect to launch that in Q1 of next year. But I think, as we think about this debate, there's some really important policy considerations. And I think one of the more important ones with the SRC that we just have to face is that it has a longer track record, it's more ready, and it's probably, cellular V2X is probably a few years behind where DSRC is. And so that's just a policy consideration that everyone needs to make as they make their deployment choices. Thank you so much.
Excellent. Thank you so much, Jason. I just want to reiterate 3 points that I really agree on. The first one is that our organizations are certainly kindred spirits in the standardization and interoperability focus. That's all Omniair does, and that's really what we do as well. I also think you really hit the nail on the head talking about how cities are in a dilemma. Do you now purchase DSRC, which is a long-standing technology that's been proven, modules are available, or do you wait for this new shiny, flashy CV2X 5G technology coming down the pipeline, even if you're uncertain when that's going to be available available and when you're going to get the speeds that you've been promised. And then the third point, which kind of speaks to that, is that the spectrum, as you mentioned, has been allocated for 20 years on this, and there hasn't been loads of movement in the DSRC space the way that they thought they would. So now you have all kinds of different groups, the 5GAA putting in petitions to open up that spectrum for CV2X allocations. You have other groups in the Wi-Fi sphere that are interested in using that spectrum as well for non-auto related purposes. So it's certainly a lot going on in this area, and that was really excellent, Jason, thank you. And so now I'll call up Boyan. Boyan's the principal product line architect for data communication systems at Thales. He spent the past 30 years working in the intersection of wireless communication technology and major industrial verticals in gas industry, public safety, and the military, and has held executive positions in the wireless OEM space. Boyan holds a master's degree in computer and microwave science from the High Military Technical School of Zagreb in Croatia. Boyan?
Well, first of all, thank you for invite and opportunity to speak about the intelligent transportation systems and certainly this very interesting debate that's ongoing in industry, similar to what I would say Betamax versus VHS. So let's start. I wanted to give a little bit of a history. Jason touched already upon that, but I think that history of evolution of intelligent transportation system is important to understand. FCC allocated this precious 75 megahertz of spectrum in 5.9 gigahertz range back in 1999. And importance of that spectrum was paramount because this was the catalyst for development of intelligent transportation systems back then. In 2004, US Department of Transportation and ITS working group have decided to use 802.11a layer 1 and layer 2 variant of the protocol to implement new generation of the vehicle-to-vehicle communication. At that time was the goal. And 802.11p working group was created soon after that. This was beginning of what is known today as DCRC, Dedicated Short-Range Communication System, which is an open source protocol for wireless communications between vehicles. ITS standards are also frequently called WAVE, DCRC, 802.11p. People in general use interchangeably these terms when they're thinking about this thing. US DOT and ETSI and ITS, they have invested significant effort over the last 20 years in the process of the standardization, testing, and the security implementation and solution for vehicle-to-everything based on the DCRC technology. And for a long time, DCRC was a synonym for vehicle-to-everything. This is what vehicle-to-everything is not. When we are talking vehicle-to-everything, in terms of applications that we are thinking to support over the time, we're talking about V2I safety applications, V2V, vehicle-to-infrastructure, vehicle-to-vehicle, agency data, environmental type of the application, road weather, mobility, smart roadside. Today, focus is on the safety part. So V2I, vehicle-to-infrastructure safety applications, like stop sign assist, curve speed warning, or red light violation warning, and V2V safety, like emergency electronic brake lights, etc. This is where the majority of the focus is going in terms of developing application in terms of the V2X. The others will come, but these from the safety perspective have the highest value. National Highway Traffic Safety Administration and Motor Vehicle Office, they did this study and in terms of the number of accidents that could be addressed today if the vehicles are equipped with the V2X radio communication technology. And numbers that they came up with are really, really high. I mean, we're talking 70 to 80% of possible accidents on the road that could have been addressed if the vehicle did have this vehicle-to-everything communication technology. I'm not going to go. So the DCRC, who started in 1999 2004 working group for 822.11p through this long process of the standardization, testing, hard-proofing technology, NHTSA in 2014 concluded a long set of testing and several long-term test beds, and conclusion resulted in the report that was entitled Vehicle-to-Vehicle Communications, Readiness of V2V Technology for Applications. NHTSA also wanted and moved for this to become a policy and mandated to be used on the light vehicles in the United States. However, Congress did not approve this decision. For whatever reason, maybe Jason can shed a little bit more light, being in Washington. But this move was not approved back in 2014-15, unfortunately, maybe. And in European Commission Directive ITS 2010-40-EU outline use of 302.663, which is pretty much equivalent to what we have in the United States and Canada, DCRC 822.11p. In Europe, this G5 stands not for 5G in terms of cellular technology, stands for 5 gigahertz because it's a frequency band. ETSI standard and US standard in terms of the DCRC are very much equivalent. There are some differences on the application layers, but similarity is significant. And everything looked okay, and then LTE, who is probably one of the most successful wireless communication standards in the history, with this constant evolution and improvements and technologies and number of applications that it can address, specifically LTE Pro C, proximity services, which was defined in Release 12 of the LTE standard 3GPP as a form of device-to-device communication. A lot of people started looking into that type of the technology and thinking, rightfully, that this kind of the technology can be applied as well for vehicle-to-vehicle communications. And 3GPP used Pro C as a starting point in terms of the technology definition for cellular version of vehicle-to-everything. This effort was finalized in Q2 of 2017 with Release 14 LTE specification. So 3GPP LTE CV2X is alternative solution to DCRC 822.11p or ITS G5. It is not compatible. Two cannot talk to each other. So industry is currently in this intensive debate over which standard we should use. 5GAA is engaged in discussion with regulatory agencies around the world, lobbying to allow CV2X in parallel with DCRC. 5GAA and 3GPP are on offensive, and they are gaining traction and support. Some automotive manufacturers are siding with 822.11p DCRC or ITS G5 in Europe. The others are siding with CV2X. So Ford openly decided to abandon the 822.11p DCRC version and go ahead with the CV2X. On the other side, and Audi in Europe. On the other side, Volkswagen in Europe is still preferring 822.11p DCRC version. So you can find these news if you are interested in searching around. This is a really hot topic and a lot of people writing about this. So certain countries made decision to go with CV2X. China made a hard decision. They are going CV2X. That's a huge market, huge number of vehicles, and they're going to use CV2X. In general, China prefer everything that is LTE related. But what is this really giving us? And myself being architect and especially involved lately with urban rail, LRT, I found very interesting doing analysis of this technology and finding applications for generally vehicle-to-everything technology in urban rail, LRT, and high-speed rail applications. So vehicle-to-everything is a comprehensive road safety and traffic solution. It includes a number of different types of the communications: vehicle-to-vehicle, vehicle-to-infrastructure, vehicle-to-pedestrians, and vehicle-to-network. So it's not just one. What does that give us? Well, it creates certain critical capabilities, which is non-line of sight sensing, conveying intent. Having this kind of the communication means vehicles can share intent or even sensor data. And we're creating, in the end, situational awareness on the road. 3GPP currently is using LTE release 14 version, and the chipsets exist on the market. It's a Qualcomm 9150. There are several manufacturers who are already making modules with this chipset to demonstrate capability of V2X communication using 3GPP LTE version. The new radio V2X is a part of release 16. Release 16 is truly 5G. So release 14 version is still 4G. Release 16 introducing additional improvements in performance of the CV2X. New radio V2X will complement and coexist with the existing release 14. So there will be back compatibility and interoperability between the two. And new radio V2X, 5G compliant, started in June of 2018, and it's planned to be finished in terms of the specification by the end of this year. Basic safety use cases in terms of the cellular V2X are identical to the DCRC. So both technologies are serving same, essentially, use cases. I'm not going to go in a lot of details, but emergency electronic brake lights, traffic turn collision risk warning, signal phase and timing, vulnerable road user protection, intersection collision warning, and slow vehicle warning and stationary vehicle warning. Those are the key applications that in release 14 CV2X is addressed, and pretty much the DCRC is doing the same. Jason touched upon this worldwide situation, which is very important to understand. As I already said, China sided with CV2X. That's it. End of the story. Europe, on the other side, it's technology neutral. But the statement about technology neutrality in Europe, it's a little bit strange. Well, you can use whatever as long as you coexist. Well, the point is that the 802.11p DCRC and the CV2X cannot coexist. And it's simple like that. So the situation is different depending on which parts of the world you're talking about. And one has to be very careful about it, especially if it's a multinational company who have customers around the world like we do. I'm not going to talk too much about the frequency ranges and these details. Christina mentioned too many numbers like that. But in general, we're talking in the range of 5,850 to 5,925, with some differences in few countries here and there. In Japan, they actually even have 700, 800 megahertz chunk of spectrum for the ITS applications. So who's better? What we should do? Well, one good thing, and I wanted to show you this, software is extremely important. Software is everything. The DCRC protocol stack and CV2X stack are actually very similar, and that's a good news. From the application point of development, regardless of which protocol stack or which radio communication you use, applications will stay relatively intact. Why? Because the lower layers of CV2X and the DCRC are differing, because physical layer, it's based on Wi-Fi in one case and based on LTE technology in the other. The MAC layer is also very different. But the above layers, the transport TCP/IP, support for IPv6, and support for wave messages, which are the critical to support basic safety message and some other messages for vehicle-to-everything applications, are identical. And the application layers who are sitting on top of it will not see the difference in that regard. So if you're writing a software who's using CV2X or DCRC radio, you won't see much difference as a software developer. That's a good news. I mentioned basic safety message. So if you look, this is the basic safety message, and that basic safety message is a part of the J1375 dictionary, and it doesn't matter which radio system you use, that basic safety message should have these TLVs, these values, these elements, and that's what needs to be transported over the air. And it's the same, regardless of CV2X or DCRC. Characteristics. So I put this table of major characteristics. Actually, this is still old. Yeah. So it's the same spectrum, same channelization. There is a difference in the certain capabilities because the LTE is using more advanced version of the physical layer that is more capable. And the MAC layer is very different between the two technology. But in the end, CV2X supports something that I think 822.11 DCRC realistically will have some issues in supporting. And that is, for example, vehicle to network, in which case the way how 3GPP positioning this approach is that the CV2X radio and can use two different modes of operation, so-called PC5, which is for direct communication, peer-to-peer, or it can even use the existing LTE infrastructure like any other LTE modem device and handset, in which case it uses so-called LTE U mode. So vehicle to network, realistically speaking, I think the CV2X approach or 3GPP approach has a bit of advantages. Another big advantage is the vehicle to pedestrian. It's more likely that we will see, especially let's say in the railway industry, workers on the road having a ruggedized LTE handsets that allow them voice, data, text communication, and then in addition to it, this radio that allows them to get warnings from the trains passing by or any other type of the vehicle. So this kind of the vehicle to pedestrian communication, I think that CV2X has advantage, which was mentioned by many others, not by me only, but theoretically, yes, one could design the tags that humans can wear based on 822.11p DCRC, but it's unlikely, in my opinion. Yeah. Yeah. So, yeah, not going too much into details of technology. If someone is interested, we can touch it. But this is very important thing to understand. This is a result of testing. The 5GAA performed a number of real-life tests on a different test tracks, comparing, and I looked these reports and reviewed these reports, and I have to accept these reports that they are done very professionally and fair, trying to do apple-to-apple comparison as much as it's possible. And in direct comparison of performance of 822.11p DCRC versus CV2X, CV2X outperforms 822.11p in the range every time. Whoever understands wireless communications will accept that because the 822.11p is based on OFDM version of the protocol and the file layer, which is 15 years old, while CV2X is using modern technology. And that gives the improvement in the range. Now, for us in railway industry, range is very important. Why? Because we probably, with the V2X type of the technology in the railway industry, have an opportunity to implement train-to-train type of the communications based on this technology. And train does not stop so easily. Braking distance for the train, it's hundreds of meters. It's not like a car. Longer we can communicate between the trains at longer distance, with technology choice is critical than to make, because this gives more safety. So, I mean.
And
maybe just to
Boyan,
show
we're going to ask you, Boyan, actually
Yeah,
to
sorry.
hold the final comments on
Yeah.
rail, just so that we give folks in the audience a chance to have some questions, because I'm sure they've got loads of questions lined up. So thank you so much, Boyan.
You see what happens when you give a couple connected vehicle guys a microphone?
Are these, is yours working? Oh, there we go. Okay, so I think I didn't need to explain any more about how quickly this can get very, very technical and how it's a tough mouthful to chew for sure, and you can get deep into it. And I know, boy, and you simplified your presentation in a lot of ways, but it can get a lot messier than that. So one thing I did want to talk about that our colleague from IBM, who unfortunately wasn't able to join us, we had a conversation about the ownership models for this infrastructure. So you have DSRC modules, obviously in the vehicle itself, that's the manufacturer, but the roadside unit and all the intersections, and then more so the 5G LTE towers that are being built out. What are the different ownership models for that? Who do you think is going to own it? Just to get your gears going, our colleague from IBM had mentioned there are some cities that are interested in owning those cell towers and then renting out use of them to private sector players as a new source of revenue for them. So in your experiences, what do you see as the ownership model for the infrastructure across the two different types of systems?
So I think when you're talking about DSRC, you're really building on a history of ITS deployments that's been 25 years in the making. And so a lot of cities and states own their own fiber networks, and so they make money from leasing access to that, and also the right-of-way and leasing access to equipment that's placed on the right-of-way. And the model that I think is probably the most prominent for RSUs is that the owner-operators of the roadways will be making those deployments, so they'll be making those procurement decisions. And then, of course, the OBUs are either aftermarket OBUs placed in the vehicles or integrated into a telematics control unit or somehow integrated into the
Maybe can I just clarify there? For those who don't know, RSU is roadside unit, OBU is onboard unit, is the physical module in the vehicle, and then the physical module on the intersection.
And we've also seen some agencies, I think Oakland County, Michigan, and a few others have some innovative procurements where they're looking at doing this on a connected vehicles as a service model. Where there is a minimum capital outlay from on behalf of the agency, and so that they're looking to have that service where they're not purchasing the RSUs, but they would have one large systems integrator come in there and replenish that, and so that also frees them from investment in one particular technology because really it's on the service providers to upgrade that. But as to the LTE side, I'll defer.
The ownership model, I think it will depend on the vertical. As I said, we in Thales have a very interesting view about V2X and application of that to railway industry. So if we're talking railway industry, I think our customers, our traditional customer, will be the owners of the roadside unit because eventually we will be designing and expanding our systems in the railway industry to allow train to object controller, what we call direct communication, which would be equivalent to the vehicle to roadside unit. We will do train to train, and in the end, this will be owned by our customers. If you're talking automotive, this question of ownership is the reason, in my opinion, why the CV2X, why we are even talking about it. Because CV2X introduces another set of the business models which were not being discussed previously. Business models where service providers can own some of that equipment. Business models where we see in Europe, certain automotive OEMs are even discussing to bring their own 5G infrastructure. So that is very interesting thing that's happening. So BMW, Mercedes, and Audi are discussing about potentially creating their own 5G infrastructure because they want to get some service model out of this whole thing. How exactly, it's yet to be seen.
I think that's one of the real questions, right, is how do you scale? Because the benefits are not truly there unless you have close to 100% adoption of all of the, at least newer vehicles that are on the roads, and you have full instrumentation of the highways. And so I think the model to date, which has been through a series of procurements by state departments of provincial transportation departments, owners, operators of the roadway, deploying that, and then OEMs the theory was that there would be a regulatory mandate, which would mean that everyone's under sort of equal costs. It doesn't appear that you have that regulatory mandate, so what other triggers are you going to have for mass adoption? And so in some ways, it's like ride sharing. So I was with a smart mobility startup 10 years ago, right? We're it was one of the loneliest places to be in Washington, was a ride share lobbyist 10 years ago. And the world's changed, and we were trying to use publicly funded projects to have adoption and to have heavy marketing for ride sharing and to have a critical mass of drivers. And along comes Uber and Lyft and says, well, we'll turn you into semi-legal taxi cab drivers and allow you to earn profits. And then they achieved what was effectively a critical mass of available rides, right? So I think that there's going to be a business model that we're not thinking of now that will lead to that adoption. And I think that some of the ones this gentleman has talked about are pretty interesting.
Excellent. Okay, I'm going to ask one more question just to be cognizant of time here. And if anyone from the audience has questions, please do come up to the microphones. But sort of as I suppose, a summative question here, if a city came up to you and asked you, should we start investing in DSRC or should we wait for 5G to be built out and CVTEX modules to be widely available, what would be your recommendation to a city?
Do you want to start?
Go ahead.
So I would say this. I would say start deploying now because from a sort of as he rightly pointed out, that the application layers and the network layers are very, very similar, right? So the underlying radio technology can be swapped out, and so I think the great thing about CVX is able to take advantage of a lot of the learnings and the standardization process, and indeed the certification process that we'll be offering that's already been developed for DSRC and some of the pains, and there have been pains. I'm sure that maybe possibly there have been some pains in bus electrification in the early days. But so you're able to take advantage of that learning. I would say start deploying now. Deploy with what you have, what's on the market, because right now you cannot deploy CV2X in the United States without an experimental license. The way that the rules are written in the FCC, the spectrum is allocated, it must be DSRC. So if you want to do anything, the only thing you can legally do is DSRC, with the exception of sort of a experimental deployment. So I would say do that now, and we're also starting to see from our vendors those that are developing dual chipset roadside units. So everyone's sort of hedging their bets. They're not quite sure where it's coming. And from our perspective, we're a certification body. We just want to make sure that the devices conform to industry standards, that they're interoperable, that they're secure, and irrespective of the underlying radio technology. And I think that I would caution this. I would caution that with DSRC, there is a longer history of kind of independent third-party validated testing, and that's coming for CV2X. I just don't know that that's there yet. That's one of the reasons why we're bringing a bunch of CV2X devices to our event in Spain here in a couple weeks.
Well, I think Jason pointed that several times already. The DCRC has that maturity level because it exists for so many years, and people know it. And because it is based on Wi-Fi, in the end, it has so much similarity to Wi-Fi. It's a modified version of the Wi-Fi. It's not Wi-Fi. But a lot of people understand it, and they feel familiar with it, and they understand how things works. With CV2X, not that many people are familiar, and there is a bit of a learning curve. And there is CV2X works, but there is still real-life usage and mileage that needs to be created with it. But all the testing that has been done point that it does work. To me, the question is the question of the regulatory. The regulatory agencies around the world have to make the firm decision what is going to happen. 5GAA going around and suggesting that they even split the frequency band, and they dedicate 2 channels for 802.11p DCRC and 2 channels of 10 megahertz for CV2X version. In my opinion, it's not such a bad idea. It will allow both technology to be deployed. On the other side, it bifurcates the market. And what do we really want from this thing? In my opinion, and this is a personal opinion, I like V2X technology because it improves safety. It saves lives. And if we want to save more lives, we should have one technology. But as usually, we get into these kind of the situations where people siding with one or the another one. In the railway industry, I say I prefer CV2X because it gives me extra range, and that is safety in a railway. In automotive, is it 600 meter or kilometer? I don't think it does make that much of a difference.
It's amazing the passion that goes into these debates. We have within our membership chipset providers, device manufacturers, automotive OEMs on different sides of the issue, and we try to play this sort of neutral role. But it's people are passionate, right? Because it is about saving lives, and there has been a substantial investment on both sides. I would say the one thing where both camps are coming together, at least in the States, is to protect the spectrum. The Cable and Television Industry Association is coming after the spectrum because they want to offer, more hockey games while you're walking down the street via Wi-Fi, and that sort of, there is that case for entertainment and having more unlicensed devices versus the real public purpose of the spectrum, which is saving lives. And so I think it's really been heartening to me to see both sides of that debate. Toyota on one side, Qualcomm on the other side, out there pushing to protect that spectrum. You saw a letter a couple of weeks ago from all 50 state DOTs and the District of Columbia leader and the one from Puerto Rico. It never happens, right? And they're all saying to the FCC, protect that spectrum. Don't let that be divided, because if that band is divided for non-transportation safety purposes, then that means you have to have a rechannelization, and then we have to figure out how does CV2X and DSRC live in a much smaller space, and that means a more limitation on deployment. So I think if there's anything that those stakeholders who are contemplating V2I capabilities or V2V capabilities in your buses, I know some companies like EasyMile are already doing that for their AV deployments. I think Beaumont, I read this morning about a pilot project moving to phase 3, putting the V2I there. So it becomes really important for the transit agency. So you have a stake in this fight. So if there's one message I would leave you with is be active, be vocal. If you want this safety technology out there, let your policymakers know how important it is.
Excellent, and I think that's the perfect note to end this session with. So can we please give Boyan and Jason a big round of applause for their input. Excellent, and are we changing schedule? Are we? Okay, yep. Okay, so then with that, we will head on to our lunch break. We're going to be having about a half hour where there's going to be a lunch buffet open, and then we have a series of 2 keynote speeches. So if you want to go out, grab your food, come back in, mingle for a bit, and then we'll have those keynote speeches while you can keep on eating. So thanks, everyone. Amazing. Thank you so much.
Well, welcome back, folks. I know that you've all grabbed your lunch, and don't worry, there's no need to rush. We fully expect you to keep eating while we get underway once more. We like to do working lunches, so here we are. I'm Jospa Beznic, as mentioned earlier, and you saw some of my colleagues here today. Christy Mlakar, you're going to meet a few more of them as we go through the rest of today and into tomorrow. And what we'd like to do now in terms of the lunch period, we've got a really special keynote speech coming up by Anne-Marie Carroll, the head of York Region Transit, which I'm super excited about. One of the most innovative transit systems in this country, in my view, and one of the most innovative leaders around transit in this country. And as a preface to Anne-Marie, we wanted to take folks through the Pan-Canadian Electric Bus project that we've been working on for the last several years that finally has launched in operation in Vancouver as of last week and was recently announced as fully funded in York Region Transit and York Region in the town of Newmarket, as well as Brampton Transit and the city of Brampton. We're really proud of this, not because of what Cutric's done, but because of what our transit agency partners have done in partnership with the manufacturers. This project literally has set a world standard, helped to set a world standard, and it is starting to be the motivational factor behind the publication of the J3105 standard that will allow for full interoperability of electric buses and chargers across Canada. So for those of you who aren't familiar with the Pan-Canadian Electric Bus demo and integration trial, we actually started it way back in 2016. It was the idea that we wanted to do something in Canada that wasn't being done elsewhere in the world. And what wasn't happening elsewhere in the world was standardization or interoperability. There were a lot of pilots. And at that time in Canada too, you probably remember, everybody was doing a little pilot here, a 6-week pilot there, a 6-month pilot here with one electric bus, one charging system, usually temporary, and almost none of it was leading to a system procurement. So that was a problem, and a lot of tax dollars were going into those pilots and not resulting in any kind of long-term electrification strategy. And the second problem is we kept hearing from people saying, well, you know, we piloted the bus, but we don't know which ones are going to work with the other ones and what charging system to go with, and nobody's telling us, nobody's giving us a Bible that we can read that tells us the pathway to salvation in electrification. That just didn't exist. And then there was one project that was happening in Canada that really set the standard for integration and systems thinking, and that was in STM as part of Cité Mobilité with Nova Bus, and that was the first overhead high-power charging system in downtown Montreal, a full systems effort where the engineers at STM did a fantastic job of getting these large pieces of equipment integrated into downtown Montreal. So we had that great project, but information about that project wasn't being disseminated across the country. So we had all of these problems together, combined with all of the issues that were raised earlier by the panelists about people thinking from a diesel perspective and that creating additional challenges to procurement. So we sat back and we said, okay, well, what can we do in this country nobody else has done? We have a small economy, small GDP, but we do have manufacturers and we do have some innovative transit agencies. And so we decided to see if Nova Bus and New Flyer and ABB and Siemens would agree to redesign their systems, both vehicle and charger, to be interoperable and fully standardized. And at that time, and still today, it's technically accurate to say there was no and still is no official standard for interoperability. J3105-1 and -2 are now being published, so that is changing as of this year. But at that time, there was nothing. There was only when we looked around the OpCharge protocol, which was an open source protocol in Europe that Volvo Group had published, and if I'm not mistaken, I believe with Siemens support, is the starting basis for an overhead charging system that people could align their systems with. So we latched onto that. Not all of OpCharge works in Canada, and there's some things in Canada that needed to be added to OpCharge, but we latched onto that, and thankfully New Flyer, Nova Bus, ABB, and Siemens said yes, that they would agree to go forward in about 3 years of what is probably and definitively the most difficult project I've ever been part of in my entire career. And if you had asked me what is the most challenging part about it, 4 years ago I would have said probably the engineering, because the systems integration and the bus platforms and the amount of work in the engineering. I think the engineering actually ended up being the easiest part, despite the last hurdles of actual civil deployment and operational deployment. The engineering is pretty much just the basic mechanical mathematics that comes and engineers make things happen. The hardest part was definitely the politics. Bar none, The politics were mostly the cause of any kind of headache that we did have came from a political section. And by politics, I don't just mean federal or provincial or municipal politics. Those existed, and those were challenges, and we had to convince a lot of councillors and a lot of politicians. And, you know, there's never underestimate the value of stoking egos. I think it's very, very important in trying to get these kinds of projects forward. But also the politics of just transit, the way that transit has historically worked, the way that procurement has historically worked. And so getting over those hurdles, we've now launched a project that is interoperable. It has 4 OEMs as partners, 3 transit agencies, 5 routes, 2 utilities. This is a little out of date. We have Newmarket, Tay Power Distribution, and BC Hydro as partners in the project. A total of 18 electric buses. The goal originally was 16. We got to 18, and 7 overhead chargers. So that means that in Vancouver, in Brampton, in York Region, there will be Nova buses and New Flyers on the same route, plugging and playing into ABB and Siemens en route chargers on the same route for full day operation. A true demonstration worldwide of interoperability, and there's no such project like this in the world. And so it just proves that we might be small as Canadians and a Canadian economy, or rather Canada might be small, but we're certainly mighty in our impact if we choose to use those fantastic institutions we have of education, social welfare, fantastic infrastructure. We can do things that absolutely lead the world, even though we only have 36 million so people in this country. And so here's just a little announcement from Brampton, and we're looking forward to that procurement now happening and the buses getting out on the road. This was our announcement recently in the summer at York Region in Newmarket, and most recently here was the announcement in Vancouver just last week. Doesn't come across in the photos totally clearly, but those buses do glow in the dark, so I still say they're the sexiest buses in the country. You need to get there, you need to get a photo on those buses. And that has led us to realize that we want to move forward even further. We started a little while ago trying to create a phase 2 project. The phase 2 project would definitely focus on J3105 and J1772 for in-depot compliance. I think the industry general view now is J3068 is no longer applicable in this context. So you'd have depot and en route standardization. We definitely realized already from our own modeling, using our Route I modeling tool, that demand charges are an issue. And in some of these jurisdictions, even when you optimize the use of that charging system, you may still need to have energy storage integration. And yet there is no standard for energy storage integration with high-powered charging systems or low power. And so we wanted to integrate the new standards that are emerging with the buses, with the chargers, with the energy storage, and of course, hype up the power to get it to 600 kilowatts. More power, fewer minutes of charging on the route, trying to get eventually one day to maybe 1 megawatt chargers so that the charging episode is down to 15 to 30 seconds rather than a few minutes. That's where we're going with it. Stay tuned for that. The big challenge coming up with this project is once you get to this size and scope, you're really hitting triggers in municipalities that focus on public tendering. And phase 1 was outside the public tender process. Phase 2 probably will be within the public tender process environment. And so we are launching an initiative around what we call the Innovation P3. There's no way to do this expensive, complicated stuff from within a transit agency on its own. And so an innovative P3 model that has the operations, the maintenance, the financing, and the capital assets is what we're now pursuing. And lastly, this project has led to our next big idea at Cutric. And this one I'm giddy over because the world needs it and nobody's doing it because it's hard to do. The private sector needs it, but the private sector can't do it because nobody will trust them to do it. And this is a big data trust for mobility-related innovation. And the sub-name that we use behind closed doors is the Electric Bus Big Data Trust. We may call it the ACES Big Data Trust, the Automated, Connected, Electric, and Shared Mobility Data Trust. But what this is in those 18 electric buses and 7 overhead chargers in phase 1, there are loggers on all of those systems. And so we learned from Winnipeg, we learned from Montreal, we learned from the systems that said to us, look, we didn't collect nearly enough data. And what we did collect, we didn't collect in a standardized form, or we didn't share it, we didn't analyze it, it wasn't real time, it wasn't cloud-based. And so a lot of opportunity in Canada has been lost through a lack of data collection. And so we got loggers on board all the buses and all the chargers that are going out the door as part of phase 1. All of those data will feed into a cloud in real time. Cutric is setting up this big data trust to be able to manage it in a cyber secure and legally sound way. And the idea is that every city in Canada that wants to eventually be able to log in or get into this consortium of big data can see in real time how Vancouver's electric buses are working and how Brampton's Siemens chargers are working or how York Region's ABB charger may be working in the future, rather than waiting for the once-a-year annual conference where we show up and we talk a little bit about how those performance measures are happening. And so the idea is create a data trust, flow all the data in, give cities and transit agencies free access, and if the private sector wants to access it because they can innovate all sorts of really great devices and tools and software controls for you, they need to pay their way in, and there's a certain amount of aggregation that occurs so they can't see the specific info about each individual unit or manufacturer. If we can create that, that will be the world's first public data trust for mobility. And frankly, I think it will just escalate Canada's position in the world around electrification. When we presented this idea to our colleagues at APTA, they were quite frank in saying that would be nearly impossible in the US to establish. At least right now, it would be very, very difficult to get cities from New York to LA to agree to feed into a common cloud data platform to share data of electric buses across the jurisdictions. And we can do it in Canada because, albeit as a constitutional monarchy, which I don't agree with, but the handy thing about being a constitutional monarchy is your provinces actually function pretty similarly to one another, and it is possible to engage in data sharing across this jurisdiction. So with that, stay tuned because we have a lot more coming up on that big data trust, and I hope that is just going to blow open the marketplace for those transit agencies struggling to go to electrification because they don't have enough data at their fingertips. And this would provide it instantaneously in a way that Canadians like to do, which is sharing as taxpayers and sharing experiences across communities. With that, I'm now love to introduce Anne-Marie Carroll to the stage. Anne-Marie Carroll is the General Manager of York Region Transit. She's been a huge champion of our project, working with us over several years and really advocating at the regional council level for electrification initiatives that go beyond just the town of Newmarket and into all of the other towns around where York Region Transit delivers services. Anne-Marie, as General Manager, and regional public operates the regional public transit provider of York Region Transit, as well as Bus Rapid Transit Way through the Viva line, as well as paratransit services. And she's actively contributed to the operational and technical advancement and the growth of public transit in York Region in various positions since 2002. So we've got a load of industry experience here. I would like to say that Anne-Marie has just been one of the leading lights, in my view, in the transit industry, because I don't think we've ever heard the word no come from Anne-Marie's team, and that means leadership comes from top. Doesn't mean they don't ask us questions, but they almost never say no to an idea. There's an openness there that is just a breath of fresh air. And so with that, I'd like to welcome Anne-Marie Carroll to the stage for a keynote address.
All right, well, I do say no now and again, so nobody get any ideas, because I do say no. Thank you for having me today. It's really exciting. Originally, Josipa asked me to join the conference as an attendee, but once I said yes, somehow I ended up here on stage. But it's a great opportunity for me to promote my transit agency and also talk about our journey in implementing electric bus technology. So York Region Transit, I'm just going to give you a little bit of background on who we are. So for those who don't know York Region, we're actually in the province of Ontario, and we're in the Greater Toronto and Hamilton area. And as you can see on this screen, we're the blue area where it says York Region Transit, and we're part of a regional transit structure, and underneath us at the regional level is 9 lower tier municipalities that we serve with our transit services. To the south of us is the Toronto Transit Commission, the City of Toronto. To the west is Brampton, Mississauga, and to the east is Durham. The benefits, listening to some of the discussions this morning about the TTC and how great their pilot is, I just want to say that we have a very good partnership with the TTC as well. And it helps that our borders are connected. But they've been very good at bringing us into their pilot project. So my staff on a regular basis are down in the City of Toronto, and we're certainly going to benefit from all of their experiences as well, which is great. York Region, we have approximately 1.2 million residents. We have a very large geographical area that we serve. It's about 1,800 square kilometers. And our council has mandated us to provide transit services from corner to corner of our region. And because we're so large, we have a combination of urban and rural areas. About 60% is urban, about 40% is rural. And York Region Transit is pretty young. We're only about 18 years old. Originally in York Region, transit agencies were operated by local transit systems, and in 2001 we amalgamated all those local into one regionalized system. So York Region Transit, again, we serve that large geographical area. So we have various types of conventional routes that we operate, and we also have our Viva bus rapid transit service. We also have our paratransit services, and this is probably for yet another session, but we have been looking at how do we deliver our paratransit services, but also deliver transit services to rural areas that are more cost effective than implementing with conventional services. So we've now integrated both our mobility services with an on-request service, so something like a regular on-demand, like an Uber or Lyft service, but we brought them now together because we see them both at the same model, and we're operating those two services together. We also contract the TTC to operate 5 services that run cross-boundary from Toronto into York, and that connects people in York Region down to the TT subway stations without having customers have to transfer at the border. We have a fairly large bus fleet, 668 vehicles. 544 are a combination of conventional and BRT vehicles. Most of them are 40 and 60-foot buses. And then we have a fleet of about 124 smaller vehicles. And those vehicles are primarily used for our community bus, our paratransit, and our on-request service. We are a little unique as well, is that we actually contract out all of our services to the private sector. We own all the infrastructure, we own all of our bus garages, and all the buses are owned by the region themselves, but we do contract out to private contractors under performance-based contracts. We have 4 bus garages situated very strategically across the region, most of the buses being in that Vaughan, Richmond Hill, and Markham area. That's the southern portion of York Region. We have an opportunity right now because we're actually either in the midst of expanding the capacity at some of our facilities, or we're about to expand on the rest of the facilities. And it's really an opportunity now with this electric bus pilot to really think about what infrastructure we need to build into those facilities, and we can do it now as part of that expansion of those facilities. So thinking green. When did we start thinking green? Well, I don't think we really were thinking green in the beginning. Originally, it was more of a cost-saving exercise. So about in 2014, we really wanted to take a look about how efficient our transit system was operating. So we did a very comprehensive review of all the services that we were providing. We looked at all the routes that we were operating on to see if there was an opportunity to run our system more efficiently. So that was about a 2-year program that we went through. We ended up removing about $8 million from our operating costs. We did reduce the number of buses that we needed in our system. And basically what that did is it allowed us to defer buying expansion buses over a couple of years. So there was a lot of benefits to us there. And really, it wasn't eliminating service, but it was more about making our schedules more efficient. And then we started to look at other areas. We started to look at what's the cost of running our infrastructure? How much energy were our facilities using? What was our cost of fuel? And are there other technologies out there that we could look at that would reduce that fuel cost or energy cost? So we hired a consultant to come in and what we were really trying to find out is what other systems were out there, what other fuel or propulsion systems could we go to that was cheaper than using the low sulfur diesel that we're using today. And it was really just an exercise in identifying what technologies were out there. We knew, of course, that there's the diesel, the hybrid electric, which the City of Toronto, or TTC, was operating for many, many years. And they brought forward to us the hydrogen fuel cell, and they brought forward electric bus as well. So phase one was really just to identify what technologies were out there. And I think it was about at that time that we recognized that if we were going to go through a transition, why would it just be about money? But here was an opportunity for us to move towards green technology. So we continued with the same consultant to do a phase two exercise, and they looked again at all those energy sources that we were looking at, and they did a full in-depth cost analysis and all the benefits of each and every one of those different types of energy. So once that consultant was done, we basically felt really confident that electric bus was really the way that we wanted to go. Originally, we were looking at CNG. We thought that was the way to go, but once we finished the analysis, we recognized that really the electric bus technology was the only way that we were going to go 100% green. The other part of our story is that York Region does have a greening strategy. So York Region adopted through council a greening strategy back in 2002. And the original version of the greening strategy really focused more on green infrastructure, so more around trees and revitalization of the regional forest network, creating accessible trails through the forest. And they were very successful in doing that. Just a picture on the right side, there is the Bill Fish Forest Stewardship Building. It's quite a mouthful. But that building is actually a living certified building. It's a LEED Platinum building. And what that particularly means is that it actually generates more energy than it uses. And it does many other things, and it also serves as a learning center for people of all ages. In 2012, though, the updated version of the strategy turned its view towards greenhouse gas emissions. And of course, once you start to look internally and you look to see, well, where is this organization creating the most GHG, of course, they focused right in on transit. So these are diagrams that are right out of that document. And like I said, once you start looking internally, although we know transit removes a lot of cars from the road, we also know that as a whole, internally to the region, we are the biggest contributors to GHG emissions. So now the focus was on transit to do something. We had already done our analysis, so we felt pretty confident about moving forward. And what we really needed now is some partners. Because we knew what we wanted to do, but we didn't know how we were going to do it. And frankly, we just sat in a room and kind of stare at each other and say, okay, well, now that we made a decision, what do we do next? So lo and behold, here comes Josipa, and Cutric was formed. So we were one of the first organizations to join Cutric, and also one of the first to put our hands up to be part of the Pan-Canadian demonstration as well. And it has been a great partnership. There's certain aspects of delivering this new technology that we really didn't have a clue about. And we also brought on our Newmarket Tay Hydro. So Newmarket Tay Hydro is a local hydro authority that's situated in one of the municipalities in York Region, happens to be the town of Newmarket. And they were really good too at putting their hand up and saying, well, this looks like a really good opportunity for us, and we want to be part of this demonstration. And the gentleman that they assigned to the project, just by coincidence, happened to be someone that I worked at the same organization about 18 years earlier. So to me, that was really a definite sign that this was the right thing to do. Was it a coincidence? I think not. I think things happen the way that they should. The other thing that really got me excited is I was at a APTA conference down in Miami, and they had a speaker who was talking about the disruption of clean energy. And it was a very long and compelling, but a very compelling presentation. But he really posed a lot of things to think about, to ponder. And he had a lot of illustrations as part of his presentation. And these two really, really got me excited and really started getting me to think about how quickly we should move forward. So this is New York City, the day of the Easter parade in the 1900s. And as you can see here, streets full of horse and buggies. And that red circle in that diagram is the one and only automobile on the street. A mere 13 years later, same street, same day, and all of a sudden we have a street full of automobiles, and that red circle now is the horse and buggy. And the horse and buggy was probably there as, something to remember the good old days by. That's probably why it was there. So it really started to make me think that although electric bus technology was new to our thinking, that it was going to come fast, and we had to start getting ready for it. So we're on our way. As Joe Sipa had mentioned, we have purchased now 6 electric buses, 3 new Flyer and 2 Nova buses. We have our partner, Newmarket Hydro, who has purchased the overhead charging units, and we're working with them to install that unit as we speak. The buses will be delivered by the end of this year. We're going to commission early next year, and then we'll be off on our pilot. So what do we think some of our challenges are going to be? So first and foremost, we've never done this before. So we don't know what we don't know. So we are in the midst of doing a fairly comprehensive assessment of what we need to do to prepare for the electric bus. We need to look at our current state. We need to understand what infrastructure changes we have to make. And like I mentioned earlier, it's a good time for us to do that because we are expanding on all of our facilities. We need to look at those infrastructure gaps. Operationally, what do we need to do? What do we need to do as far as training? We're dealing with the private sector as well, so they need to be our partners in delivering this new technology. So that's important, and they're all on board, and they're all as excited as we are. And we need to set some timelines and some cost estimates. We need to know how much this is going to cost us. So we are now preparing a 10, a 20, and a 30-year budget for our council. So once we finish this assessment, we will go back to look for the appropriate approvals from council. And we do have a very supportive council. We can't do this fast enough for them, but when we put a bunch of numbers in front of them, they might change their mind. But we're going to do a 10, a 20, and a 30-year estimate, and we're going to see what kind of approvals we're going to get. At the municipal level, it's unlikely that they're going to allow us to continue to pull money from reserves, so we're going to have to find other ways to fund it. This is another problem. This is our transit system network. Very comprehensive. A lot of it is legacy routes. Like I had mentioned, local transit systems had operated these services previously, so a lot of these routes are very focused on community. And the difficult part is they have really good ridership, so it's hard to pull back on some of those routes, and politically it's probably not very good. And having a regional municipal structure, regionally we look after all the region roads, which is really what forms the grid network. The municipalities look after all the other, like the mid-cross blocks and all the internal road network. So they have not been great in planning that road network. It's not really conducive to transit. It's great to slowing cars down through neighborhoods and great for kids playing on the streets and all those things, but it's not very conducive to transit. So part of the assessment that we're doing right now, we'll do a full review of each of the routes to see which ones we could actually operate using electric bus technology. And what we know as of today, we figured we can probably operate about 80% of those routes with the technology as it is today. But we have very long routes, like I mentioned, 1,800 square kilometers. Some of our routes are really long as well. So we have to figure all that out. And the big F word, funding. We know through the phase one, we had a lot of challenges with funding. Thanks to JOSEPA and others, we did get some funding from the Canadian government, and that funding went to the overhead charging units. We did get approval for funding from the Ontario government as well, but that was on again, off again funding. We got the funding originally through one government, and then a new government came in, and they decided they weren't going to fund it anymore. So we were on again, off again. I thought I was going to have a stroke. It was just constant for about a year. It was on again, off again. But I went back to our council. We explained what was going on, and because they're so supportive of this project, they agreed that we were able to take the money from reserves, plus we had to tweak our existing capital budget as well, but we now have the money for the 6 buses to go ahead with the trial. But going forward, we really have to figure out where that money is going to come from. We do need a sustainable source of funding, and if it's not from the Canadian or the provincial government, we may have to look to the private sector as well, do something a little bit more creative. So last slide, just timelines. We've been doing this for a really long time. I know I have 2016 up here because I couldn't fit the rest in, but we've been looking at this since 2013 or 14. We've been working on this for a very long time, and we do have a long way to go. We're really excited about doing the overall assessment to figure out what we have to do. In the next 6 or 8 months, we'll have that document done, and we'll be ready to present to council what we think it's going to cost and how we're going to roll it out into our system. The greening strategy says we'll be completely GHG free by 2051. After I was at that presentation, I started texting my staff and I said, the heck with 2051, we're going to do it by 2031. So they weren't very happy with me when I text them that, and they're probably not very happy that I'm here today because they'll think I'd come up with something new. But we're going to do our assessment. We're going to get the buses in. We're going to spend the next 2 years analyzing those buses. We're going to work with other agencies like Brampton Transit and our partners down at TTC as well to collect data so we know what we're doing going ahead. And, we're just going to work towards becoming 100% greenhouse gas emission free. So thank you for allowing me to speak to you this afternoon.
So we're going to move to a bit of a fireside chat, but we're missing our microphones up here, so I'm going to give you the eye over there if we can grab a couple microphones, and we will have potentially time for a couple quick questions with Anne-Marie, and I've got a couple lined up for you. Just while we're waiting for our speaking devices, the funding issue that Anne-Marie referred to, in fact, thanks so much, actually. I'll come on over and we'll have a cozy over here. All right, let's see if this works. Okay, so the funding issue that Anne-Marie referred to is actually, I think, quite indicative of a lot of the issues transit agencies are facing. We did lobby for a couple years. We did get about $13 million, and that was for Brampton and York Region for this project. And everything was ready to go, but even to get that $13 million from the province of Ontario in a jurisdiction under a government that was climate action oriented, it took us over 18 months from a Ministry of Transportation to explain the business case. And in the end, the only reason we ended up getting the money was because literally we had to hunt down the minister at his favorite Starbucks and then his favorite dinner place to get him to listen to what we were doing, and then he turned around and approved the funding. And unfortunately, by that point, the election was called, we had a new premier, and the money was canceled. And so I think that period that you said, that whole year of here we go again, just proves how hard it is to actually do electrification in this country. Those are not sustainable funding models. And so the first question to you, Anne-Marie, and you alluded to it here, hunting down ministers at their favorite Starbucks to convince them, under a government that believed in climate action, about funding these kinds of innovative projects, not sustainable. It's almost never going to be the case that the feds, the provinces, and the cities align in funding. So how, from a financial standpoint, do you think York Region is actually going to get to full electrification, given that the numbers are high and they're difficult, and the regional council probably hasn't seen all those numbers just yet?
So that is a difficult question to answer. But I think part of the problem with the provincial government is I don't think they understand electric bus technology in the transit industry. When we met with ministers, and I think it's ongoing, constant communication. When we met with one of the Minister of Environment, he was really focused on the automotive sector. And that seems to be where their head is at. So they don't really understand the differences between the automotive sector and the transit sector. So I think we have to continue to constantly educate the politicians. And hopefully there's good timing involved, and we do it years before an election occurs, or we might end up in the same circumstance again. We're going to have to look at our capital budgets. I mean, we're going to have to really dig deep to see if there is opportunity within our existing capital budgets to endure the difference in cost. We're hoping that as electric bus technology becomes more popular across all the transit agencies, that the cost will come down. And we saw that presentation this morning where we do see some of the costs coming down. So I think it's going to be a combination of many things. I think we need our politicians to commit to maybe spending a little bit more money to buy electric bus technology and the benefits around it, because there is the capital component, which is a higher cost, but through our analysis, we are showing that overall, on the operating side, which really comes from the tax base, there is a savings over the life cycle of the bus as well. So I think we can be creative in implementing our budgets the way we need to implement them, but we are certainly going to have to continue to go after the province and the Canadian government to support us.
Yeah, so maybe the innovation comes in recognizing the operational savings need to factor in the capital procurement, and that alone seems to be a challenge in a lot of our cities. But back to your point, Anne Marie, I think you made a really good point that in a lot of ministries and a lot of government, municipal, federal, and provincial, if you do the rounds, and it's not that hard to do the rounds in this country, there aren't that many governments, almost every Ministry of Environment and Ministry of Transportation, up until very recently, thought about electrification almost exclusively from the car perspective. And it took us about 2 years to get colleagues at the Ministry of Transportation and Ministry of Environment to understand that electric buses are not dormant for 95% of the time, which is the common argument for electric cars. They're dormant, they're not moving 95% of the time, they're just stationary energy storage, and buses are not like that. Totally different system play. Fast forward to where we are now, this is the first time in Canadian history that Natural Resources Canada, as a federal ministry typically allied to natural resources, has actually had programming for innovation for transit, because it's usually been shunted to infrastructure. And Industry Canada, which is Innovation, Science, and Economic Development, has only just now in the last 12 months admitted that they will have a transit innovation team. So this is 2019 in Canada under government that is climate action oriented, and that's how hard it's been to get the kind of thought process that you need. So the question to you now then, I suppose, is in reflecting upon all of this, there's a federal level, there's a provincial level. The provincial level is a different kind of context from what we operated in when this project started, and then you've got your regional council. And depending on the federal election, at least the province and the region are not necessarily on the same page around environment, let alone transit electrification or transit and transit mobility. How is York Region going to overcome the lobbying effort and working with the province in a context where it may be the case that transit is not just a second thought, but a non-thought?
So I don't think York Region can do it alone. I think it goes back to we need to do it as an industry. And like I said, we have met with a number of ministers, but a lot of it's either been done through you, Josipa, or even with Karen Cameron at the Ontario Public Transit Association. And I think we need to do it collectively as a group, because I don't think York Region can do it. Yes, I can get our chairman to write as many letters as he can possibly write, looking for funding. but I don't think it's just York Region. The other piece, going back years ago, the federal government did at one time subsidize the purchase of expansion buses or new technology buses. And I think that's something I'd like to see again. I want to see if there's an opportunity to do that. I feel like we're going to have better luck at the federal level as opposed to the provincial level.
So, and I will find out where Doug Ford likes to eat dinner and where his favorite Starbucks is. No worries, I'm on it. So we'll be back here next year seeing how that pans out. But in the meantime, one thing that many folks may not realize is this Pan-Canadian Electric Bus Project is innovative for a lot of reasons. But in York Region in particular, Anne-Marie did mention the fact that Newmarket Tay Power Distribution is owning and operating a $1 million overhead charging system on behalf of the transit agency. That is fundamentally innovative in the electricity market. Loads of utilities are looking at York Region and Newmarket Tay Power Distribution saying, how did this little local distribution company decide to own and operate a high-powered charging system on behalf of a transit agency? There's all of this innovativeness happening there on the business side. And of course, they're going to try and figure out if it's distribution equipment and if they can get it regulated. But on the flip side, for York Region Transit, there's risk because you've now handed off your fueling system, fundamental to the operation of that electric bus, to a local utility. And so there's risk as well as benefit of having the local utility maintain and operate something that they clearly know how to manage. From your perspective, as you're scaling up and York Region is thinking about scaling up, you've got a number of utilities in your backyard, not just one. Is the plan to continue to try to develop a utility-owned and led charging system strategy, or is the plan ahead for York Region to possibly start in-housing that and deploying an entire system?
So I think it goes to a conversation that was had this morning, is I don't think York Region has the expertise in-house in order to do that. So I think, we need to do what we're pretty good at. We need to go out and we have to start developing those partnerships with the hydroelectric companies. And I think we can use our partner from Newmarket Tay Hydro to help us with that. They have a lot of good insight on what's going on in the industry. And I think there's a lot more thinking about this in the industry that we know with other hydroelectric companies as well. But I think it's really about building those partnerships and really figuring out how to move forward with them, maybe not even owning, but at least operating and helping us maintain those systems.
And I think that jives with our experience as well. I think it's fair to say, and correct me if I'm wrong from folks in the audience, but in Canada, we've only got Toronto, Montreal, and Vancouver that have subways, pretty much. And then we've got Calgary, Edmonton, Waterloo, and Ottawa that have LRTs, right? Like maybe I missed one or two there, but that's pretty much it. Like there's not a lot of high-powered electrical engineering capacity in our transit systems in the country. And so while those bigger systems are probably going to in-house their charging system operation, most systems are in York Region's camp where they're hoping to outsource or find a deliverer of that mechanism. And what you're saying is it could be the utility. Could it be other players as well that you guys are thinking about?
I don't think we've thought that far ahead at this point. I think in our minds it would be the hydroelectric companies that would manage those systems. But it's not to say that as we go through this process and learn more, that we might change our mind. I'm always open to changing. I'm a woman. I have the prerogative to change my mind at any time. So, if something better comes along or something that we think works, then maybe we'll do that. I just wanted to add too, one of the points I wanted to make as well is we have an electric bus pilot. Brampton has one, City of Toronto as well. And one of the things that sort of came to light recently is we really need to think about how do we integrate those systems together. Because TTC operates in our jurisdiction, Brampton operates in our jurisdiction as well. We have cross-boundary agreements with those agencies. And it's something that we're really not thinking about as part of these pilots, is how do we integrate those services together. We're working on with TTC with an expansion of a second subway into York Region. And one of the comments we made about the terminals that we're going to build is what technology are we going to build into those to allow for electric buses. And nobody on that entire subway team had even thought about that. So that's a bit of a concern, and it's something that seems to be missed, but I think we've caught it now. But we have to figure out how that works.
Yeah, and you have a lot of terminals that are shared also with Go Transit, and we've heard this crop up as well. What's the plan at Go? Who's steering this ship? Because if you want all of those Go stations across the backbone of the GTHA to be electrified, needs to work with York Region Transit, all of those transit agencies, and it means that you and TTC would need to have interoperability on your charging strategy. So the next big great thing, but it could be posed as a great challenge, and that leads me to one of our penultimate questions, which is, what's the biggest fear you have going forward? So you've got this great visionary plan, great action ahead, a great team, great project, all of that, but what keeps you up at night in terms of, is it going to work out?
So whether it's going to work out or not really doesn't keep me up at night. I think the trial, I think we picked the right technology because we did look at everything, and we looked at, do we look at a transitional technology, hybrids or hydrogen cell? But we keep coming back to no, we're going to go full electric bus. I think we're really comfortable in what we're doing. Really, the only thing that's going to get in our way is funding, and so that's sort of number one for me, is to figure out the funding component.
That's great. So we're going to crack that nut. And I did tell Anne-Marie we're going to shift gears as we conclude and segue into our next section. We believe in innovation at all levels, obviously technological innovation, financial innovation, and social innovation. And here we have one of very few female leaders in the transit industry. And if you've heard me wax not so poetically about this issue, it's a huge problem. We've got, 6 women heading transit agencies in this country, and there's, 200 transit agencies in Canada. It's male, pale, and stale, and that is not reflective of the clientele. Right? And lots of you are my friends. It's fine. We can say it. The clientele is female-dominated. Females ride transit more than men do. In large cities, visible minorities ride transit more than white people do. So what other company or industry do you know where the CEOs and the directors do not use their product as their clients do and do not reflect their clients in almost any case? It's catastrophically bad for mobility in this country. And so I asked Anne-Marie, given her insights, given her experience, how do we socially innovate as well? Because look, 2 of the 3 transit systems, Brampton, at the time that we started this e-bus project, was led by Sue Connor, yourself. We now have Erin Pinkerton at BC Transit turning that ship around electrification. I think women are systems thinkers. We're raised and sociologically trained to be systems thinkers. So when we're at the helm, we get these projects through the door. So I want to know, Anne-Marie, how do we get more of us at the top of decision making? What's the problem in this country with women not being in control of the transit systems that they ride and the product they use?
So I have 2 minutes, so I'm just going to tell a quick little story. So when I started in the transit industry in 2002, so I've generally worked through male-predominant industries all my life, whether it's in construction or solid waste management or some of the other industries that I've been in. When I came in 2002 to transit, I think it was the 2nd or 3rd year that I was in transit, I went to the Opta conference in Mississauga, and I walked in that door, and literally, there were about 100 or so men in the room. They all stopped and turned and looked at me, and they didn't know what to say. Am I in the wrong place? Was I the entertainment? I don't know. But, back then, I was the only woman in that room. So fast forward to today, we can see, although not all leaders at the top, the industry is starting to change, and there's a lot more women coming into our industry. And at York Region, about 3/4 of my management team are women. We have a lot of women in our operating side, all the on-street sector as well, in our paratransit side. So it is changing. We did a women's symposium for our enforcement group last year because it's an area where we have difficulty getting women into, but we've changed it now, so it's a symposium for women in the transit sector. And I think a lot of it is women don't know where to start because they really don't look at buses as being something that they're interested in, or that they, I don't know anything about buses, how can I be in that industry? Well, I didn't know anything about buses originally either. But over time, we're smart, we can figure it out over time. But it's really getting out and educating people. So we need to get into the high schools. We need to actually, the high school before they get to college. We need to get them interested in our industry, and we need to mentor them once they come into our industry. And we have a program in place, a mentorship program now, where we are developing young women in the transit sector at York Region. But I think that's really what it comes down. I think women just don't know, and they're maybe a little bit afraid of getting into this industry because they just think it is something that males do in general. So we have to change the mindset.
And frankly, if you're a woman out there and you think you don't know, trust me, the men don't know either. So you just go take that power. The reality is that we got to create these pathways, and women do need to start taking the directorship and the power to make the decisions to change the mobility system for Canadians. And I really appreciate everything that you've gone through, Anne-Marie, everything that you've helped create, and it is changing the landscape of Canadian mobility as we know it. So thank you very much to Anne-Marie Carroll, and a round of applause for our keynote. Got a little gift to say thank you to so much. There you go. Yeah, thank you so much, Anne-Marie. We really appreciate that. And with that, just before we turn to our midterm health break, I'm going to turn to my colleague Adriana Shuyin, who is our Membership Success Officer, and she's going to take you through a bit of a whirlwind tour in a few minutes, some of the ecosystem that we build up, because we've been talking a lot about transit mobility, transit applications, but actually Cutric's job is not transit. That's not actually our job, even though it's in our name. We don't do transit policy. We don't advocate for transit in general. That's not what we do. What we do is actually technology innovation projects that create jobs in Canada. And so our job is to create an ecosystem in low-carbon smart mobility. And Adriana is going to take you through some of the outcomes of the last 3 years of that effort before leading into a presentation by one of the projects that is currently being funded by our funding pool. Adriana.
Hi, everyone. My name is Adriana Shuyin, and I am the Membership Success Officer and Contracts Administrator with Cutric. And so one of my, I do another role, which is assisting in the ongoing projects that Cutric has co-funded through our research and development program. There we go. So some of you may know that Cutric has developed this research and development program from 2016 to 2019. And one of the key objectives of this program was to support industry-led collaborative research that builds the opportunity for the training and the job creation from our academics. And so part of our program was we developed a 2+2 model. So what that indicates is that we have at least 2 industry members and 2 academic members partnering together to create a research project. And another objective here is to support our vision as making Canada a global leader in low carbon smart mobility. So you may be wondering what types of projects that we have co-funded, and our projects all fall under our 4 pillars of innovation, but before we get there, we have funded about 10 projects that are reviewer approved. The total amount the value of these projects are $38 million. And of that $38 million, Cutric has contributed $5.5 million. So all these projects fall under our 4 pillars of innovation, the first one being low and zero emission propulsion technologies with charging system integration. Our second one is smart vehicle and smart infrastructure, and our third one is big data with regards to advanced mobility and mobility as a service applications, and our last one is cybersecurity. But as you can see to my left, most of these projects fall under these 3 pillars of innovation. And just to give you a little bit of a taste of what types of projects we have co-funded, we have a few examples from each of our pillars shown on this screen. So our first one here is the automated and connected electric vehicle integration, which is our optimization analysis and techno-economic predictive analysis project. So this project was motivated by our members, which allowed us to develop a tool now called our Route I tool. And in this project in particular, it was to assess the feasibility of operating and deploying autonomous, low-speed, connected, electrified shuttles in different jurisdictions. So with this tool, Cutric has now been able to model out routes for many different jurisdictions, transit agencies, and cities across Canada. For example, Edmonton, Toronto, Vancouver, and Brampton Transit, etc. Next one is the development of low-cost, high-performing, and durable PEM fuel cells. So this project was led by Ballard, University of Waterloo, Star Power On Systems, as well as Western University. And this project was looking at proton exchange membrane fuel cell technologies for transit applications. And our last project here under the third pillar is our social somatic analysis of social media interactions to assess customer satisfaction in transit agencies. Their titles are almost as long as our project titles. And this project was developed by Calgary Transit, SP North America, University of Toronto, York University, and the University of Calgary. And here they're looking at collecting or integrating the social media posts from the public directed towards Calgary Transit and essentially amalgamating that data into a cloud, doing the data analysis to optimize and help Calgary Transit optimize their operations in real time using AI. So as you can see here, Cutric is really proud to have worked with all these innovative companies as part of our project partners, some directly related to the project and some invested stakeholders. And here we have 81 of our industry partners who are involved in our projects. And we also have our academic partners who are doing amazing research with our industry partners as well. So as Membership Success Officer, I'm really proud to stand here today to describe some of the projects for you that we have co-funded as one of our values that we have to our members. And one of the great things that we have here is that we've created this ecosystem to help launch these types of projects in Canada to create, to make Canada the global leader in these types of technologies. And so with that, I'd like to introduce our next speaker. He's part of a very innovative company that is looking at reducing greenhouse gas emissions in transportation. And they are also creating jobs within low carbon smart mobility as a project partner from our R&D program. And they're also a gracious sponsor of our conference today. And so please welcome to the stage R.K. Hong from MicroGreen Solar.
Yep. Is that the slides on? Okay, so go to next one, please. Yeah. So MicroGreen is a very small company, and we see ourselves as the expert in the solar plus storage system. And we focus on one thing, that is we combine the value of solar plus storage. And what we do best is to get a maximum value from the solar plus storage into several applications. In here, we define the value as the reduction of GHG emission and the saving of the operation and maintenance costs. Next. Now, we thank Cutric for giving us the opportunity to bring this solar plus storage into the public transport. In fact, we had previously deploy such system in the vehicle application, that is in a recreational vehicle. But in this application, we are actually increasing the power and also the energy level to a level that can resolve the anti-idling in the public transport. So what we do is we deploy the solar panels on rooftop of the vehicle in the energy storage battery system inside the vehicle. So we collect the solar power installed into the lithium battery, and we use the energy to power the auxiliary loads in a vehicle, such as the lighting appliances and potentially HVAC. What we do not do is we do not touch the drivetrain of the vehicle. So the motivation here is to use the clean energy in circumstances where such auxiliary loads would otherwise have to be powered by idling the engine. The end result is we eliminate the GHG emission from idling vehicle, and we save the fuel cost. Okay, next one, please. Oh, before we go to next, anyway, okay, that's fine. Yeah, so because the amount of solar energy we can harvest is quite small, so one of the challenges we are facing is how do we maximize the reduction in the GHG emission given the amount of the very small amount of the solar energy. And because of that, one of the systems we implement in the whole solution is to create the energy management system which maximizes the energy flow from the power source to the load. Okay, next one. So here I explain a little bit the industry problem that we are tackling. So the efficiency of the engine is extremely low compared in the idling compared to that for the highway driving. In fact, we are talking about 6% versus 40%. Now, in addition to emitting the GHG emission, actually idling causes very severe damages way out to the engine, and that wastes a lot of the fuel. Now, transport account for 34% of the GHG emission in the Greater Toronto Hamilton area, where that level globally is only 14%. So in this study, in this project, we are working with University of Toronto, University of Waterloo, and Centennial. So because we have the academic collaboration, so we have gone through very elaborate modeling study on the emission from transit buses. And we took the weather condition in New York and that in Toronto. So our result demonstrates that a 20 kilowatt hour energy system would result in a fuel saving of over $5,000 per year, and that would reduce the GHG emission by 4.7 tons per year. If we are able to increase the energy capacity to 60 kilowatt hour, we will then deliver a fuel saving of $13,000 in a year and reduce the GHG emission by 11 tons per year. Now, in all of the solution that MicroGreen has developed in general, not just in this particular case, we always take the rule of thumb that the financial payback for the customer would have to be under 5 years. So in this particular case, we are able to meet a target. And given that the lifetime of the lithium battery is at least 10 years, so it should be a very good investment for the transit agencies. Next, please. Oh, okay, so in this busy slide, I just basically want to draw you to 2 points. First point is that in our investigation, we found that the energy density, the energy capacity we can put into any transit vehicle will be at least 2 to 4 times better than the lead-acid battery that is currently being used in the transit agencies. Second point I'd like to draw your attention is that in our system configuration, we also incorporate option of actually charging the battery by the alternator in the vehicle. So when a vehicle is on the road and the battery runs out in the middle of the road, in that case, we will trigger the alternator to charge the vehicle so the system will be available all the time. Next, please. So we really like the T in the I in the Cutric. So we try to push the innovation in the solar plus storage to different areas of application, as I have alluded earlier. One particular application we would like to tackle, which is more related to this audience, is that we would like to work on the integration of solar plus storage in 2 applications. First application of the 2 is that we like to combine that with the EV charging, and the benefit is to reduce the demand of the charging stations on the grid. So in this application, we are moving up actually energy capacity from a few tens of kilowatt hour to even half megawatt hour or even greater. Next, please. Next application we are tackling is actually to bring the same system, that is solar plus storage, into the power supply for the 5G network. Now, in the 5G network, the Lambo base stations are at least 10 times more than that in the 4G scenario. That is because the transmission distance is much shorter, and because the radio base stations will be transmitting far more data that consumes a lot of power. So this solution would reduce the amount of cost that telephone companies would have to spend on powering the base station. And of course, it will reduce the reduction of GHG. Next, please. So we are a small company. We do not manufacture batteries. So the dominant supply of the lithium battery we are using for the various applications is a China manufacturer called CATL. It's a top global player in the industry of lithium battery. Next. Now, in addition to the innovation of the technology, we also would like to extend the innovation into the business model. And our innovation is to cross into the lease model or the build, operate, transfer model to allow the transit agencies or other customers to be able to launch the electric application without the huge upfront cost. Now, the difference between the two is that in the lease model, it's a very simple, clean cut for the customer. In the other model, it involves the transfer of the ownership to the customer at one point. Okay. Next. So we can see that the solar plus storage is actually becoming a very, very current topic. Next. So I then summarize my presentation. We again thank Cutric for funding the project, which allow us to take the solar plus storage into large-scale vehicles like transit vehicles. And we innovate in three aspects. That is, we find the best way to find a reduction of GHG emission. We innovate because we use the lightweight, compact, high-energy density solution, which are essential for the mobility application. Thank you. I think I'm over the limit by 1 hour, by 1 minute. Yeah. Okay.
Thank you so much, RK. We know that a lot of our TRs are interested in anti-solar technology, so thank you very much for your presentation. So before we go on to a break, we wanted to thank our sponsors. So we wanted to thank New Flyer, Siemens, ABB. We wanted to thank City of Winnipeg, MicroGreen Solar Corporation, MCI, Proterra, Transdev, Uber, Winnipeg Airports Authority, and Via On Demand Transit. All right, thank you very much, and we'll be back in about 15 minutes.
Folks, oh, I think the microphone's off, so that way we'll just let people know. Oh, I'm gonna check. So everybody, there is just a refresh on coffee at the back and some refreshments. So if you do need your refreshments, they've just been lined up at the back. Thanks. I hope you've had a chance to get your coffee and your refreshments. We're going to get started with the next panel in just a moment. No? Mm-hmm. Very good. You guys want to take a seat right away? Sure. I was going to call you out, but go ahead. Yeah. Take control. Do it. No, it's no problem. Yeah. So we're going to get started on our next panel, which is also turning back to the electrification of transit. And panel 3 is focused here on transit strategies for full fleet electrification. We called it the good, the bad, and the lessons learned. And since we've heard in-depth, we're going to invite Anne-Marie. Come on up. Oh, yeah, come on up, Anne-Marie. They just took control and sat themselves, so this is all very good. We're chipping along here. On this panel, what our intention was to make sure that folks got a chance to hear from the belly of the hyena, from the core of the transit agency. And a lot of times, if you go around to these conferences, as we do in North America and Europe, you'll see that there's a lot of manufacturers, a lot of integrators, but not always a lot of transit agencies in the audience or on the panel. And everybody wants to know 3-4 years into electrification, what are the experiences of transit? What are the good experiences, the bad, and the lessons learned? And to the extent that there is data to share already, we're quite keen to see some of those data. And some of our folks here on the panel have excellent insights to share with you. I think you're going to find this extremely enlightening. And so just to recap what we said this morning, 5 years ago, we were still trying to convince people. Now where we are in terms of transit agencies represented here across from west to east, from TransLink in British Columbia out to Toronto and surrounding communities, what we've got here are leadership-run and oriented transit agencies that are now trying to iron out the wrinkles and get to full fleet procurement. So an exciting time ahead. With that, I'll introduce from my left to right our speakers today. Our first speaker is Mike McCass, Senior Manager of Vehicle Engineering at Toronto Transit Commission, and definitely on the front lines of the electrification strategy and the procurement that we've heard about so much today. Scott Gilner, who's Senior Advisor of Transit Policy at Brampton Transit, who has loads of experience and has lived through everything that Anne-Marie Carroll referred to earlier in terms of Brampton Transit being one of the first transit agencies to propose standardization of electrification and being part of our Pan-Canadian Electric Bus Project. We've got Don Repta from TransLink as Senior Sustainability Advisor, and Don and I had the chance just last week to sit on a panel together laughing about the good old days, not really, sort of sharing war stories. And so Don's got a lot of good experience to share with you from TransLink now that the buses have launched. And of course, Anne-Marie Carroll joins us again from York Region Transit to share additional insights into YRT's deployment for electrification. So I'd like to welcome this panel and the insights that you're about to share with us. With that, I'll turn first to Mike McCass from Toronto Transit Commission. It's just the big green button there. Yeah.
Hello, everyone. I just want to thank Cutric for inviting the TTC to this event. I'm very happy to be here. I apologize if some of you have already seen this presentation. There's some slight changes. I think we'll have some more exciting information at the next panel where we'll actually share some data. But this presentation is really meant to guide you through how we got where we are today and where we're going next. And so just before I get into the presentation, I think TTC in the past has been criticized for being very conservative when it comes to adopting new technology, and I think part of that isn't accurate. We were one of the first adopters of hybrid buses in the early 2000s. We lived through the growing pains. They were beta versions, and we lived through those pains, and that really made us think twice about being early adopters of new technology, having a large fleet and taking on that risk when really we need to deliver service to our residents of the city of Toronto. But I look at this like the perfect storm right now. So how did we get here? Back in 2015, we started looking at alternate fuels, alternate technologies, seeing what's in the market. What could we potentially trial, pilot? Could we go out and buy to reduce greenhouse gases, reduce operating costs, improve reliability? And then the perfect storm happened. You had the City of Toronto who released their Transform TO target to reduce greenhouse gases in the city by 80% in 2050. And then you had PTIF, so the federal government came in with a funding opportunity, 50 cents on a dollar. It only happens once every 10 to 15 years. And that was a huge opportunity for us when you're looking at new technologies and mitigating some of that risk and that capital investment. Having some of that partially funded by the feds is massive. And so we went on and decided that we were going to get into electric buses as well. And we came up with our own target of going zero emissions, solely buying zero emissions buses in 2025 and on, and trying to achieve a fully zero emissions fleet by 2040. And that could be a mix. It's zero emissions, even though we're focusing right now on electric buses, I will say that it's not just electric buses, there's potential for other technology, including fuel cell or something else that might come up. So this table is our fleet plan. So I'm proud to say that in 2018 was the last clean diesel bus we bought. Moving forward, we only plan on buying a mix between hybrids and battery electric for the next 5 years leading into 2025. It's a gradual ramp up of electric buses in that mix. And then in 2025 on, we would plan to buy only electric buses or zero emissions buses. I will say the one problem with this is that currently none of these procurements are funded. So we only have funded procurements up until 2019. Anything beyond 2019 is currently not funded. But the good news is that we do have funding to continue with feasibility studies to work on the design of our facilities for the charging infrastructure and the smart charging system that would then integrate local energy and our dispatching software and assist with the operations of these buses and new technology. So just a quick recap timeline. So in May, we received our first electric bus from New Flyer. That bus was subsequently commissioned and put into service June 3rd. Just a couple weeks back in August, we received our first Proterra, and we're currently undergoing commissioning. I think we have, as of today, I think we have 8 on property. And in October, we expect to receive our first BYD bus. And then in Q1 of 2020, we expect to receive the last of the 60 buses that we are procuring as part of this program. And then in March of 2020, we expect to have a substantial completion of a backup generation. One of the issues we see with electric buses is the risk with power outages and how to mitigate that risk and add resiliency into our fleet. So we decided that we would have backup generation that would be CNG powered to protect us in case there is power outages. So just a quick recap of our program. We're buying 3 different types of buses from 3 different vendors. All 3 buses very different, other than that they're 40-footers. When you look at the electrical propulsion system, they all bring different approaches to the table, from the design, where you have a single traction motor to a single traction motor coupled with the transmission to a dual in-wheel traction motor system. Even with the charging, they're very unique, where 2 use DC charging using the SAEJ 1772 protocol, and then BYD has their proprietary AC charging system. But besides the propulsion system, the buses are very different. The body construction is different, where you have a composite body versus a stainless steel body versus a carbon steel body or frame. You have different HVAC systems, different door systems. I mean, the list goes on. So our program really, and I know that we call it a pilot, but to me, it's not a pilot, it's a program, because we bought these buses. We plan on keeping them for their full life cycle. We plan on studying them and understanding what the impacts are of that full life cycle with respect to, operating costs, maintenance costs, reliability, greenhouse gas emissions, et cetera. So we plan really, our program, the focus is to run these buses and understand all these different systems on these buses and the different design approaches that each one of these OEMs took to help formulate our next procurement spec when we go back on the street and buy more electric buses. Hopefully this time we'll be buying a TTC electric bus, and it'll likely be a blend of all the good features from all these 3 buses that we're trying today. So when we talk about infrastructure, again, we had 3 buses, and we decided that it wouldn't be fair to our operating garages to saddle them with 3 different bus types all introduced at the same time. So we decided that we'd have to separate them or segregate the buses by division. So we have 3 divisions that we selected that will be each running one of those bus OEMs. And we tried to spread it across the city. And so part of the thinking that took place when selecting garages was really to understand first off, the skill set at that site. We have 697 legacy hybrids in our fleet operating at various divisions. So we had a leg up on some other agencies because we had some high voltage experience and electric propulsion system experience and controls. So we kind of looked at those divisions first as those are the optimal places to put an electric bus as kind of a gradual increase in technology. And then we looked at energy available on site. So the program had a deadline with the PTIF deadline where we knew we couldn't install substations or get massive amounts of energy at the site. So we had to understand how many buses could we charge, what's the energy available. So we had to look at what's the size of the transformers, how much energy is being used today, and what could we charge. We came up with 10 buses, and we were then challenged by our board to go to double the fleet, from 30 buses to 60 buses, which we now are going to accomplish by introducing energy storage. So the energy storage will get us over the hump for the extra buses that we are charging. We don't have energy on site available, but we will be using energy storage that we would charge during the day and then deplete at night to supplement that charge. I see I'm running out of time here. So planning for the future, we've done some studies. Cutric's modeled our entire bus network to identify which routes are prime for today's technology of depot charged buses, which routes are optimal for opportunity charged buses, and then maybe a supplement of routes that maybe you need to look at other technologies, whether it be fuel cell or something alternate like a hybrid. So with today's technology, we feel that roughly 50% of our service can be satisfied between short runs and swing runs. And then we have another complement of probably another 30% that could be satisfied with kind of the next generation of buses with more energy on board and a higher charging power, which we foresee happening in the next 5 to 10 years that technology will be here. And so right now what we're doing is a feasibility study of all our 7 garages to understand what the effort required to get the energy there and what kind of real estate space we have, what does the charging infrastructure look like. We think it's going to be an overhead approach just to maintain our storage density in our depots. And again, I mentioned earlier that our bus procurement program is not funded for a few outer years. So, we're looking at market engagement to see if there's any public-private partnership opportunities out there. And then, of course, we want to do a future state route and energy optimization study. I think it's obvious that at some point, all agencies need to look at their routes and possibly modify them to accommodate some of this technology and find efficiencies. So this chart here is really a chart representing what we forecast for, fuel and energy savings from switching our fleet, looking at our fleet plan and the different mix of buses that we have retiring today and the outer years and what their fuel consumption is and what we forecast is going to be our energy costs. And you got a higher and upper and lower limit, which is really kind of a risk where we don't know what energy costs are going to be when we have a large fleet. We have some forecasts from Toronto Hydro, what we think it'll be. And so that's really a range of kind of best case, worst case scenario of what the savings will be. But they're very substantial, between upwards of $30 million all the way to almost $50 million once we have a full fleet electrification. And of course, complementary to that similar trend, it's the GHG reductions, where we're looking at when the fleet's fully electrified, you see reductions of 200,000 tons of GHG. This is just a quick snapshot of what we envision for the future. It's kind of having a microgrid at our divisions where you have energy coming in that would go through a substation, which would then take also energy from on-site solar energy and feed into a smart charging system that would also manage the energy storage that we would use for peak demand shaving, and backup generation. And this will all be controlled through a smart, intelligent energy control system that would take into consideration dispatching of buses, what state of charge is, what the state of charge needs to be for whatever route that bus is going to be deployed to the next day, and try to find efficiencies in optimizing the whole operations, which is a huge challenge. So recommendations, first and foremost, engage with your local utility company. If you're really thinking of going electric, you got to start talking to your local utility company. Understand what the energy is that you have at your facility, what you're using today, what's the balance of energy available, and also identifying what kind of challenges you're going to see if you want to go full electrification. How far are you from a transformer station? How much effort is it to bring that power to your site? Analyze and model your routes. You don't know what you don't know. There's plenty of data now in the market. There's plenty of tools. Cutric has done a good job of modeling our routes, and it's actually very accurate to what we're seeing today. So you need to understand what that mix is between your fleet. If you want to electrify at a very fast pace, you will have a mixed fleet between depot charged buses and en route charged, and you need to analyze your routes to understand which ones are those that would be depot versus en route, and what divisions they operate out of, and what makes sense for your operations. Look at SOPs. Your operations are going to change. we encourage you to do like a tabletop exercise. We did it. We called it like a day in the life of an e-bus. What changes? What's different between a diesel bus versus an e-bus when it comes to bring the bus in? Where do you park it? How do you clean it? Who's charging it? Who's monitoring the charging? Who's dispatching it? What are your rules for dispatching? What do you do if the bus breaks down in service? What if there's dummy lights that come on the dashboard? How do you handle them? Do you take a bus out of service? Do you keep it in service? So these are all things that need to be taken into consideration. And probably the most important point is my last point, which is don't wait. Everybody's complaining about the technology being expensive. It is expensive, but guess what? The more people that buy buses, the lower the costs will come down. And you don't know what you don't know. So even if you're only buying one bus, if your agency doesn't have the capital to buy a large fleet like we are doing, and mind you, it's not because we have money, but we've taken advantage of federal funding opportunities. But the reality is that you don't know what you don't know, and if you even have one bus, you can learn so much from one bus as far as how it performs in your routes, because every agency is going to be different based on duty cycles, based on routes, profiles, topography, loading, and understand what the impact is to your operations. What's the maintenance like? How are your operators going to adopt to this? How are your maintainers going to adopt to it? How are you going to manage your charging events and dispatch buses? So even if you start with one bus, it's better than doing nothing and sitting idly and waiting for everybody else to do studies and coming into the game after the fact. And I'd want to also say that by coming in and experimenting with these buses, you actually have a chance to influence the design of these buses and software and solutions that are coming out right now that are really being driven by agencies like TTC and New York City and Brampton and TransLink and York and all these other agencies that are going to try these buses and identify issues in their operations and find solutions which then OEMs will work towards satisfying their needs, and then agencies that haven't participated kind of fall behind, and by the time you come to the game, you're going to have to adopt to how we do things, because no one's going to want to customize something just for your operations. And that's all I have.
Thank you so much. So if anybody was in doubt previously about the passion at TTC about this program, let that be settled. There's an oodles of passion and a very large amount of passion at the electrification team at TTC, and we're excited to be working with them. And with that, I'll turn to Scott Gilner at Brampton Transit, who's been around town for the last few years trying to make this happen, and we're excited to hear what has come of all these efforts.
So good afternoon, everyone. Pleased to be here to provide an update on Brampton's e-bus program and our experience to date. I'm going to speed through the slides as quickly as I can, but probably not as quick as Josipa. So that's one thing I have learned working with over the last 5 years: talk quickly and get your message through. So first and foremost, Brampton is a green city. The city of Brampton's committed to becoming more healthy, resilient, and environmentally sustainable. Brampton Transit's committed to providing innovative solutions to provide high-quality services that reduces operating costs and improves the overall carbon footprint and GHG reductions. So a bit of background on Brampton, just before we get into it, to give some context. Brampton, for those of you that don't know, we're known as Canada's flower city, so hence the environment. We're the 9th largest city and one of the fastest growing cities in Canada. We're outpacing the national average in terms of population growth by 2.5 times. Our current population's about 650,000, expected to grow to 1 million by 2040. And we have one of the youngest census population bases in Canada, with the average age of 34.7 within the Toronto area. So very high expectation in terms of technology and environmental sustainability. We currently operate 441 buses in our fleet. We operate only rubber wheel transit. We operate bus reliable transit service, to couch Paul's phrase from the keynote this morning. Love that. It's called the Zoom service, and out of that we have about 123 diesel electric hybrid buses. 80 of them are 60-foot, 43 or 40-foot, and we're seeing about a 23%, up to a 23% reduction in fuel savings, equating to about 4,000 tons of GHG reduction per year. So that's about almost close to 30% of our fleet is currently diesel hybrid electric. So we are transitioning. To top off the growth issue, our ridership growth has far exceeded the national average of about 1.5% in 2017. Our growth was 18% in 2017, 14% growth in 2018. So we're growing, and that's definitely a challenge that we need to make. So in terms of the Cutric project, obviously we're going to be looking at the performance, maintenance, and customer experience of electric buses versus our diesel hybrid versus diesel. The project's been recognized as a global first, and with that we have the great opportunity to claim the largest global deployment ever to date of fully interoperable battery electric buses and high-powered overhead opportunity chargers. We'll have 80 buses and 4 chargers, which I'll get into. And the total project value is about $16 million, with 70%, and again, I say that again, 70% of funding coming from the federal government. So thank you, Government of Canada. It's something that we don't expect to ever happen again, but certainly we're thankful that they were able to step to the plate and solve our funding gap. So we're currently in the pre-procurement bid phase with our 4 vendors, and we anticipate delivery of our buses next year, so we'll be happy to report back at that time. So in terms of the buses themselves, we're going to be acquiring 6 New Flyer Excelsior Charge, 200 kilowatt batteries on board, 2 NovaBus LFSEs with 76 kilowatt batteries on board. And Mike alluded to the fact that there are different strategies for different bus types, different battery capacities. You know, the New Flyer buses tend to be a bit heavier, but have a longer range, so less frequent charging, whereas the NovaBus are a bit lighter. You can accommodate more passengers. However, the cost is more frequent charging. So you really have to balance off which routes these buses are traveling on, and that's part of the phase 1 study. We are going to be OpCharge compliant J3105-1, inverted pantograph down to the bus, which is expected to be approved by the end of this year, hopefully. In terms of our routes, we've pre-selected 2 routes. We went through a fairly rigorous process to select these 2 routes as part of our phase 1 trial. We wanted a high percentage of success for phase 1, obviously, so we've decided not to include the battery electric buses as part of our BRT, just given the extensive demands on the BRT service and the expectation of reliability of that service. We'll consider that for a future phase. So we are electrifying 2 routes. The Route 23 Sandalwood runs east-west across the city. There'll be opportunity chargers placed at the westerly terminus as well as the easterly terminus, and unique to this project, we're actually installing an overhead high-powered charger at our Sandalwood transit facility for maintenance purposes rather than plugging in overnight. So those are the 2 routes. In terms of the civil works, that's been an ongoing challenge. We look forward to working with our partners at Siemens and ABB to provide us a full turnkey solution on the chargers, which is another unique trait that we're bringing to this project. We are expecting a full turnkey solution. This location's our westerly terminus. It's the northern end of a GO station. We're going to have 2 opportunity chargers installed there, working with our utility in the area of Electra. Similar setup at our easterly terminus, which is our Queen and 50 location. This is a BRT stop, and it's also shared currently with YRT, York Region Transit. So to Anne Marie's point, we need to start working together to understand the future, and in the future we could actually see YRT e-buses coming into that terminal and charging at this location as well. So it's a great strategic location for us. So let's talk a bit about influencers in terms of going electric. And certainly the first and foremost is you need a strategic direction. If you don't have that, you're going to have a hard time getting any approvals. You're going to have a hard time getting any funding. You need strategic direction. So if you don't have that, get that first. That would be my advice. Thankfully, our council just this past June declared a climate emergency declaration. So basically, we've got a target similar to TTC where we need to reduce GHG emissions by 80% by 2050. We also have a Brampton Vision 2040, which is the city's vision to 2040, and part of that vision is being a green city. That's supported by our Grow Green Environmental Master Plan, our Community Energy and Emissions Reduction Plan, which, interesting to note, the orange, I know you can't read the graph, but the orange, just looking at the color, is showing transportation in Brampton in terms of GHGs. So it's 59% of GHGs within Brampton is created within the transportation sector. So obviously, as the public transit agency in Brampton, we need to step up and be champions and stakeholders and leaders in that. We have a zero energy emissions and management plan getting to zero carbon. That's more prevalent for our facilities. And we also have our Brampton Transit Business Plan, and future iteration of that will include a green fleet strategy to get us there. So our next step in 2020 is report to council across the city and how the city transit being part of that will achieve that target by council. The other influencer obviously is the savings. So when you start talking about savings, you're looking at a return on investment. You look at the ROI in terms of buses only, and we're anticipating about a $3.6 million return on our 8-bus investment over an 18-year bus life. And that's including the fuel savings and the maintenance savings that were expected as part of our modeling. The unknowns obviously is the gray area, we call it, the scary area where we don't know what we don't know, to Mike's point. We don't know anything about ongoing maintenance for overhead and on-street chargers. Brampton Transit is not in the electricity business. It's not part of our business. And another unique aspect of the project in Brampton, Brampton Transit, City of Brampton will be owning the 4 electric chargers. It's an asset we've never owned before. We don't operate them currently, so that's a scary thing for us. And obviously the additional service planning impacts, running time and vehicles as well are unknowns. And electricity as a fuel is an unknown to us. You know, we're a transit agency, we run on diesel, we're comfortable running on diesel, we're comfortable with hybrid electric because it's diesel, but we're now completely switching a fuel source, which is completely different for us. So challenge in terms of funding, the F word, Anne-Marie used it earlier. I can underscore that. Having lived through this with Josipa for the last 3 years, it's taken a long time to get us to where we're going. I think the key message here is we need predictable, sustainable, dedicated funding that is bipartisan, that's centrally managed, that's streamlined, and it's easy to access for the transit agencies. It's really challenging trying to secure federal funding, provincial funding, municipal funding, get municipal approvals, all within the window of an OEM's manufacturing schedule. So very, very challenging. The infrastructure, you need a transition plan to get you from diesel to somewhere in the middle to eventually fully electric. So start thinking about that now. As many people have said today, it's not going to happen overnight, and we don't expect it to either, but we've started that process. Limitations on existing infrastructure, space constraints around your locations. You're not going to have the space all the time to deal with what you have to deal with. And, you know, in terms of Brampton's growth, we've got 440 vehicles, as I said earlier. We're going to be growing that to 900 vehicles by 2035. So that's a significant investment, over 450 vehicles over the next 15, 20 years. We're buying those buses now for a 15 to 18-year bus life. So the decisions we make today will affect us tomorrow, and it'll affect future years' procurements of buses as well. Timing, expertise, and resourcing. I'll just touch on the timing. Aligning the stars is difficult, as I mentioned. Be aware of electoral cycles. Josipa mentioned it earlier. I can't underscore that enough. We need to be more strategic in how we time our projects, and be aware of this at the federal, provincial, and municipal level, because it does absolutely have an impact on your projects. And make sure you're getting the appropriate resourcing and buy-in for the project. Key lessons learned, funding and timing. Make sure you have the funds aligned with your timing. Consortium, going it alone. One of the key benefits to joining a consortium is de-risking and sharing that risk with the OEM. So Brampton couldn't do this alone, and we're thankful to be part of this consortium-led project. Procurement and modeling and scope. So basically, one of the biggest lessons we've learned is it's not a one-to-one replacement. You need a dedicated project team. You need to have resources in place, including a project manager, following project management methodology. You can't do this as part of your existing business. And that's what Brampton's doing now. We're feeling the pain, but as we start to transition, we're taking those lessons learned as we move forward. And that's all I have. So thank you very much.
Thank you, Scott. So a lot more lessons to learn as we go forward in the next year procurement. I'm looking forward to having you back to tell us what you went through. Somebody who has gone through it now and has come out the other end, and the buses are now launching. We're about to start collecting those data is Dom Repta. Dom at TransLink is going to share with us a little bit about those experiences. And I think also, Dom, you have a bit of data that you're going to be able to share as well.
Mine's more full fleet, but I can talk to some of this as well.
That's great. Thanks so much, Don.
Thank you. So we did just launch 2 buses in service right now, then 2 more at the end of the month, part of the Cutric trial. So 2 Nova, 2 New Flyer, 1 ABB Charger, 1 Siemens. So my presentation is on, we've done a full fleet, kind of full low carbon fleet transition plan. The learnings we are going to get from the Cutric trial will definitely feed into kind of our full fleet plan, which is great. Is it just this one here? It's just the big green one. Okay, so TransLink, who are we? We kind of do everything under the sun other than fly planes. But the crucial thing for us is we have 160 million riders last year. That's almost 500 for our bus fleet only. That's almost 500,000 people a day. So while headlines are great, we're going to fully electrify by 2030 or 2040 or 2025, we need to understand that that is great for climate change and we have to do it. But if we do change too fast and one person misses a doctor's appointment, is late for work, that's one person too many. So while we want to make the change, we have customers to serve first. So that is always in the back of our mind. My CEO calls mine and my director every day. How come we only have 4? Why don't we have 50? Why are we making these commitments? And I said, well, we will, but we still need to think about our service here. So the good. It was an amazing day that we had on Wednesday where we launched our Cutric trial. And 4 buses, 2 chargers, took 2.5 years to do. So we have 1,496 more to go. Because we're running 1,500 buses, and we do have a commitment to. The commitment was made to only buy battery buses out of 2025 and on. We'll see if that's going to be exactly how it goes. But again, that 2.5 years of information that we got was invaluable. We started with a team of 4 or 5 of us at TransLink, the head office, thinking 4 buses, 2 chargers. We got the locations, we got the buses, we got technology. They're all trusted OEMs in this field. How hard can it be? We had a weekly call twice a week, and the team grew to 30 people on every call. So the resources to put in 4 buses and 2 chargers cannot be understated. And not to dissuade anybody, because it's well worth it and it's what we need to do. But when you're thinking of who's on your team, what expertise do you need? I'm sitting as a senior sustainability advisor. I don't know anything about scheduling. I don't know anything about maintenance. I don't know, well, it sounds like I don't know anything, but I don't know anything about, how electrons go from A to B. I can project manage and maybe give a good presentation. But the amount of partners that we needed with this was just phenomenal. So I just can't understate the knowledge of your operational companies and people who've been there 20 years, 30 years. The mechanics, everybody for this was instrumental for us. So we have a lot of lessons learned. Anyways, we were tasked to come up with a full fleet electrification plan from 2020 to 2050. So this is what we're doing. I put this slide up. So we have a procurement strategy where we have basically 500 buses by 2027. And then after that, we have a bit of a break in our procurement. So that's 1/3 of our fleet. If we miss this opportunity, if they were all diesel buses, that's 800,000 tons of GHG that we miss out on. Now, again, it makes my head spin a little bit, thinking of how much work we have to do here. But this is a massive, massive opportunity for TransLink to kind of make this change that we need. The big thing is that if we want to start doing this in 2023, we need to start planning basically now, whether it's depot charging, en route charging. I will say we do have those 4 buses on Route 100. By 2021, we plan to have 19. So we are procuring those. The infrastructure's in place, so that's the easy part at least. So this is a really big challenge. So with our low carbon fleet strategy, what we did is said, what's the current state of technology today? We have 1,500 buses. Just like you said, we're not going to do it just at a depot, and we're not going to do it just en route. We have 7 depots, and we're building a new depot that will have capacity. Originally, we thought for 350, but looking at infrastructure needs, I think we're getting down to the 280 point. So what we did is said, well, current state of technology, let's look at our current route. Half of our buses go over 250 kilometers a day, more or less. Some of them go up to 700 kilometers a day. Well, current state of technology that we think is that a depot charge bus, and we're planning for mid-life capacity of the bus, not sticker price day one. We think at midlife, a depot charge bus at 440 kilowatts is not going to go 300 kilometers. Maybe they'll prove us wrong. So that means for today's planning, we need to plan half of our buses. We're planning half for depot, half are en route. Maybe if somebody can, if technology changes, which we think it'll improve, that will change. It's very scary for a transit agency to think about having a ton of infrastructure that you own or don't own out into the environment. Now, we have a trolley network in Transit. We have 262 trolley buses, so we are used to having some infrastructure throughout the system, but adding in 100 chargers throughout the system scares people. Not owning that infrastructure, which is a proposition that we may consider, is even scarier. Transit agencies generally own and operate all the infrastructure. So what we did, we said, okay, well, let's look at what our en route charging network would look like for half of our buses. The other half we'll save for depot charging. So this is Metro Vancouver. We say we need, we'll call it 100. 100 overhead, 450 kilowatt hour ports. Now, those big circles, that's 13 ports, chargers at one location. The amount of space you need for 13 ports at one location is a lot. I don't know, from here to that wall, or Steve, you would know, how big is the footprint of all the charging infrastructure you need? It's massive. Yeah, so Steve from BC Hydro is a massive partner for us. So I don't know, so this is really scary when you look at this. If you have 100 chargers, I will say what's key though is we partnered with BC Hydro, which has been amazing. So what they did for us is they went, pretty much assessed every site and said, what infrastructure is there? What do you need? What's the timing? And what's the cost upgrades? So they provided all that for free. There's some benefit for them in the end, we hope. And so we kind of did this analysis. Would this be hard, kind of medium hard, or easy to do? Then we looked at our own costs and said, well, what do we need to do to make these a reality? So it's quite challenging. I mean, putting in 100 charging ports throughout the system, could we do this in 10 years? I mean, we just took, I said, a couple years to do this demonstration, which we think would be accelerated. But just construction, permitting, BC Hydro schedule, we're not the only game in town. There's large fleets, there's personal vehicles, massive growth, so there's a lot of competition to do this. I think we're an essential service. Maybe we should get some priority, but that's not my call. The thing is, this is not a 2 or 3 or 4 year project. This could be a 20-year project, so timing is of essence. Then we went into our depot charge. So this is generally a 70-slide presentation, just so you know, down to 7 or 8. We went to depot charging and said, okay, what we think the current state of the battery is in 7 years, but then also let's look at what, if you turn the heaters on full blast on a 0-degree day, what does that do to the battery? Well, our kind of information of networking with other transit agencies, which have been really great sharing information, we think that we could get 170 kilometers at midlife on a 0-degree day in Vancouver. It does go to 0 and below in Vancouver, it gets to minus 20 some days. So this is a real impact. Then we said, if we had 1 0-degree day in Vancouver, what does that do for our depot buses? So that chart on the left, that 1.4, 1.3, 1.6 you see, is compared to a diesel bus, how many more buses do we need, a battery electric bus, to do the same service a diesel bus would do? That's on one day. We have more than one day. That's 0 degrees. So you're looking at numbers of 1.4, 1.3, 1.6. We can't underserve because it's cold out. So what does this mean? This means an extra $400 million in buses for some cold days. Now, the option is, of course, use a fuel heater, which solves the problem. The problem is saying you have zero-emission fleet and saying you're using diesel heater or propane heater isn't exactly the message we want out there. Our marketing team hates it. We don't like it. The greenhouse gas impacts are quite small. I think we go from a 95% reduction to a 91%. So it's not major, but it's still enough, and it's just not where we want to be. So we've done some testing already with the buses that we have, and the heating draw is as much as we figured it would be currently. So for any of the battery OEMs up there, we need, if you could work on this, that'd be great for us. What do I have left? Some more time. So I'm just going to flip through this. The good. Greenhouse gas. So we did a whole greenhouse gas assessment. Of course, not surprising that we see massive greenhouse gas reductions from our baseline fleet. Partnerships. I should have put Cutric up here. Sorry, Josipa. They've been one of our best partners for this whole thing. I'm just going to, here, I'll just give you that's better than a logo. That's much better than a logo. You see an outlier here, Fortis BC. Someone said it's not all about electrification. We do buy RNG as well because we have a CNG fleet. But BC Hydro, New Flyer, Nova Bus, Siemens, ABB have all been fantastic. Utilities are key. We're working with BC Hydro, and I'm not joking. They have done hundreds of hours of work for us on our low-carbon fleet strategy. We're also working with them on a special EV rate, so to give us an incentive to do what we need to do faster. We're also working with them in BC. We have a carbon credit program. So can we get the money if we electrify our fleet now? So that's a conversation they're really open to. What do I have left? Oh, one more after this. So working with your utility is mandatory. The good news is, I'm going to just go the graph on the bottom, is it's a shift from operational capital. We figure the next 30 years, it'll cost about $1.2 billion to do our whole overhaul, but we'll have about $1.2 billion in savings, primarily from fuel cost savings. So it's a change in thinking of getting that return on investment in 3 years, 4 years, 5 years, but it's a long-term strategy. And for now, we think this is like at today's what we think, and we think it'll get better. So the good news is there's a payback, and that's my 10 minutes. Thanks. 8 minutes.
I know what you're all thinking. Because he gave me a hug, I gave him an extra couple minutes, and it's true. So there we go. With that, I'm going to turn to Anne-Marie Caron. I think, Anne-Marie, did you want to add any additional comments? I'll invite you up here if you have some additional comments you'd like to add. Up to you? Yeah? All right. Anne-Marie, come on up for some additional comments. And I think most of us will recollect it was a fantastic presentation. You gave us a lot of insight, and anything in addition on the full fleet electrification strategy would be appreciated.
Thank you. I thought these three gentlemen here used up all my time, so I wasn't sure that I was going to get any. Anyways, I really don't have a lot to add, but I think just watching all the presentations from these three gentlemen here and even mine, you can see that we have all things in common. We have the same challenges, we have the same fears, and we all have the same funding dilemma and how we're going to fund our conversion over to electric buses. So I think it's really important to have organizations such as Cutric make sure that we all continue to be aligned as we're going forward, because like I said, we share the same issues, and I think we're going to learn from each other, and we're all going to be successful. And those who have not thought about trying electric bus technology, I think after today, I hope that this panel has inspired you in some way, shape, or form. And we hope you try electric bus technology and perhaps join Cutric, because Cutric will help lead the way to get you to be GHG free. So thank you.
We did not plant the shameless plugs, but we'll take them. So thanks so much. A great, fantastic group of people, a lot of passion, as you can tell, a lot of experience, and just uber amounts of wealth of knowledge and a willingness to share. So with that, we're going to turn to some questions for our panelists, and we do have the 2 microphones open, and I am sure that there are loads of people who want to know a little bit more about the deep, dark secrets and the great optimistic outcomes. So with that, we're going to launch right into a couple questions to get things started. First off, we're going to ask each transit agency, again, kind of parliamentary rules, try and get it out there in 60 seconds. What would you say has been the biggest win and the biggest fail, if you had to summarize, in terms of your progress through from where you started a couple years ago to where you are right now? So if it had to be the biggest win and the biggest fail, if you could do it again, this is what you'd do again, and if you could win it again, you'd repeat it exactly the way it was. What were those from your experiences? And Mike, we'll start with you at Toronto.
So I think probably the biggest win for us, or really a surprise, is just the acceptance from our staff, operators, maintainers. We expect a lot of pushback, new technology. Hey, who's plugging the bus? I need to get paid more. Or I'm working on a high voltage electric bus. I need to get paid more. Or I don't want to touch it. I'm scared because it's dangerous and I don't want to get electrocuted. So we expected these types of pushbacks, but it's actually been completely the opposite. I think everybody's very excited that we're going green. I think they like the technology. I think they like that the bus is smoother, quieter. Our patrons are happier, so I'm sure they're giving operators less of a hard time. And I'll share a quick story if I can do it in 30 seconds. But our very first bus that we dispatched, we actually had some issues with it on the road in the first couple of days. And we had that operator come in the next morning for that shift an hour early just to talk to our engineering team to understand, did he do something wrong? Because he did not want to get pulled off that bus. So much he liked driving that bus. So I think that's been key, is just us communicating with our staff well in advance of this program coming, and so that they know what's coming, what are the benefits, and they're all on board, and it's been really good for acceptance. On the downside, we've had challenges with dispatching buses, mostly with trying to get charge events, getting our staff trained, knowing when the bus should be charged, knowing when it has sufficient charge to put it on routes. and educate in that sense. And we've had some instances where we've missed service because we don't have an operator trained, or that bus just didn't have enough charge to go out in service because it just didn't get charged overnight and nobody was monitoring carefully. But we've worked through those struggles, and it's typical, growing pains for new technology.
That's fantastic. So deployment pluses and some deployment lessons learned. But you know, over the years, we've heard a lot about labor and the worries around labor. It's gotten less and less, I think, now with these experiences. But we used to hear, no, we can't. We've got a union. It's really strong. It's going to be really hard. But people are people. And just because labor is organized doesn't mean it's oppositional. And I think there's a great opportunity here to learn from how you've managed labor relations to get people to buy in. And Scott, over to you.
So for Brampton, I think, working with our OEMs on the charger side and the bus side, somebody said it earlier, the equipment's the equipment. So that's the easy part, I think, in all of this so far. We haven't launched yet, so we'll see if that stands true. I think for us, the biggest fail really was the loss of the $8.3 million from the provincial government that really ripped the rug out from under our feet. Literally we had to start from scratch, and transitioning back to the biggest win, obviously, was the $11.3 million we were awarded by the federal government. 70% funding on a project is unheard of. The federal government funding the purchase of buses is really unheard of directly. So that's definitely one of our biggest wins. But I think aligning it all was the biggest challenge out of it.
Yeah, absolutely. And one of the lessons we learned from that as a group was, the feds coming in and saving the day, but saying, and quite rightly, look, the federal taxpayer can't always save the day. That communities have to figure out a way to make this happen without federal ministries stepping in to save the environmental story. So great lessons learned on the financial and funding side. Tom?
Sorry, I guess.
Yeah. It should be, yeah.
Hello? Okay, yeah. I guess for us, so we are almost a week deep in having these 2 buses operating, 2 to come. I think the biggest surprise is the technology isn't really a pilot technology anymore. We're doing something very specific in Cutric, checking interoperability with systems that have never integrated before. But the buses and the chargers that we've not heard anything from the operations, which is great. So it's working, and it's working as we wanted. So I think dispelling the myth internally and to others that this is not a demonstration of pilot technology anymore is really valuable. And I said in my presentation, we really underestimated the resources needed for organizational change. I heard it from Edmonton last year. I talked to those folks, and they said, well, we've had thousands of hours working on this now. And I say, well, it's not us. We're going to do better. We've had thousands of hours working on this as well. So really, 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 you need to have a large team, committed resources to make it successful. So that was our challenge.
And to that point, we're hoping to have Paul Nesben here and the Edmonton Transit team. We couldn't make it happen, but next year for sure, because they got that right up front, a great in-depth project management approach, I think. And per your point, Dom, one of the things we used to hear a lot of was, look, is this an R&D pilot or is it commercialization? And OEMs never like hearing that this is R&D. And so our position was, that's why we don't call this a pilot. I know a lot of people call it a pilot. It's not a pilot, it's an integration trial. And there's a difference. The individual units are commercial, the integration is not yet commercialized, though hopefully that has changed. And so great points there in terms of getting over that hump with a lot of labor resources. Anne-Marie?
Okay, so I'm an optimist. And I don't feel like there was any failures at all. I mean, it's been a long, hard road to get where we are today, but it's all been positive. We did get ultimately where we wanted to go. Maybe took a little bit longer than we wanted to, but we're here and we're ready to go with that trial, that demonstration, and it's brought a lot of people together as well. I mean, with Newmarket Tay Hydro, it's brought a lot of people even internally. We have a really close relationship now with our environmental services people because the greening strategy is theirs to deliver, and we're going to be the ones that deliver that for them. So I think it's all been very positive. Yes, it's been difficult, but there's nothing negative about anything that we've done at this point.
I concur. So in the world of relativity physics, we say there's an infinite number of ways for a unit or any kind of subatomic particle to get from point A to point B. And I think that this is a great example. You eventually get to point B. There's just an infinite number of ways to eventually get there. So with that, we're going to turn to the audience and remind folks that if you do have questions for the transit agencies, make sure to line up so that we do have query time for them. But I'm going to turn to you, Dom, to start the next question. We've got a lot of folks here from Winnipeg Transit. in the audience. What is the piece of advice that you would offer to Winnipeg Transit specifically if they're thinking about moving electric in a city context, in a provincial jurisdiction? That's a little bit tough. Not everything's aligned necessarily. They've had some experience with electric buses here, but it's going to be a long haul ahead. And in your presentation, you didn't tell us, is it going to be depot or en route? And so could you give some insight to Winnipeg Transit? They're about to start going through the same thing.
Yeah, I was just thinking about what we could do different. So for our low carbon fleet strategy, sometimes I say when you do your route analysis, you're basically putting a square peg in a round hole. Because what you're doing is taking a brand new existing technology and trying to fit in what you're already doing. So we're trying to fit battery technology into the existing routes. I think what would be really valuable, probably very costly too though, is to look at the technology and design your transit route based on battery buses, not based on diesel technology. That's what we're doing, and that's where we're at right now. But I think there might be a couple agencies who are saying, well, we're going to do that as well because we have to, but what if we designed it just with battery technology? What would it look like then? I think we'd probably get a bit of different perspective and maybe a different breakdown of what is a depot and what is an en route. So if you have the resources to do so. And of course, for us at TransLink, we have great leadership. We have, I think you mentioned having the policy, so we do have formal adopted board policy of greenhouse gas reductions and renewable energy, which has been a catalyst in moving us forward. So when we go to an operations or maintenance or someone who's like, well, what's this battery? Why are we doing this? Well, we have these commitments that we've made at the board and mayor's council level. So tone from the top and design for with the technology in mind, not just what you've already been doing.
So reiterating a little bit about the message that John shared from Proterra, which is basically design around the technology to some extent, stop thinking from the diesel perspective, as Kirk said. And from the TTC perspective, advice to Winnipeg Transit, if they were thinking this way, since the two of you have buses out on the road?
So I echo Dom's recommendations for modeling. I think it's very important to understand where you're going to put these buses and how you're going to launch them. Will they even work from a modeling perspective? And I mean, it's just communication through the organization. Bring all your stakeholders to the table. Understand what everybody's concerns are from the get-go and address those early so that you have a successful project launch. If you don't include all your stakeholders and you just assume that you're satisfying their needs or requirements, it's going to hurt you. It's going to hurt you at the wrong time when it's too late to make changes and satisfy their needs. And then you have discontent in the organization and it's going to impede your launch. So definitely bring all the stakeholders to the table, including the public, accessibility community, everybody, and just understand what everybody wants and needs, what are the impacts to their operations, and how you can work around to make sure that you meet all their needs.
That's great. And Michael, we're going to turn to you for our first question.
Yeah, this is just a question of clarification around some of the numbers that I'm hearing this morning. I'm here to learn, and I hear on the one hand that I think somebody said 60 or 65% of the energy consumed goes to HVAC. Presumably that's an annual average because it'll vary from winter to summer and so forth. Yet on the other hand, I'm hearing that putting a diesel heater in the bus only reduces the reduction in GHGs from 95 to 91%. Some of that isn't kind of adding up in my mind, and I'm wondering whether I'm misunderstanding that or whether there's more to it.
Yeah, I think the 65, I think so the two options, to run a battery, run the heating system on the battery, and that's where you're getting that draw. If you don't do that, the option is to use a diesel heater. So you're not using any of the battery capacity for heating of the bus. So there's two different scenarios. We haven't chosen, well, we'll see what we go with.
But I think
so that's where you're getting the difference.
I understand that, yeah. but if the heating consumes more than half of the total electrical energy of the vehicle, then how can that only result, replacing it with a diesel, only result in such a small reduction in the GHGs reductions?
So here I'll offer a little bit of insight, and I welcome inputs from the team, but essentially we've heard the question before, and what you're pointing to, Michael, is really the difference between energy density and the pollution and emissions factor. And in this case, if we could rewrite history, we would never use electricity for heating. It is not, using electrons to generate heat is a really poor usage of the scientific principles of not just combustion, but thermal heat exchange. So you just wouldn't use electricity for heating. It's a very inefficient system. Conversely, if we could rewrite history, we would never use diesel and petroleum for propulsion from an energy efficiency standpoint. We've got a lot of energy density, but we get a really inefficient engine system when you try and combust and use explosions to propel vehicles. So we've got the inverse, and as a result of that, when you you use electric heating, it's very inefficient, draws your battery pack, but it doesn't create a huge amount of GHGs. On the flip side, to create heat from petroleum combustion is quite easy because it's a heat engine, but it doesn't actually cause that many GHGs because you don't need that much diesel to create a huge amount of heat. So essentially, it's GHG emissions intensity is not the same as energy and density. And I think often the way we present it, it seems like it should be a zero-sum game, and it's not. And we often do talk about that, the energy efficiency of an overall system versus the energy intensity or energy density of the system. Does that make sense? Okay, great. So with that, Abhishek, we'll turn to you for a quick question.
Sure. Thanks, Josepha. So first of all, I would like to thank the panelists. You have truly been the pioneers, like the Canadian version of Lewis and Clark on an electric bus. So kudos to that. And like I have been leading the project along with Josepha from the Cutric side. So I have been I've been kept abreast of all the development that's taking place. So my question is like, based on the experiences that you had in our phase 1, how do you think that we can engage the municipalities better? Because municipalities is our first level of contact, and normally Cutric interacts with the transit agencies, and it is you people who go and interact with the municipalities. So we want to make sure that that level of interfacing goes on really smoothly so that we can take it up to like higher level, that is provincial, and directly to the federal level. Mm-hmm. And this is important because we are planning phase 2. And when I'm saying this, I'm looking at you, Mike. We are planning phase 2. So you know what to do. So yeah, that's my question.
Okay, so it's also underlying it a political question, and perhaps we can speak to your experience. How did you engage your council? And a lot of you presented the fact, well, and you're a little bit different, Dom, in the sense that it's provincially regulated. It's a kind of crown corporation of the province. But for the rest of the three of you, it was not so much, correct me if I'm wrong, you engaging your council. It's your council saying thou shalt go zero emissions, and then you engaged. And so can you explain to us and take us through a little bit your engagement with your council? Was it tense? Was it always workable? And what was the way of communication to get your council behind you 100%, even when the cost profile and the complexity started to become real?
So our original plan was to propose a very small program of between 1 to 5 buses to experiment with and learn from. That quickly got accelerated with PTIF and with outside pressures and council looking at other agencies like LA Metro that were all over the news saying that they were going to buy 120 buses. And so, they basically challenged us to go with a larger fleet. And after our analysis, we were comfortable with going with 30 buses based on energy available. And then they still challenged us to go with a larger fleet, not really understanding all the implications and challenges, especially on the infrastructure side. What I would say for the next step, really to get council on board, I think now it's 2 things. One is really delivering on your initial program, get it on time, get it on budget, get it buses in service, and then really is trying to now back up your projections for your original cost calculations for operating costs and maintenance costs and reliability, and now backing those up with actual data. And I think once you can go to council and say, we deliver our project on time and on budget, here's now our numbers for buses in service, and they're performing the way we expect them to. Here are the actual savings. We think this is a viable project. I think at that point it's a much more compelling argument to get them on your side to try to get that funding for full-scale electrification.
That's great. And Scott, you had a lot of interactions with town council, or city council rather.
Yeah, so for us it was more of an interactive discussion. It wasn't so much top-down, you shall go electric. Going back 5 years, it was more of a conversation around what can we do to improve the environment, and certainly going green and electrifying our fleet was one of the key recommendations that we move forward. So, fast forward through another council, a new council, the theme has always been Brampton is a green city, and that's clear in our vision. It's clear that our mandate is to become green and carbon zero as much as possible. So the funding has remained there, and as has the commitment from senior leadership as well as our council. I think in order to engage other municipalities potentially in phase 2 and beyond, you really need to look at the funding element of the project, and that's one of the key challenges that we faced, especially at the municipal level where capital and operating budgets are extremely tight. There's many competing priorities corporately, that transit's just one of those other priorities, but you look at the cost of a conventional diesel bus at, call it $680,000. You look at a cost of an electric bus at, call it, $1.2 million. You're almost double the cost, although you're seeing a return over time. To Sasha's earlier point, council doesn't think in terms of a 20 or 30-year budget. And I think that's something we need to start having a conversation with them on, because the returns based on our modeling is there. It's just how do you get that capital investment through debt issuance or through the tax base now to reap that reward in the future.
Yeah, and to be fair to councillors, I mean, councillors only know what they know. They're regular people just like the rest of us. And one time we were asked by Thunder Bay Transit to model out their fleet, and we did. And then they asked us to come up and present to town council or city council, and we did. And what was supposed to be like a 15 or 20 minute back and forth just query about it turned into, I think, 2 hours by the time we were out of there. And you know, councillors were asking questions about drones and fuel cell tech, and because councillors don't know what they don't know, just like the rest of humanity, right? And they're listening to the news. So I think your points about real deep engagement over time, whether it's financial innovation or about the actual costs, is critical, because councillors are just people, and they're certainly not oppositional until they're made to be. And Dom?
Yeah, I think you're right. For us, we didn't have a ton. We were governed by a mayor's council who really pushed us to do this, which was great. But what we're doing now a lot is more provincial representative engagement. And I think the big piece for us is they just don't know the kind of investments this takes. They're used to personal vehicles, and you know, some of the grant programs, Green Infrastructure Fund, they've been focused on personal vehicles or $50,000, $100,000, $1 million grants. One charger costs $1 million to $1.5 million. So when we're talking to government now, we're saying they're really supportive of what we're doing, but it's a bit of a reality check. Okay, it's going to cost $200 million by 2025 to support what we want to do. We don't have any of this money earmarked. We get a gas tax, which basically buys the buses for us, but there's a $200, $300, $400 million gap for infrastructure. So we started these conversations working with BC Hydro, BC Transit, our provincial representatives, and I'd say in the last month they're kind of getting their heads around what scale investment. $200 million isn't a lot in a provincial budget, but it is a lot for a transit agency to come up with.
That's right, in the grand scheme of things, but realizing at the time you're making the decision to allocate those funds is a big issue. And Anne-Marie?
Well, I think for us what worked in our favor is I actually have a very good relationship with our regional council. Again, we're a little bit different because we have 9 local municipal councils we have to deal with, and then some of those representatives sit at regional council. So we have a lot of councils to deal with. So it takes a lot of effort, but we do have a very close relationship with all 9 municipalities and their council, and of course that filters up to regional. So I think them having trust in you to deliver on time and on budget is certainly important. At the local level, they're very invested in green, whether it's recycling. Recycling's huge. Save the birds. Conservation, it's all important to them. So when you bring things like green technology to them at the regional level, they're pretty much already bought into it. And of course, there's always those champions on council, more so than the others. And again, you kind of work with those individuals to say, okay, well, how do we deliver the message that is impactful to everybody that's sitting around that table? And really they'll help us sort of design what that message is, and they'll help us really promote that message, and they'll put, let them put the other politicians on the spot. I'm not going to do it, but let them sort of, make the others sort of ante up and make that commitment towards going green.
Yeah, so get your political champions on the council to champion and cheerlead for you. Right. And I think there's a lot of folks in the room today from City of Winnipeg, and so I think it's just a great innovative city, a great innovative transit agency. There's a lot of opportunity to learn from this, and maybe one day we'll have to bring a traveling roadshow of councillors who are rah-rah cheerleaders from jurisdictions around Canada here to Winnipeg to help move the needle forward. With that, I'm going to turn to Karen Cameron at Opta for your question, Karen.
As quick as I can. There's been reference to the return on investment. What is the state of that calculation? How stable, I guess, is it, and how digestible is it? In our first meeting with the new Minister of the Environment back in January, the meeting began with him making the statement that, oh yeah, there's no calculation where there's any return on investment in electric buses, and it was just a statement. And that's not a partisan thing either. He got that calculation from the bureaucracy that was there when the Liberals were in power, and they had had the Climate Change Action Plan. So it wasn't about it being the new PC government. They just were using, as Anne-Marie said, a calculation that looked at the transit business model as exactly the same as the private car business model. So where are we at with that? And is it digestible for a transit manager who's taking it to their council, and has that ship sailed of having to make that business case?
Yeah, and to that point, Karen, I mean, so we're sitting in that room, for folks who were not sitting in that room with us, and Karen and I were asking the minister's office, essentially, where'd you get these numbers from? And they couldn't tell us. And then they said, go ask the Ministry of Environment. So we went, and they couldn't tell us. Nobody actually had the numbers, but everybody was certain that $1 of tax money spent to electrify transit would not pay off. So everybody's absolutely certain. Nobody could tell us where they actually came up with the numbers or calculated it. So 2 questions in the back end there, Karen. One is, what is your system thinking in terms of return on investment? So is there a yearly calculation? I know we did our modeling, but you may have your own internal ones. What's that return on investment? And from an emissions standpoint, what's your view in terms of $1 of taxes spent electrifying transit results in what kind of GHG benefits down the road in terms of impact? We'll start, Mike, with yourself.
So I think that's something that we struggle with, because at the end of the day, everybody wants to go green, but I think not too many people can stomach the costs that are associated with going green sometimes. And this is very high capital costs up front. It's something that we're working on with the business case, and it's a challenge. And I hate to share numbers, firstly because we're not finished our business case, but also we don't really have real numbers at this point. We're entering our 3rd month of operations. We're starting to get some numbers now on the cost of operating these buses. We don't know what the maintenance is like. We don't know what the long-term costs are like for an overhaul program, and so there's a lot of assumptions out there. From my own, my personal thoughts on this, because I've run numbers, I think it's going to be very comparable over the life cycle of the bus. I think it's comparable to a hybrid bus. I think it's going to be a wash. And to me, if it's a wash, I think we're already, I think that's a win, because it's a wash cost-wise, but from a green standpoint, it's obviously much cleaner. So, and the second question, that one's a tough one too, only because like, what's the price on green? Like, what value do you put on reducing that greenhouse gas? And that's like the magic question, and that's really what I think the solution is for all the funding problems we have, is if somehow we could attribute that reduction in GHG to some dollar value, that's the money, that's the missing piece of the puzzle to get money to pay for all this new technology and an adoption. But I don't know the answer to that. I think it's going to be a joint effort between all agencies and Cutric and bus OEMs and charger OEMs and utility companies. But I think together we need to figure out what's that value and convince people that there is this monetary value. We've been doing some work recently with C40, trying to look at other ways to put value on that with impacts to health, and that's something that's ongoing. And I think that's going to produce some really good numbers too that people don't even consider of having a full electric fleet and what that does to health costs for our health networks and improving a quality of life for people. So these are all things that are ongoing. I think in the next 2 years there's going to be some really big advancements, and you get a lot better data because there's more buses in service. And we should have a better answer for you, Karen, in maybe 1 or 2 years. But I hope that at the bare minimum, if we're equal to a hybrid, I think it's a win.
So equal to or better than a hybrid, and potentially if we can get a price point of $20, $50, $200 a metric ton, we'd actually be able to run those calculations, plus what we've called in the past the dead babies figure, which is a terrible thing to use, but how many kids die from asthma-related illnesses or heart attack from asthma-related or diesel pollutants? If we had a number, a macabre number to attach to diesel pollutants, we'd probably get this movement forward quicker. And Scott?
Yeah, so similar to Mike's answer, I mean, we've done some internal estimates based on industry experience in terms of, the maintenance and operation of e-buses in North America. We've heard different numbers from the OEMs, and we've kind of used a conservative estimate for the maintenance savings that we expect based on our experience with our diesel hybrid electrics. So again, similar to Mike's comment, I think it's going to be very close to that of what we're experiencing now with our 123 diesel hybrid electrics. You look simply at the capital cost of a diesel bus versus the capital cost of an electric bus, and you take that over an 18-year bus life, you look at the fuel savings and the maintenance savings year over year, and you do end up with a positive return at the end of it. So again, we'll be going through much more detailed analysis as we get through our project and actually get our buses on the road. But that's just on the bus side, right? So then you have to factor in the charger side. And in Brampton, we're going to own and operate 4 chargers. There's been talk with Electra to potentially transition those assets longer term, and they may have an interest longer term. There's been some conversations with OPG, But when we go live, we're going to be the owners and operators of the chargers. We don't know what costs come with those and how that's going to impact our ROI at the end of the year, at the end of 5 years, let alone the end of 18 years, when the life cycle of these are, probably around 10 or 12 years. So we're not sure what the maintenance and operation of the chargers is going to do to the ROI, but on the bus side alone, we expect a positive return over the life of that bus.
Okay, so time will tell as we figure out that ROI on the infrastructure.
Yeah, just quickly, so we've done the life cycle cost modeling as well, and the same thing, it pretty much comes out to equal as what we do baseline diesel. But one thing we didn't factor in, but we understand is there is a price on carbon, and we actually get it at TransLink. We have compressed natural gas that we sell to other fuel suppliers in British Columbia. So we have a low carbon fuel standard program in BC. Last year, through the province, the average price of selling a carbon metric ton was, I think, $180 per metric ton. So that's a very strong market. So we've done some analysis on what electrification of our fleet would bring in annually from carbon credits if we got them, and it's around $20 million a year. So add that over 20 years, 30 years, that outpaces the diesel argument. So it's not even an argument anymore. So there is a price, and we don't think that program is going away. So yeah, there's definitely a price, and we're going to monetize it.
And obviously over 20, 30 years, the price goes up, so the money increases, right? Anne-Marie?
High five to BC Hydro.
Who's going to lose that money if it transitions over, but we won't talk about that right now.
It's not a loss. It will be anything incremental going forward will be reinvested in the sector, so please don't.
Win-win, win-win scenario.
No,
That's fantastic.
It's been fantastic.
And Anne-Marie?
So I don't think I can really add anything to what these three gentlemen said, other than an interesting point was made was that human factor. And that's something that we haven't considered into our calculation, is what is the impact to the environment and as far as a health, from a health perspective. So I think that's maybe something we need to do going forward, because we can crunch numbers and we can divvy them up either which way, but there is other costs associated with what we're doing, and I think we need to include that in our calculation.
Absolutely, and I'm really sorry, folks, we've run out of time and you've stood there so patiently. What I'm going to ask you to do, though, is articulate your question, and we're going to conclude on your questions as questions to return to. So we'll start here. If you want to just let us know what was the question.
Kevin Sturgeon with Winnipeg Transit. The question was, battery electric buses are heavier than other buses, and heavy vehicles damage roads. So have any of your jurisdictions considered whether this will have a significant effect on greenhouse gas emissions and cost of the road rehabilitation cycle?
And something for us to come back to in our next panel, where, Mike, you're going to be on the panel. In any case, talking about evidence, we've definitely talked about the idea of heavier buses and infrastructure impact. So if you can hold on to that question, I think the next panel is going to have a little bit of insight. At least, Mike, I'm going to task you with that. And the second question?
Sure. Boris Kaganovich, LTK. Question, how much is real estate space a bottleneck for charging infrastructure? And then also a follow-up of, do chargers scale in terms of if you buy more, do they get cheaper per unit?
All right, a quick answer to that, yes. But back to the next panel in terms of real estate and space constraints. Some of our panelists respond to that. And then the roadway infrastructure degradation, the impact on GHGs and unintended consequences of electrification. With that, I'm going to thank our panelists for a fantastically insightful, from the transit agency perspective, electrification discussion. Thank you very much, folks, and I'll ask you to exit that way. And with that, I'm going to turn to introducing one of our upcoming moderators. We're going to switch gears here a little bit. So I'm going to invite Jess Daw, who is Senior Policy Advisor for Clean Energy Canada. And Jess is here with us from Clean Energy Canada. We've invited her to serve as the moderator for this panel. And Jess, I'll let you take over.
Hello, everyone. I'm loving that big transit energy we just had on that last panel. Hoping we can continue it on. So as Josipa said, my name is Jess Daw. I'm with Clean Energy Canada. We are a program based out of the Centre for Dialogue at Simon Fraser University, where we're working to transition Canada to a clean energy economy. Something that we released earlier in 2019 that's really relevant for the group gathered here today is a report called Will Canada Miss the Bus? And that explored the current use of electric buses at home and around the world and the opportunities that they present for Canadian manufacturers, transit operators, and of course the riders. We're also involved in the Global Drive to Zero initiative, which is designed to catalyze the growth and adoption of zero and near zero emission medium and heavy duty vehicles, of which buses are a big part of that. And so, you know, suffice to say, we're really on board with the shift to electrified transit, pun intended, and that's why I was pleased to be asked to be the moderator for our panel, which is titled Going Forward by Looking Back Field Data from Transit and Transportation Electrification. Now, perhaps you were super keen and you read the panel description online. Maybe you have no idea what this panel is going to be about. If it's the latter, I've got a little description for you. I think there are going to be a lot of synergies and overlaps with the last panel, and it won't be repetitive though. So we know that with any new technology, the unexpected or the unplanned for is really to be expected. And so with our panelists, we're going to explore the ongoing outcomes of transit experiences on the road with a variety of electric bus technologies. We'll hear from our panelists about the benefits, the pitfalls, and the workaround solutions that they're innovating to overcome the early stage growing pains for fleet electrification. The goal is that at the end of this session, you're going to walk away with some recommendations and best practices for transit systems here in Canada based on our panelists' real-time and historical experiences. Of course, as some folks earlier have said, transit agencies, you know one, that's all you know. So it's a little bit of, it's not so much apples to apples, but I think that you'll walk away with some inspiration, some food for thought. So I'm going to join or ask my panelists who are just getting to know each other over there. Pierre, Mike, and Ray, come on up. You all know Mike, so that's great. How the next 65 to 70 minutes are going to unfold. It's going to be pretty similar to how the sessions previously unfolded. However, I'm going to give a bit of more of an introduction, a bio for each of our panelists, and then they'll do a little presentation, and then I'll pose a few questions, and then we are going to have time for all of you, and we will get to those questions that were posed. We're actually, sadly, one of our panelists wasn't able to make it, so that actually maybe gives us a little bit of time for the questions. So with that, I'm going to introduce Ray Holmson. Ray, I hope I got your name right. You told me how to pronounce it last time. Perfect. So Ray is the Executive Director of Research Partnerships and Innovation at Red River College. Ray has led the establishment and growth of the Applied Research Enterprise at Red River College since 2004, when he was appointed Director of Applied Research and Commercialization, and in 2016 he took over his current role as the college's Executive Director of Partnerships and Innovation. During his tenure, a robust research enterprise has evolved, leading to some $85 million in capital investments for research infrastructure, annual research revenue of some $6 million, Canadian and international research partnerships, a consistent top 10 Canadian Research College ranking, the prestigious Natural Sciences and Engineering Research Council College Synergy Award, and the Colleges and Institutes Canada Gold Leadership Excellence Award. Ray holds a BSc and an MSc in Agricultural Engineering from University of Winnipeg and is an alumni of the Governor-General's Canadian Leadership Conference. And with that, I'll turn it over to Ray.
Thanks, Jess. You could have just said I'm a tractor guy. I started out designing tractors, so that's my first job. So I'm just have about 8 or 9 slides here. Just want to run through to give you a quick overview of what we've been doing at the college with respect to applied research in the electric battery transit bus and other vehicle technologies, and then we'll have the Q&A afterwards, I guess, with the rest of the panel. So we're the second largest institute, educational institute in Manitoba, a large institute of applied learning. We have multiple programs ranging from trades to technologies to a couple degrees in nursing as well as construction management, multiple campuses across the province. We've been at this now for about 15 years, and clean, green, and extreme technologies are one of our focus areas, and that's where the bus technology fits in. So just a couple of initiatives that we've had over the years. Back about 6 or 7 years ago, we were funded by the province to establish what we called EV Tech, or the Electric Vehicle Technology and Education Center, which had a mandate for applied research, education, and training. And then we were fortunate to get an NSERC Innovation Enhancement Grant. So this is a college-specific grant. It's a 5-year research grant to do a research program. And ours is focused on vehicle technology and energy, especially the use of renewables and sustainable energy. A lot of it's on-off-highway vehicle technology. You may or may not know, in Manitoba, we're fortunate to have 5 heavy vehicle OEMs. Bueller Versatile, who does the farm machinery tractors primarily. MacDon Industries, now owned by Linamar. They do harvesting equipment. Of course, New Flyer and Motor Coach Industries on the intra-city and intercity buses. And then Fort Garry Fire Trucks, which is Canada's largest fire truck manufacturer. So the sector is about $2 billion in sales a year, of which $1 billion are exports, and about 6,000 employees. So it's very important. And as you may or may not be aware, in the college community, we really try to react to economic development needs of the community. So that's one of the reasons we're into this sector as well. And we have several unique facilities on the vehicle technology side, which I will go into more later on. And here we are. So Motive Lab is unique in Western Canada. It's a driving climatic chamber with integrated 3-axle chassis dynamometer. It's rated for 1,000 horsepower, and here we go. The chamber is big enough for a bus. We've just finished commissioning on the chamber, so we can do -40 to +50 year-round under full load, which in our case is 650 horsepower continuous for 20 minutes. We're just finishing up some Department of Labor requirements, so we should be fully operational by the end of this month. We actually changed the braking system and chassis dynos to replace AC. We used AC motors to replace the braking system, so therefore we can also simulate slopes in the chamber. So this is unique in Western Canada. The nearest chamber is in Argonne National Labs in Chicago. With the changes we made to the dynamometer, we're able to actually generate power, and just to give you or electricity. And so just to give you a sense of the capacity of the chamber, which was designed by Lois Engineering out of Toronto. Under full load operating in extreme temperature conditions, we are about 20 to 25% of the entire load of the campus. So we're not going to be running during the day probably if we ever have that sort of temperature requirement. We'll be running more at night to avoid the peak loading. And we can actually power the building that we're in with the electricity we're generating, and the electricity we can't use, we have a 2 million BTU toaster, a resistor bank, which could, if it was a barbecue, you could cook 100,000 quarter pounders at the same time. So everything is big in the facility. It's about a $10.5 million investment by CFI Research Manitoba, the federal strategic infrastructure program, as well as the province and ourselves. You'll see this better when you get the presentation afterwards, but we've been involved with vehicle technology since about 04-05, going back to helping Motor Coach meet some US EPA emission requirements. Basically, we had a project was here's a bus, here's a transmission, here's an engine, make it all work together to meet USA EPA requirements, which we did within 6 months. So that was a good fortunate timing, but it worked out. We've done a lot of vehicle technology demonstrations over the years, both in the automotive and heavy vehicle side. So, for example, we did some winter testing with the prototype for the Olympics with a Ballard fuel cell, and the New Flyer bus. We worked on the ICE bus, which came up from San Diego. We did some winter testing on that, and then we were involved for many years on the electric battery bus. So the electric battery transit bus project was started out in 2011 as a 3-year, $3 million project with 5 partners, including Mitsubishi Heavy from Japan, the province, Manitoba Hydro, New Flyer, and ourselves. We're using lithium-ion batteries provided by Mitsubishi as part of the integration, and our role in that first phase was basically helping to put the battery packs back together because they had to be flown over for timing considerations for the project, and then we helped Manitoba Hydro a bit with the charging side of things. Then that was expanded with a proposal that New Flyer put forward to SDTC, and it became a 5-year, 5-bus, $10 million project. And 4 of those buses, which were considered pre-production models, actually went into fare service with the City of Winnipeg through Winnipeg Transit, and they're operated on Route 20, which just coincidentally was named Watt Street route. We didn't realize that when the route was picked, but it was one of the longest routes in the city. And if you're at the airport, you'll notice there's still the overhead chargers there at just to the west of the arrivals area. And this was, very good for the college as well as the partners that we worked with. So right now we have an NRCan-funded electric battery repurposing project. So we've received some used batteries that came from New Flyer, and we're going to be putting them into a level 3 DC fast charging system at the college. So that project is under development right now, and we'll be also working on developing curriculum program development for safe handling of these high voltage battery systems. Okay. Thank you.
Thanks, Ray. You even gave us a minute to spare. So we had some of the academic perspective. Now I'm going to welcome Pierre Vizek to the stage, and we'll probably share more of an operator and perspective, and also touch on the rider experience and the economy. Pierre has worked in the world of public transit for over 15 years, always passionate about the challenges of sustainable mobility. He is today an internationally recognized expert of Transdev Group in the field of electric and autonomous vehicles, where he's the general manager of maintenance and procurement. Pierre has held several strategic positions within Transdev, which has enabled the group to position itself today as a world leader in the operation of electric vehicles. Pierre.
All right, next is here. Sorry, guys. Good day. Just before I start, used to live in Australia for a while, so if you get some Australian words in my English, just raise your hand, because I discovered some of my colleagues don't understand me. What I want, first of all, I don't want to paraphrase a lot of stuff that I heard since I arrived at midday. Clearly, there is a very, very good view on the electromobility. So I'm going to try to give you a point of view as an operator that is currently operating a bit more than 750 electric buses, including this is a Europe operation where we have more than 120 buses in one operation. So it's kind of insight of how we've done that and what are the key messages. First thing first, what's the future of mobility? Because there is a point about that. It's we describe it with the acronym of PACE. Mobility in the future will be personalized. This is something everybody has in mind. We want our own mobility. Our passengers want to be considered as unique. It will be autonomous. That's the subject for tomorrow. I will be there. We'll be connected, and it will be electric. Connected in a way that, can you imagine putting an electric bus on the road and not having any app or any brand new system that fits this new electromobility? This is a slide I've made in 2009. At that time, I thought I was smart. I was not. What you have on the left was a conventional diesel CNG and the start of the hybrid that we start operating in 2009 in Europe. The idea was the same as everybody around the room. We knew that electricity was around the corner. So electricity was on the right. Not exactly on the right, by the way, because there is an electricity transit system called trolleybuses that exists for more than 120 years. That said, it has this downside. We all know about it, and not a lot of cities want to install this kind of trolley and overline charging system. So we knew that we were going to the new technology of battery buses. And in between, we had the idea, okay, I'm politically or technically, I want to reduce my greenhouse effect. I'm going to purchase some hybrid. And the trend here, you can see, was about the life of the hybrid. So let's say 15 to 20 years, as we hear the investment discussion. Reality is it has been way faster than that. And start of 2013, 2014, just before I left for Australia, we were already working deeply on electric buses, as you all know. And by the way, I would just want to say that in 2009, 2010, I was looking at America. We were starting to operate early 2010, Proterra bus in Foothill Transit, and I was so proud of my colleague over there. I wanted to see these buses that was able to charge at the end of the line. At that time, was not existing in Europe. So how many progress we've done in those years, that's incredible. What about the technology? You've seen a lot of pictures. I can say I've tried it all. Not everything is working well, and it has its good side and bad side. You know that, and there was a question about the weight. The question about overnight charging or opportunity charging, which has been discussed since this morning, is a very good question. The real point is that we need to think, as an operator, we need to think about the passenger perspective. My passenger wants to go to a point A to a point B without any change of bus because we run out of battery, right? So basically, and they want to have a bus. At the beginning of 2010, the first buses we experiment were about 42, 43 passengers for a full-length bus. At the same time, in Europe, we're about 85 to 90 passengers on conventional buses. So we got that rule, which is not valid anymore, of 1 to 4. For one diesel, you needed 2 buses to cover the range, and you needed 2 other buses to cover the passenger capacity, which means that for one diesel buses, you needed 4 electric buses, 4 driver. I mean, I don't do the math, but you have an idea. There is a discussion about slow charging, fast charging, combination of the both. The best idea is how many people do you need to carry from point A to point B today or tomorrow? Because this is a key point. If your buses are half empty, well, a battery bus overnight charging would be more than enough. But if your bus is full, and someone was talking about BRT, that's quite difficult to put an overnight charging bus, right? Because you will reduce by half the capacity, and there will be a problem of number of buses on the road. So that's a technology. Pantograph, I've seen picture of pantograph, I've seen picture of reverse pantograph, I've seen picture of induction. We tested induction, we tested plugins. Everything works. Has to be reliable now, and it is reliable more or less in the whole world. In Transdev, we try to find a way to design a network on electricity, and that's something I want to emphasize. Changing to electricity is not switching a diesel bus to an electric bus. I think everybody got that. But how do you do that? It's very complicated, and it has been said before, every city will have its own result because there is no recipe. The only recipe you have is that you need to put your must-have, your nice-to-have, and your, or if possible, I would like that, at the entry point. You put that on systems, and we've designed an e-bus living lab, which it's a kind of expert meeting where we group together PTA, we group together technical experts from the world, including scheduling people. Let's not forget that sometimes by scheduling you gain bus. If you gain bus in the bus flow, you gain money. It's part of the balance. And the idea was, let's say, do I want the same timetable tomorrow? Or do I want to adjust my timetable to suit electricity? We put that in the system, we'll calculate, and we obtain a result. Believe me, most of the time the first result is really bad. Really bad is twice the price of the existing, thrice the price of the existing. And then you adjust. You say, okay, I'm going to put an overnight charging there. I'm going to put a specific charging station here. More or less, I try to join with a railway, for example, because they already have electricity, which reduce the capex. And I try to do my best, but as you may know, for now, it's still more expensive than diesel. So that's not the question. The question is greenhouse effect and how we solve it. So it's an iterative process. It's a virtuous circle. And sometimes we failed on starting some stuff that was not perfect, but that's how we learn. No, we're very good. I mean, we are very good. We work hard to try to find the best solution and to convince our PTA on what is the best solution for them. Something about the batteries. There is what we call the C factor. It has nothing to do with a TV show. It's less fun than that. It's the time a battery takes to charge itself. So you all have a cell phone, right? I mean, you put a fast charger, either you have a Samsung, an iPhone, whatever, and then the system will tell you how many minutes it requires to charge. If your phone is empty and you plug in and the system say 1 hour, then you have a phone that accepts a 1C charge. it's not related to the charger. It's related to the battery and the charger. If you have a wonderful charger, but you don't have the battery accepting a fast charging, then you will have a problem. You see here the split, and for the one who have worked on the design network, on the electricity, you know all the split between power battery and energy battery, which is still valid of today, but is slightly going to change in the next years. Energy battery is a battery you charge overnight. You need time to charge them. Power batteries, the batteries that accept a fast charging, you see till 2C, 2.5C, that means that, let's say, you want to charge 30 kilowatt hour, it will require half, 20 minutes, 15 minutes, 10 minutes, even less than that. So the idea is, what will be the next technologies? There is a technological barrier now on how much energy you can put on a kilogram of battery. That is going to change over the next 10 years. Who knows what will be next? No one, except that you can read a lot of documents, technological documents, and you can expect what will be the future. And I will end up with this one. This is a calculation done on a scheduling system on where to put a fast charging system on a line. It's not really visible, but there is a red line. Well, don't go under the red line, because otherwise you can't go back to the depot. So the idea when you design your network is trying to be sure that you charge early enough, of course. That makes sense, right? But also that you come back to the depot. It's good to be at the terminal, but if you have to plug in the bus at the terminal and you have nothing to plug in, there will be a problem. Last but not least, in North America, may I say, as I work in many countries, grid stability. And a positive sign that has not been said, I just want to say, with electric buses, there is far less impact on neighborhood. So when we park far away from people, far away from houses or buses, because it's diesel, it's fuming, it's making noise, why not trying to park some of our buses very close to the terminal, very close to the city center? Why not? That reduces deadhead, that reduces pull-in, that reduces pull-out, that's cost saving. And I thank you very much.
Thanks, Pierre. It's great to get that international perspective. You all know him, you love him. Mike from Toronto Transit Commission. Mike, did you want to add anything with the presentation? From what you touched on earlier? You're good? Yeah, I got a new presentation. You got a new one? Sweet, okay. So come on up, Mike McCass, if you forgot. He's the Senior Manager of Vehicle Engineering at the Toronto Transit Commission.
Hello, everyone, again. I think this presentation will be a little more exciting than the last one, just because we actually have data now. We have buses in service, and I think everybody's really anxious to see numbers. I'll skip this slide because I went through this last time. Let's get right into the meat and potatoes. You know about the program. It's 3 different buses. The data I'm presenting to you today is really only focused on the new Flyer bus because that's all we have in service at this moment. Again, to reiterate, the Proterra should probably be going in service in early October. And the BYD is arriving in October, and hopefully we'll commission it and get it in service for sometime in November. So here's our experience to date. So like I said, we launched on June 3rd. First bus went to service. We commissioned the second bus shortly after that. That bus was dedicated to training operators. So I didn't want to share data for June because it was essentially for one bus. Mind you, July is only for 2 buses in service. However, we put some significant mileage in comparison to our first month. And just to take a moment and talk about our deployment strategy, we really picked 35 Jane as our first route. Based on the duty cycle, it's probably one of the most toughest duty cycles of all the routes we have out of our air road division. Has heavy loading, significant grades for it to climb up in the valley there by Eglinton and Jane. And it had a plethora of short-range routes, or we call swing routes, that are under 100 kilometers or under 85 kilometers that would give us the flexibility of deploying buses in the morning service and then again in the afternoon service. And so for the month of July, really what we did was we concentrated on AM and PM swings. We started off early in the month with only deploying it in the morning, and then we started deploying in the morning, bringing it back, charging in midday, even though it wasn't necessary. We want to get our operators in the routine of plugging in buses. Because that'll play into our overall vision in the future of having a system that'll actually charge the buses and control that, but you need to have them plugged into that network or that system. So anyways, focusing on AM and PM swings of 85 kilometers or less and weekdays only. We stayed away from weekends for the month of July. We accumulated total mileage between those two buses, and it was predominantly the first bus that accumulated most of this mileage, but 6,300 kilometers. I won't get into nitty-gritty of energy consumed, but the average energy consumption was 1.42 kilowatts, and that's actually really good. From Cutric's modeling and from a test route that we devised as part of our commissioning plan with loading the bus with 12,000 pounds and running it through a rigorous route that's duty cycles comparable to the Altoona test as far as door cycles and speeds between stops. Anyway, we were getting about 1.55 in those tests. Cutric, I think, modeling was around 1.52. So we're averaging 1.42. That's with the same operator or same two operators on the same two buses. Energy costs for the month of July, I was surprised. They were 19 cents per kilowatt. I was expecting less, and I called Toronto Hydro and said, hey, what the heck? Why so much money? And they explained to me that our global adjustment charges for that month were 13 cents. So it was a 13-cent premium. It's the highest month of the year so far. Typically, historically, it's been the summer months that you get hit with that GA charge. And typically, the rest of the months are averaging around 6 to 7 cents premium. So I expect those costs to come down as far as the overall average for the year. But anyway, our operating cost for the month was 27 cents per kilometer, which is higher than I would expect. I was hoping a little bit less than that. But in comparison to a hybrid, hybrids would be anywhere between 40 to 45 cents per kilometer. A clean diesel would be anywhere between 50 and 55, so it's pretty good. So just touching on the month of August. The month of August, we had 7 buses in service, all flyers. At that point, we now opened it up to multiple routes. We picked 13 routes where we selected different runs, again, AM, PM swings, but we also did regular runs that are under 200 kilometers. We have quite a few runs that run during the weekends that are around between 180 to 195 kilometers, which is that sweet spot where we're trying to keep on that 200 kilometer range, even though we feel we might have a little bit more, but right now let's just focus on 200 or less. So for the month of August, we put on 26,000 and change kilometers. The average energy consumption was 1.55. It's a lot higher than the first month. So I think part of this really is just different operators now that are driving the bus aren't really used to it, may not take advantage of regen. And there was a lot of testing in between here with commissioning chargers that we were using energy. And I didn't have time to really segregate that data to really focus on what energy was used to charge the buses. We're just not there yet. That takes time to crunch those numbers, and I just didn't have that kind of time. And I haven't gotten my electricity bill, but I'm anticipating that's going to be less than the month of July. So just some quick, I sliced and diced some of the data that we were getting. And again, this is for the same bus on the same route for the month of July, same operator for the most part. And again, some of these assumptions or some of these trends, I think they're pretty obvious. I think we all assume that these would be the trends. But again, when you look at the impact of temperature on energy consumption, yes, as the temperature increases, that HVAC comes on, has to work harder. Yeah, you're using more energy. And as you get into colder temps, yeah, there might be instances where you use some electric heat in the morning when that bus is pulling out, and you have days where you're around 12, 13 degrees. And so you start seeing that energy creep up on the left side of that chart. And I think as we start now moving into winter operations in a couple of months, I think we'll populate this chart and you'll see more data that will define that curve, which will have peaks on either end, where if you have extreme cold, you're going to use a lot of energy. If you have extreme heat, again, you'll be using a lot of energy, and you have a sweet spot somewhere in between in that 22, 23 degree range where you're not really using a lot of those HVAC systems and the bus runs very efficiently. Looking at speed, this is one that surprised me, but I've been surprised this even with hybrids. I think years ago, I was always told that, hey, hybrids are perfect for stop-and-go service, and the lower the operating speed, the more efficient that bus is. In actuality, we're seeing the opposite. It seems that higher speeds, we're getting better efficiency. I think part of it is just maybe those higher speeds, you get more regenerative braking, and therefore you're recovering some of that energy. And I think the same thing applies for hybrids. We are seeing this on our hybrid fleet. I've talked to other agencies, Boston in particular, who is seeing the same trend. So it kind of throws out what we thought was, applying this to low-speed service. Again, the correlation, a lot of this, it's just a lot of data. Correlation factors aren't very good at the moment. As we get more data and more buses, hopefully those numbers will improve. But I think the trends are pretty reasonable. Maybe the numbers themselves, you probably couldn't predict the value from this data just yet, but I think the trends make sense. And so when you look at time of day, you get these peaks. Typically in the afternoon, we see more energy usage in the afternoon. I think this is really a combination of various factors. Loading in particular, you get peak loading in the afternoon, and you tend to carry more passengers in afternoon service than morning service. Temperatures in the summertime are hotter, so again, your HVAC's working harder. So again, just trends that we're seeing, just observations. that might be of interest. But the key thing here is there's a lot of factors that go into the energy. And when people talk, well, what's the range of your bus? Nobody knows. You have to try it. Again, it's what I said earlier in the previous panel. You got to get a bus and try it for yourself and see how it works in your service and what kind of trends you see, because there's so many factors that go into understanding what the range is and temperatures and duty cycles and loading, and the list goes on. So there was questions about electric heat. We actually did an experiment where we forced electric heat on for a day, back-to-back days. So on a typical day on 35G run, we're running about 1.45 kilowatts per kilometer. The traction motor is the bulk of that energy being used, which makes sense. And then you have your high voltage accessories, which was your HVAC, which was about 23%. And these are days where we're hovering in the high 20s to low 30s in temperature in degrees Celsius. So with that same bus, the following day with your heat on, where we forced it on, our consumption doubled. So this is no different than what we are hearing from properties in Europe. In the US, not so much, because the deployments are concentrated in the southern states where they don't really have issues with heat, or they have it only a couple days of the year. With us, it's a problem. And, like, I'll be the first one to confess, we equipped all our buses with diesel-fired heaters. I mean, it's a necessity. At this point, with the technology and with our approach for a depot-charged bus, long range, you have no choice but put diesel-fired heaters. I think in the long term, we're going to look at changing set points for our HVAC system. We've used the same set points in our bus spec for years and years and years. I'm not sure if anybody's actually tried pushing the limits to see what our customers would tolerate as far as cold temperatures and hot temperatures on the bus. It's something that we're willing to try and see if we can squeeze out some more efficiency from these buses. But in the meantime, we protected ourselves. We didn't want to take any risks. So we have diesel-fired heaters, and it's much easier down the road if we find a solution to this to turn them off than to have to integrate them and design them into the bus after the fact. Just another lesson learned for us. Of course, everybody wants to maximize range. We want these buses to stay out there the longest and get the most range possible. One of the things that we were playing with was the idea of, well, we know that battery manufacturers won't let you charge to 100% or deplete to zero, and you're somewhere in between in that 10 to 20% or 10 upper, 10 lower. So in the case of our bus, we were told that the maximum we could go is about 94%. But at 94%, you don't have any regen because you have no space in that battery to take a charge. So what does that mean for us? Well, for us, really, by the time regen kicks in at 90%, you're looking at about 11 kilometers or 26 minutes of service that you have no regenerative braking. Well, what that means for us, we had two instances where we had smoking brakes because the operator took the bus, he took the bus into service, deadheaded it. The deadhead distance was less than 11 kilometers. He gets passengers come on board, he starts going on the brakes, and they overheat, smoking. He calls it in, and we realized, okay, we can't do this. We got to forfeit those 11 kilometers, and we want that bus to leave the depot from the minute it leaves with full regenerative braking, so no difference to the operator. So that's a lesson learned. I've talked to other agencies. They aren't aware of this. They're starting to look at it now. With us, it's maybe the route that we were on where it gets heavy loading right from the first stop, where we experienced this in two occasions. We had these buses running for several days where this never happened, and all of a sudden we had one day out of the blue where this happened. And from looking at, we have all our buses equipped with telematics, started looking at some data, and we realized, oh, there's no regen coming on. Okay, we got to correct this. Lessons learned. Who plugs in the charger? That was a huge question. People were asking, like, well, who's going to plug in the charger? We have to pay people more money for it. So we brought all our stakeholders to the table and tried to figure what's the strategy here? What are we going to do? And really what our recommendation from our HR department was everybody plugs in the bus. Just train everybody from day one. If you're driving that bus and you're parking it next to a charger, the expectation is you plug it in. And you're just plugging it in. You're not fueling the bus. You're not charging the bus. You're plugging it in. And it's worked out really well. Everybody's plugging the bus. Yeah, there's been some mistakes with following the sequence to initiate a charge event, and we're working through that with training. But for the most part, everybody's plugging it in from day one, and that's going to help us in the long term when we introduce our smart charging system, where now you plug in a bus, the charging event won't start for a couple hours because it's programmed, but at least the bus is ready. It's connected to the grid. And lastly, I touched on this before, but employee engagement is really important. I think the success of our projects really a testament to how much effort we put in employee engagement. We were communicating with our employees from day one with posters of, hey, here's what's coming. Here are the benefits where e-buses are coming. We did a demonstration week in April of last year where we invited all 3 OEMs to bring a demo bus, and we took that bus and took it to all of our 7 divisions and allowed people, operators, maintainers, come on board, ask questions to the OEM, ask questions to the TTC e-bus team on the project and what we're going to do, what's the expectations. And schedule, and things of that nature. And also what we did with the 3 divisions that are actually going to accept the buses, we actually got the buses put on hoists, got technicians to go underneath, look at the underbody of the bus, ask technical questions to representatives from the 3 OEMs. And I think that really helped. And what we did is we collected information. What are the concerns? What do people want to see? What are they afraid of? So that we can kind of control those messages and try to satisfy and reassure them that everything's going to be okay. Other things that we did, we shared drawings from consoles when we were working with OEMs and trying to work through the design of the consoles and where we want switches and the placement of them. We asked our drivers, we talked to our joint health safety committees and said, here are the drawings. What do you think? What would you like to see? Where do you want to see certain switches? And I think things that give us clout and respect in our company as far as, okay, they're willing to work with us. This isn't just that we're shoving this technology down their throat, but we're actually trying to work together as a team and ensure the success of the project. And then lastly, I talked about it before, but tabletop exercise, bring in all the stakeholders, run through different SOPs, different processes you do at your various companies, and think about what's the impact of introducing an electric bus? What's a day in the life of an electric bus at your operation like? What are the impacts? Who needs to be notified? What are the SOPs that need to be updated? What kind of help do you need from third-party experts, from OEMs, things of that nature? And that's all I have.
Thank you, Mike. It's great to hear some real-time data and really what's happening on the ground. I'm sure the audience is pretty stoked on what you're sharing there. So we're going to move into questions. I have a few that I'm going to pose, and I'm also going to put forward that question about impacts to city infrastructure, roads. I'll send that to you, Mike, at the end. So if there's questions that are coming to mind for you, I encourage you to line up, and I'll let you know if we're out of time. I'll let you sit down so you're not standing. But maybe you want to stretch your legs. All right, so first question. I'd like each of you to describe an example of when the electrified system performed exactly or better than you had expected. So in Winnipeg, with the pilot program that was going on, Ray, Pierre, you have so much experience internationally. I'm sure you have many examples. And Mike, in the past few months of what's happening with TTC, and from what you just shared, it sounds like you probably have can expand on that. And then, so in addition to sharing when the system performed exactly or better than you expected, and what system conditions were in place that led to that, on the flip, share with us when the system did not perform as you had expected. Ray, I'll start with you.
Is it on?
Try again.
This one's working.
Can everyone, Ray, sing us a song. Can we hear you?
I can't sing. You don't want.
No.
It's rugby song.
Rugby song. Yeah, the volume isn't working. It doesn't seem.
Can you hear me now? Okay.
No. Is it?
Can you hear? Yeah, there we go. Okay, all right. So now the technology's working. As I mentioned, there are 2 phases in the bus project that we had. The phase 1 was the first bus, which was a prototype, and then phase 2 was the 4 pre-production versions. As far as I was aware, generally the technology worked well as expected. No significant glitches. The only one I was really aware of was once when we were still using the charger when it was on the prototype when the bus was located, the charging station was located at Manitoba Hydro. We disconnected the charging system while the communication systems was upgrading, and it killed the software, right? So basically we had to reprogram it, and that problem was fixed. So that was the only one I was really aware of. When we were doing that we did monitor the batteries for 3 years, and we developed a data analytics tool to do that, to help monitor the reliability and performance of the battery bus during the wintertime, especially, and again, that helped us quite a bit. It was also a tool for predictive maintenance purposes. And as far as the 4 pre-production versions, the only feedback I've heard was there was a little bit of initial apprehension by the drivers or operators about operating electric bus, but after a while they got used to it, and some of the more seasoned operators were actually requesting to drive the electric buses. There was a little bit of range anxiety, I guess, at first, and so people were tended to overcharge the bus. And when we had the charging system at the airport for while the bus was at the end of the run, I think it was 6 minutes or 7 minutes of charging would give it 2 hours of run time, and that really wasn't an issue. But people got past that. And actually, that's probably not a surprise when we started working with Mitsubishi Heavy back in 2011. In Tokyo, they had one, and then so on the automotive side, they had one rapid charging system for their vehicles, and even their own staff were hesitant. But as soon as they put in 2 chargers in Tokyo, the range anxiety went away.
Okay. So perfect. So yeah, I'll just say we're hearing some around software glitches, apprehension from drivers, and of course some learning curves around the charging. Pierre, what do you have to add for us?
A good experience, I think, is it's coming from Europe on massive deployment is the Amsterdam contract. It's because we learn. It was all about what you just said. It was all about the driver's preparation for the handover from diesel to electric with a brand new network. It works when on day one there is nothing to say. And so that's a good thing because it was massive. I mean, when you put on the road 100 buses, it's not as a trial where you have a backup plan. When you have 5 buses on an operation electric, you always have a backup plan. It will be your old diesel 18-year-old, but you can deliver the service, right? I mean, when you have 120, you do not have any backup plan. It's like a light rail. So you need to deliver. And I think that's a very good experience. I could present during 3 hours how we did that, and it was full of, Anne-Marie said it takes time. I mean, you have to be ready sometimes to delay a little bit because we don't know everything and it's so complicated, but we know the way to do it. We know what we have to explain. We know how to have the driver on board. Driver has an impact on energy consumption by more than 40%. So good driver, bad driver, some driver will never make it to the last terminal if they're not trained properly. It's way more important than with diesel. A bad one. I can give you 2. I can give you I can't name the city, I'm sorry guys, but the first one is when you when you sign a contract and the buses are never delivered, and you have everybody ready for the inaugural 1 week before, yeah, they will come, and you do not have the bus. You have the charging station, you have the software that manages charging station, smart charging, and you never have the bus. That's a kind of a problem, and that delays have some kind of a costs. Second one is that's coming from down under. That's it's not a negative test because I think we learned from that. You said it from the heat. I can tell you that more than 40 degrees, it's not working. It's not working because you have to cool the battery first, and then you have to cool the passenger second, and then your range is about 15 kilometers. And so basically you try to charge 3 hours, you do 15 kilometers, you charge 3 hours. So there is a lot to develop about that. We learn by trying, That's for me.
That's great, thank you.
Oh, sorry, yeah. So for the good, I think I've answered some of those questions in my presentation, but one is really the energy efficiency that we've seen from our first deployments exceeded our expectations, both from modeling and also from our actual commissioning testing that we did in preparation for our initial launch. As far as the bad, I mean, I talked about the challenges that we've had with dispatching buses early on and making sure that they're charged. You're now asking, garage staff, 4 persons now to be monitoring, charging, and really paying attention to the dispatching of buses, which is something that, it's not really part of their job description, I guess, and they have to kind of learn and get used to it because it will be, I guess, moving forward. So that's unique, and I think the other challenge we've had really was on the charging side with commissioning our chargers. Again, it was a challenge to have 2 parallel projects as far as the bus deliveries and having the infrastructure ready in time so that when the bus arrives, you actually have a means of charging it. I mean, that would look really bad if you get a bus and you can't charge it. So luckily, we didn't run into those issues per se, but as far as commissioning chargers, we did run into challenges because when we commissioned the chargers, we didn't use our buses because they weren't available yet. So we're using demo buses, and sometimes demo buses aren't really equivalent to the bus you're receiving. And so we've experienced that from both vendors that we've received already. We've had some minor challenges, but I will say that both vendors did step up to the table, worked with us, and worked hard and relentlessly until the issues were resolved. And so I thank them for that. But yeah, it's something to look out for with the charging as far as commissioning it. It can be challenging.
So a big piece of that, of course, is make sure your buses show up on time and make sure your infrastructure is also there ready to support them. So I have a couple more questions. If there are questions from any of you, please line up, because otherwise I'll just keep going. So my next question, if I had a time machine and you could only use it for this purpose, nothing else, and it will enable you to go back and start over with your deployment or with your program or your project, is there anything that you would do differently, or you'd go back with some hindsight? Ray, you can start us off.
I think the first thing we could look at is just being more aware of infrastructure requirements. I'm talking with respect to the charging system itself. We had, as part of the phase 2 project, we had to relocate the charger to the airport. So then, how do we get the land? The cost of doing modifying existing infrastructure, getting power there, the curb cuts, that sort of thing. And there's nothing anybody could have done about this, but our original supplier chose to leave the business, right? So then we had to change, or in the future going forward, we'd have to find another supplier.
Okay. So you just had to really think on your toes there, and the decision was to move
it was okay for the project we had, but going forward, we'd have to find
Okay, so we'll go back in time and we'll make sure they don't leave.
Yeah.
Okay, got it.
And I think another thing that came out of it was I believe the properties are expecting now that the bus manufacturer also is involved with the charging integration into the infrastructure.
Great.
Clearly, nothing. I mean, I mentioned bus not delivered, but if you choose the right provider right now, this is not an issue. I think one thing I would do differently 10 years ago, 5 years ago, is working more on smart charging. I think 5 years ago we were ready to work with an electricity provider on smart charging, so to avoid peaks, to avoid a highly and too heavy dimensioning system. We wanted to charge at maximum a lot of buses instead of thinking about what the bus will do next day. And you do not need to have all the buses at 100%. And that has a massive impact on the balance, on the economical balance. So I would probably focus, if I could travel back, I would probably focus on that. You talk, Ray, about the ground. It's easy to purchase a bus. It's way more complicated to work with 10 organizations when you want to put a fast charging station somewhere in the city. You have the owner of everything under the road. So that's quite complicated. But clearly, smart charging is a key point.
Great.
For me, it's time and resources. Time, which I couldn't really control, even if I could go back in time and change that, because with us, our timeline was really driven by the funding opportunity and really a funding deadline. But resources, I think in the last panel, Dom from TransLink brought up that he worked with a small team and they thought they could do it with a small team, and how Edmonton has an army of people that are working on their program. It was the same at TTC. I mean, we thought that we could do it with the staff we had. We did hire people, but we didn't have the people in the project early enough when we hired them, and then the time to build up that expertise. So if we could get more resources, I think it would have made our lives a lot easier, where we were scrambling, working a lot of hours, off shifts, just trying to maintain that schedule and ensure like a successful deployment.
Okay. So a time machine and maybe a cloning device. I think that would be really helpful for the TTC. So next question I have, and then I'm gonna change gears here. So some of the previous panelists touched on this a little bit in terms of, more and more city councils across Canada are declaring climate emergencies, and they're adopting really strict climate action plans, of which transportation is often a large part of that, because transportation is usually the biggest source of carbon pollution in cities. Oftentimes councillors want it like that, and they perhaps, as was touched on earlier, don't understand, because they're just like everyone else. They need to be educated, and they need to have the opportunity to ask questions and receive answers, because we know that with electrification, an overhaul of our streets and our depots is required. So I'm curious for each of you, is there anything else besides what's been touched on in terms of your experience with council and of them wanting the electrification but without the disruption? Do they understand the system overhaul that's needed? Has there been any techniques that have worked for you working with council? Is there anything that any of you would like to add around that?
I can start. So in our case, we didn't actually deal with council on this. This initial project came out of a provincial initiative, because they'd signed an MOU with Mitsubishi Heavy back in 2010 on various areas to work in, of which electrification of transportation was one. But what we did do after the end of the project, of the SDTC project, we had a a working group that was put together that included representatives from the city, from transit, from New Flyer, Manitoba Hydro, and ourselves, and developed a plan for electrification of transit, which is actually available on our website. And some of the considerations that we had, which I presume were reflecting, transits and the city's needs, which are probably driven by council, would be things like, the routing was a significant factor, like the route itself, where would we put the charging systems? It was important to integrate with the existing diesel fleet, which I think there's about 550 buses right now in the city, and I believe, and I'm just going by memory now, and transit could confirm, but I think during rush hour, where like 500 of them are on the road, right? And then my sense was if we could have done charging on the go versus having charging systems, we might, might have accelerated that uptake on them. We actually did start a follow-on project with the support of New Flyer and NSERC to look at actually on-the-go charging. It was going to be, and there was Western diversification support in there as well through an initiative that they had, and they had University of Manitoba involved as well. It was basically a Chevy Volt on steroids, right? So phase 1 was proof of concept, phase 2 was a prototype, phase 3 would have been testing. And we made it to the end of phase 1 because we were going to use a gasoline-powered, carb-compliant engine to do the charging of the battery packs. And then the supplier decided to not pursue that business. So the project stopped there.
All right, so a little bit of a mixture of the choice of infrastructure used for charging, but also the importance of convening with working groups, which works whether you're dealing with city council or provincial, just being able to bring together the stakeholders to share the messages and work through any questions or issues. Pierre, anything to add from the political perspective?
Yeah, I think, I wouldn't say everything is about the money, but when we talk about electricity, we talk about costs. We all have in mind the climate change. We have that, but it has been said before, right? I mean, when you go to the bottom line, and councils, politicians, they have that in mind. I think one of the things we need to think collectively is how do we induct patronage, more passenger on buses because we are green? What will be the effect for everyone taking care of this planet and people taking cars will say, oh, because the transit is going green, I'm going to take the bus. Of course, you need to have the bus. You need to have the passenger capacity and not only 20 or 30 or 40 passengers per bus. So it has to be taken into account in the economical balance because unless you're a free operator, people pay to take your bus. If you put more people on the bus because you're green, then it's not only changing from diesel to electric, there is something else here. And last thing is talking about the global impact. If you talk to a councillor, if you talk to a minister, people are also in charge of health. It was said by Anne-Marie before. There is a study done in New York about the cost of changing all the buses in New York City to electric. It has been done, I think, in 2016. You can find that in the internet. It's controversial because it says it paid by himself by reducing the healthcare cost. But when they say healthcare cost, of course it's over 30 years because it's lumps issue. You don't cure in 5 days from something you suffer. But they say it will, it's free. Doing electric transport even now is free. The problem is who will take the risks. Mm-hmm. So you need to, in my point of view, to convince people and to be better, you need to lock what you know. And there is some stuff we don't know, but some stuff we know, and to take into account a wider scope that only I will switch my diesel bus to an electric one. Otherwise, we won't convince and we won't be good at that.
Okay, great.
So I think councillors, again, they're busy. They have many different things that they have to deal with. So I don't expect them to be experts by any means on electric buses and deployment strategies. But I think maybe we need to do a better job educating them. And to me, I see the challenge really here is brownfield construction versus greenfield construction. It's completely different. And people all the time say, well, in Asia, they got 100,000 buses running. Well, yeah, but those are all greenfield construction, that purposely built facilities that aren't constrained by our parking nose to tail in a barn, have brand new routes that are developed around that technology, where we're trying to integrate to something that already exists, where we don't have real estate space in all locations. We might have a transformer station that's a kilometer away or maybe 15 kilometers away. There's lots of challenges here, and what that means time and money. And councillors don't necessarily understand that because they're looking at ribbon cutting events, and patting themselves on the back saying, hey, we beat out that other city, we have a bigger fleet than they do, but the timing and the expectation times aren't realistic. And so it's just a matter of us educating them so they understand really what are the challenges here with adopting this technology and what are the risks associated with it. It's not all about just that day that we cut the ribbon and say, here, buses going into service. There's a lot of work that goes into getting to that day that they don't really understand.
I used to work in municipal government, so I can echo some of what you're saying there. I'm going to remove my question I had. I'm going to ask the question around the weight of the battery, and then there was an individual over there who I think still may have a question, but Mike and then maybe Pierre, you can add to this. The question earlier was talking about the weight of electric buses because of the batteries. Curious if the TTC did any projecting on the wear and tear, or what the expected road impacts will be, or any commentary around that?
The short answer is no. I think we're within the limits in our jurisdiction. I think there's different limits depending on the province. I know in the province of Ontario, we're within those limits. I will say that just from driving, and I grew up in Toronto, you can definitely see that there is wear and tear on the road just from our existing fleet. I'm not sure if an extra 2,000 pounds will make that much of a difference. Hard to say. To me, it's not so much the weight of the bus on the roads, but rather the weight of the bus with the batteries and what that does to passenger counts and passenger loading, which is something that the industry needs to look at and look for means, whether it be through battery density improvements or then axle upgrades to ensure that we're within those axle limits.
Great. Pierre?
For those who were in Quebec last winter, we were obliged to stop half of our hybrid buses because regulation limit during the, I don't know how you call that, de-icing period in May or April. With 10 passengers on board, we were overweight. And Montreal had to stop during one day till the minister changed the law. Nobody noticed that for the last 20 years, by the way. So I think we are not heavier with electrics than hybrid. Hybrid was a combination of the worst because you have all the diesel, very heavy, and all the electric. I agree with you. I think it's also what is the impact of the buses on the road versus the trucks? Really, buses will have that impact versus all the delivery truck of the big or small trucks. So I think it's marginal. Still, there is a weight limit that nobody will cross. So under this limit, roads are supposed to last a certain period of time. Coming from Quebec and Montreal, I won't tell about the road condition here.
Great.
It's famous worldwide.
Was that question still out there? I think it is. Thank you.
For Mike specifically, how did you gather the data for your presentation?
So all our buses are equipped with a Versity telematics system. So we have real-time monitoring of our buses. We can download all the information from the CAN bus as far as energy consumption, all the various systems, faults on board, charging events. And we do know that all three buses will be equipped with their own telematics from the OEM. So in the case for our Flyer bus, New Flyer also put their Connect system. So they're also in the background monitoring and sending us regular reports on the bus performance, which we then compare to ours. And for the most part, they do correlate, which is good. But yeah, we basically equipped all three buses with a third-party telematics system so that when we're reporting data, it's all from the same type of system, same source, so no one can dispute it and say that anybody's been fudging numbers or inflating numbers or editing.
Great. Go right ahead.
Just one question regarding the difference of charging types, the plug-in charger versus the overhead charger. I have the impression that the plug-in chargers must be a lot less capital cost than the overhead chargers. My understanding is that Electrify America, the Volkswagen recent capitalized company, has just installed 2,000 fast chargers at less than $200,000 US per site. And I'm just wondering, maybe a company with that expertise doing such high volume installations around the US may have some value to add as a consortium partner to bring the costs of charger installations down, because the utilities and the transit agencies, neither of them have a volume approach to charger installation. So just a thought whether 200,000 US per charger installation is way below where you guys are seeing the numbers.
No, the chargers we procured were less than 200,000. So I don't know as far as Volkswagen if that's truly a deal, but I do agree that scale of economies. I think that if we buy more chargers, we can definitely drive down the price. And I want to know how many chargers we need to buy so it's free. But I'm not sure we'll ever get to that point, but definitely if we're buying more charges, the price should go down.
Pierre, you
Well,
chuckled.
I mean, from my memory, there is a limitation on the amount of power you can transfer by a plug-in that you do not have on a reverse or pantograph. So we usually use this technology for very, very fast charge of very high density of energy. I think the cost of a charger is not really the pantograph itself, it's also technology behind that to convert the current and to prepare the energy to be transferred. It's not the technology of pantograph. I mean, how many trains have pantograph in the world? I mean, it's very reliable and not, I wouldn't say cheap, but it's not very expensive. So the whole lot is about the charger itself and the cabinet in which it sits, and whatever technology you choose, that's where the money sits.
I've got another question, and then if someone does, actually you can go right ahead. More exciting to hear from the audience. It could be you next.
All right. So no, we know that we have done the modeling for at least for TTC as part of Cutric, but I want to know what is the different amount of the kilowatt hour of the battery usage when the ridership is at the highest and when it is lowest. So what's the difference? Have you guys calculated that? Have you seen that? And what is in the moderate scenario, maybe, which is the regular average usage?
Sure. So the average energy consumption I had in my presentation, I recall, I think it was 1.55 for the month of August, and I think that's slightly inflated based on activities that we were doing with commissioning buses and whatnot. It's hard to say. The peaks would be in one of the slides too, where I have the energy consumption over time of day, where you see peaks in the afternoon. I don't know what that would have been like, but if I had to guess, it'd probably be over 2 kilowatts per kilometer, I would think, at those peak stages. But those instances where we're crush loading buses are typically only for like a 10, 15-minute interval. So it's for the period that the bus is in service, it's actually a very short period of time where you see those really high loadings from passengers.
I mean, interesting question, because we never thought about that when we were running in diesel. Nobody asked me beginning of the 20,000, how much do you use when you're full loaded versus half loaded? Because we had an average, let's say 50 liter per 100. For my figures, without trying to have not the impact of the climate, because morning, afternoon in August, but you will have that very quick now in mid-season, it's about, let's say, 20%. But we are not full all the time in transit. You're full during, let's say, an hour and a half, and then you're a bit less full, and then you're a bit empty, depending on your schedule. So that's why we work in average. We just want to reach the end, but yeah, about 20%, which is roughly, I say roughly the same as diesel.
Okay, so last question I'm just going to pose. Mike, you touched on this a bit earlier in terms of talking about the design of an electric bus. So often feedback that is coming in from drivers is that it provides for a smoother ride and it's quieter. Wondering if you're, for all of you, Ray, I'll start with you actually from the pilot. Haven't been many questions to you, I don't want you to feel left out. So in terms of what kind of feedback was there? Is there anything that was shared with OEMs, or is there anything that could be shared for Pierre and Mike in terms of improving that aesthetic swank factor?
I don't think we can overlook the heating cooling requirements versus the attractive energy requirements. And I think we found, at least with a prototype, we needed, like for every unit of energy to move the bus, we needed 5 at temperature extremes to heat it or cool it.
Okay.
Right, because we do have an extreme climate here.
Yep.
We're actually colder than Mars in the wintertime.
Good to know.
And I guess the other, I'll have a few ideas here, but the other one, 2 others I'll just quickly mention. So on the auxiliary heating, we're actually talking with a European company with a thermal battery technology, which uses phase change to maybe do that initial cabin heating before the bus goes out on the road. So we're looking at that. The other thing I mentioned during my presentation was about the repurposing of batteries after they've done their useful life in the bus, because there will also be a related disposal issue down the road, right?
Okay, great.
Feedback on electric buses from the driver's point of view, some of them are too quiet, so they hear too much the passengers. That was not expected. Everybody wants quiet bus, but you know what? No, you don't really want. Sometimes you prefer to hear a loud, very rough noise of an engine that covers the noise of everybody's talking on the bus. So that's the funny one. Yeah, indeed. And sometimes the air conditioning is very noisy. I mean, you hear some stuff you never heard before. That's the feedback from the driver. My point is, I think OEM in the future need to be a bit more innovative, because thanks to electricity, they do not have the same constraints in the way the bus is built. They have way more margin on the way to reorganize how passenger flow is into a bus, because you do not have those constraints we had for the last 50 years. So that will be that is already, when I discuss with them, some things they need to think about it.
Okay. Last words from Mike.
So the engineer in me thinks that now that you have electric buses and electric propulsion systems, you got rid of that diesel engine, you got rid of the transmission, there's lots of space in that rear of the bus. And with in-wheel traction motors, to me, it brings up opportunities to have a fully low-floor bus from front to rear instead of having that upper deck. And I think that would be something that the public would like. And possibly configurations for door placements, exit doors. The operator in me, although I'm not an operator, I think they all want more visibility. So smaller, narrower A-pillars and more glass, more visibility. And for passengers, what I see, we, and 2 years ago, started equipping our buses with USB ports. Something so simple, but it's unbelievable how people love USB ports, and all they talk about is how great it is. And so to me, it's, sometimes it's just those quick wins, easy wins. And so there's got to be something else we could look at as far as maybe real-time GPS tracking so that the passengers know where they are, or we have infotainment screens on our buses now. Leverage those screens so we can maybe advertise how much GHG we avoided in your trip. So if you get on the bus, you could see, okay, well, I was on the bus for 5 minutes and I avoided 15 kilograms of CO2. Things of that nature, I think, to keep the public aware and, I guess, excited about the new technology.
I think that's awesome in terms of the education piece, a bit of a living lab with them. But then also the USB ports keep people distracted. That could help Pierre with, drivers not wanting to hear the conversations that are happening. Though that could end to more FaceTime conversations, so I'm not sure. Okay, so I believe I'm out of time. Yes, I am. Okay, so thank you to Ray, Pierre, and Mike for sharing your experiences and your lessons learned, and I hope all of you enjoyed that. Thank you.
Perfect. Okay, we're going to move to a 15-minute health break, and when we get back from the break, we will have our final keynote speech of the day, and then we'll be having a reception upstairs with some comments from the Deputy Mayor, a number of federal candidates, and some local councillors as well. So see you back here in 15.
Got it. All right, folks, so we're going to get started with the last speaker of the day, and I welcome you to take a seat. And with that, I'm going to signal to my colleague John Walsh if he wants to make his way up here to the front just as we get started. So we've heard a lot today about technology innovation, social innovation, and financial innovation, as well as political economic innovation. All of these levels of interdisciplinary innovation have to occur in order to transition this country from a petroleum-based transportation network to an electron-based, clean, green, smarter, and better transportation network for Canadians across the country. And with the dialogue that we've had today, I think we've run the entire gamut, from the technology on the bus to the charger to the storage systems to the electricity grid, and we've referenced a few times about just how expensive all of this stuff can be, combined with the unknowns around operations and maintenance. And so we've turned to our colleagues from Proterra over the last year or so to really ask them about their innovative financial solutions to help not just Cutric and our members, but also Canadian transit in general and cities think about innovative financial solutions. So with that, I'd like to welcome my colleague John Walsh back to the stage, Senior VP of Sales at Proterra, speaking about finding the money, Proterra's financial innovation to spur North American electric bus innovation. Welcome, John.
Okay, is this one different?
Big button. Yes,
big button. All right. Okay, good afternoon. I'm the only thing standing between you and happy hour, so I'm gonna go quickly here, but thanks for the introduction. I have with me from Proterra our Director of Business Development, Alan Weston Sco, and he's gonna maybe help me out with some questions if you guys have them as we go through this. He does handle all the financing for us, so let's go pretty quickly here. I do want to point out one thing on my little bio here. You see this little thing that says MV1? Maybe some of you remember the little car called MV1, the mobility car, wheelchair car. So in my world, the word mobility was transporting, people with disabilities. And now mobility means something completely different, in our new world. So when I put that slide together, I thought everyone uses mobility as something different. So I thought I may be talking to a different audience this afternoon, so I'm going to skip through what you've already seen and get right to the finance part of this. So when we come and sit down with a transit authority, we go through a process with you. We're not in there to sell you buses and chargers. We're there to help you from the beginning of the process to the end of the process. So we determine that by 4 major categories. Determining fleet charging needs. We talked about that a lot today. You should do that first with the utility. Evaluate electricity plan options. Forecast capital operating costs. That's what we're really going to focus on, that leg in this session for the next 20 minutes, and then creating fleet charge master plan. So we come in and we do route analysis, we do block plans, we figure out your efficiencies and fleet replacement. So that's what we do when we're determining what your charging needs are. So it could be en-route charging, it could be in-depot. I've heard so many different opinions in what we should do. Every property is different. So we want to come in, sit down with you, and figure out what that is. Then we go and we figure out, what do you have for electricity coming into your depot, into your property? What are the load curves? What's the charge plan? What are the options that you have? What's it look like with your utility in your area? Okay? Grid tariffs, storage solar, and resiliency. But this is what we really want to get to today. Anne-Marie, she used the word, we're going to talk about the F word, funding. Because that's really the hard part right now, is where does the money come from and how. I'm not the government. I don't have a bucket of money over here. So we have to find other ways to help you finance this technology. So we have infra design, capital estimate, funding optimization, sources, and design to fund. And I'm going to skip past this last part just so we can get to the 4 different ways that we can help you finance a bus, finance charging, and finance batteries. So the first thing you can do, and these dollars are in Canadian dollars, so if they're a little off, again, everybody's configuration is a little different. You know, Toronto's bus may be a little bit more expensive than Edmonton's. So in this particular case, 100% cash purchase means you get the money from the government and you write the check. Okay, that's the easy one, right? The next way to do it is battery leasing, and that's something that a lot of properties, I think, Alan, you said we're up to over 100 buses right now. We're leasing the batteries on those buses, so that customer never has to worry about the life of the batteries. We replace them at midlife. We take care of everything, and they make one payment. We'll get to that in just a second. So the 100% cash purchase, what we wanted to show you on this slide, and I went the wrong way, is the cost of a diesel bus in Canada, roughly $650,000. So the delta between an electric bus in Canada and a diesel bus is about $340,000. But we really want to point you to the bottom of the slide on the right. The cost, and I was glad to see some other slides today that weren't mine that talked about fuel cost and operating costs, maintenance costs on diesel buses or fossil fuel buses and what they were. So our numbers are pretty close to what has already been presented. But if you look at the cost of electricity, and in this model, we're using 10 cents a kilowatt, so just bear with us on that. It could be different with your situation. And we're using $3.25 per gallon on diesel fuel. That's American. That's U.S. So the cost savings you would have just in maintenance and fuel savings is $46,000. So you're really going to have to pay attention to that number. And a lot of this is detail, and Cutric is going to provide you with these slides. But let me just walk you through the math real quick. So if we get to $46,900, that's your savings over 12 years, which is a typical life of a bus. Some of you go 18 years, so you can see the difference in the two numbers. But we're doing the math a little bit differently when we look at the TCO. So what we're doing is we're taking your savings in fuel and maintenance, and we're multiplying it out, but we're showing the upfront cost of what an electric bus delta is because it's more expensive. So we can't really say, gee, you're going to save $562,000. You paid more for the bus up front. So it's really $220,000. And I've seen some different numbers, a way of doing the math, but this is honestly the right way to do it, okay? Battery lease. This is something that we launched in the spring. We partnered with a company called Mitsui to fund our battery lease program. Many of you transit authorities are currently on the programs leasing tires. It's the same concept. You lease the tires, you lease the batteries. You have no worries. So in our contract with you, what we do is we guarantee you 80% life of that battery, and we think that'll be maybe at year 6 or 7. It could be beyond that. Nobody really knows yet. But we're going to guarantee for 12 years the life of that battery, okay, and an 80% state of charge. So as we go through this model with you, and we do have a note in here. This is a U.S., excuse me for putting it in here, but the FTA does have a FAST Act piece of legislation that allows for leasing of batteries. They didn't do that 5 years ago. So I think they had the foresight to understand we need more programs around funding. On the battery lease program, let me walk you through this. So if you take the price of a diesel bus and the price of an electric bus, and again, it's the same model. When you go to the right, you'll see your payment for the batteries is $45,000. And you go, well, gee, that sounds like a lot of money. You're still saving $9,000 in this model. Correct, Alan? Every year. Yep. Every year. So what we're going to do is take that and we're going to expand this out over the entire life of the vehicle. Okay? On a capital lease, you say, well, can you finance the entire bus? We can. And that sounds unusual in transit, but we can finance the entire vehicle for you. In this particular model, you're going to save $11,000 on the vehicle, which is $138,000 over the life of the bus. Now, this is the big one. So all that sounds great. The bus, the batteries, but what about this infrastructure we've been talking about all day? The cost of the infrastructure. Why don't we just get the utilities to pay for all of it, right? We'd love for that to happen, but in reality, we have to find a way to finance the infrastructure. And so in our model, we can do that. So this is really interesting in this slide. I want to point this out. The blue that you see, that is diesel fuel. But someone, somewhere down the line, put in that diesel fueling station. They put in infrastructure. They ran lines. They put in pumps, right? We don't take that in consideration in this model. All we're taking into consideration is fuel. If you look to the right, 20% is all you will pay for electricity versus diesel. It's a huge savings. 40% will be us financing over 12 years the infrastructure for you. So we will do all the infrastructure and the charging, and at the end of that 12 years, you own it. It's yours. And you can see the significant cost in doing that model with us. Okay? Any questions? This is I know it's the last one and you guys are ready to go, but does anyone have any questions on these, three ways of financing these, the bus, the batteries, and the entire vehicle? Let me go back before I hit my punchline.
About the leasing. So since the battery is a key part of the lease, and you're looking at the way the battery charge diminishes over time, and that's related to how the batteries are charged over time. So I guess, in essence, what I'm asking is, are there conditions on the lease that would need to be documented and satisfied in terms of the way an agency basically treats the batteries?
Well, we're going to know how you're treating the batteries through our telematics because we look at it all day long. We're watching and seeing exactly what you're doing, but that is.
I'd
go
also
ahead,
add,
Alan.
we build it so that it'd be very difficult to override the way you treat the batteries. I mean, there's certainly the amount of throughput you use on it, but that's built into it. So you'll be okay.
And this is
I basically meant that the agency would want to know up front, I guess, whatever the conditions
it's all built
would
into
be.
that.
It's an excellent question because we have a customer at the Port Authority in New York, which is the 3 airports in New York City, and they're buying buses and they're leasing the batteries. And they said, we outsource the service. So we own the bus, we own the chargers, but we have an operator, a private company that comes in and operates them. What if they abuse the batteries? That's all built into the lease. So they're protected from that. That's a really good question. Anybody else? I got the expert with me. And we're happy to come down and sit down at your property, talk to you about these options. They're very unique to the industry. I think the industry needs to look at more financing options. And the last item, we heard this word a few times today, called P3. But I will tell you, Proterra is engaged in P3s already. And they are major, major projects that we have underway. And we would love to sit down to talk to you about how we help you finance through a P3 program, which would be a project company. And this is a really good, nice, tight slide on how this works. You have equity members, you have lenders, and then, of course, you have Proterra. And the biggest item I want to point out in this slide is it takes away all your risk. You pay as you go. This is based on performance. If the bus is running, then you make a payment. It takes all the risk away. It's a really, really good program that you should be taking a look at with us. Now, I know we're going to get a question probably when I come off the stage. It says, hey, tell me who you're working with. There's what's called an unsolicited proposal process that many properties have, many cities have. So in other words, we've submitted a proposal and they didn't ask us for it. We just did it because we knew there was a need in that city. And we can't talk about those until that city announces that we're under a P3. Did I say that right?
Well, yes, right. However, they asked us to put a proposal in, so we're in the process of going through that process with them. But we've looked at it and done the same thing with other properties as well, and we'd be happy to talk with you about the process for anyone in Canada. In fact, Canada, I think, has been much more progressive in the use of the P3 approach.
Yeah, the U.S., there's only been 3 P3s ever done.
For transit.
Transit. So don't get down on yourself. This is a great concept. Somebody needs to make that move, okay? So we still have a few minutes left. I can't believe I got us out of here fast. No hook. No hook. I thought you'd be standing behind me. Anyone have any other questions? I really appreciate the opportunity to get up here. Proterra loves being here in Canada with the deployments that we have. We have information back on our table. If you want detailed specs, they're all there. You can answer questions. We'll be here tomorrow if you've got any further questions, but I really appreciate it. Thank you. Oh, no, what is it? Oh, cool. Thank you. Take a look at things. That's great.
Okay, well, that concludes our formal proceedings for today. In terms of logistics, we do have a reception upstairs from 5 o'clock till 5:45, and Josipa will introduce that in a minute. It's on the 13th floor. For those of you who were here last night, you were up there, the 13th floor terrace. And then at 5:45, we'll return back downstairs to this room for a formal sit-down networking dinner. And I will turn to Josipa to conclude.
All right. Well, we did say to a few people, come on out to the conference. It's like a university in one day. Everything you want to know about electric buses, but we're afraid to ask. So hopefully we were able to share some of that really detailed information with you, but also some of the global messages. And just to take us back a few hours, we started this day talking about low carbon smart mobility, trying to pass the parental test, trying to get mobility in Canada to be faster, cheaper, greener, and just better for two parents with two kids. And I hope 2 years from now, I'll be back sharing with you examples where we were able to move Canadians in ways that made them richer and happier and added to their lives. Now, I do think moving 3 kids and 1 parent, which is the true test of mobility and how accessible our mobility is, that's going to take us a few more years. But let's at least try to aim for the 2 parents, 2 kids, passing the parental test in low carbon smart mobility. We also talked about, in order to get there, taking responsibility for our generation. And frankly, I think it's fair to say, we do not want to be waiting around asking our kids for forgiveness. And frankly, they shouldn't give it to us. If we find ourselves in that circumstance, we've got way too many brains in this room, way too much capacity, way too many manufacturers and integrators to have the excuse of laziness or inaction or political lack of will. We've got everything going for us. And so with that, I certainly want to thank you for taking the time to be part of what we consider to be the first step in a movement towards a low-carbon, smart, mobile Canadian landscape. It took us 4.5 years to get here, but we'll watch out for the next 5 years because we've got a lot of things planned. Et merci beaucoup à tout le monde qui sont venus ici. Je suis désolée que j'ai pas utilisé la belle langue française pour introduire notre conférence que nous avons commencé ce matin. Mais merci beaucoup. La prochaine année, il y avait déjà des efforts d'avoir cette conférence à Montréal. Donc, on va voir si ça va arriver. Il y a aussi cette pression d'avoir la conférence à Vancouver. Donc, ça sera un grand débat de 3 coins du Canada parce que c'est vraiment une bonne démonstration que tout le monde, maintenant, toutes les provinces sont vraiment intégrées dans le débat pour la mobilité, pour les Canadiens, pour le futur. So thank you very much. I'm going to do my part in taking responsibility. I'm going to find out where Doug Ford has his coffee, and Brian Pallister and I are about to become best friends. And whoever ends up in Ottawa, we're going to get to know each other really well, too. With that, thank you so much, everybody. People are people. Politicians are people. We can convince them if we keep saying the same message over and over. So I welcome you to repeat those messages. Low carbon, smart mobility for all Canadians in the 21st century. Thank you for a great first day.